In a previous video, I have explained why you have to learn infrastructure as code and specifically Terraform, because it's leading the crowd when it comes to automation of infrastructure provisioning, and it can work on different clouds, and it can work on premises in your own data center as well. And the link to the video is above my head right now somewhere. So please watch that video if you are skeptical or you don't know what Terraform is all about. This video is going to give you the details about Terraform, and it will get you to a very sweet spot in knowing about Terraform, whether you are going to use it or you just need to learn what is happening in infrastructure automation. So please stay tuned, subscribe to the channel, activate the notification to receive videos like this one, and also please consider giving us a thumbs up if you benefit from the video so it can reach more people. Please be aware that this is not for freshers. It assumes that you have some background knowledge in AWS. We are going to focus on AWS, but the same knowledge applies if you are going to apply it on Azure or Google Cloud or even on premises. So we are going to take you through that journey, assuming that you have the AWS knowledge. If not, please do let me know. And I'm going to post an AWS beginners video that will get you going so you can learn Terraform without any hardship, even if you are a complete fresher with no prior knowledge in cloud or in Terraform. All right, so stay tuned, and I'm going to see you in a bit. Infrastructure as code allows IT professionals to control the provisioning, the creation, updates, and the life cycle of resources and infrastructures in the cloud or on premises by using code. Terraform is the most popular infrastructure as code tool across the globe because it's open source and it supports a lot of different cloud providers and even on-premises technology providers as well. And analysts predict that infrastructure as code global revenue is going to grow by 24% every year to reach $2.3 billion by 2027. That reflects on jobs, and the skills are going to be in demand. So learning Terraform and learning infrastructure as code is a must and a skill that every IT professional has to have today. My name is Isa Abu Sharif, and I'm going to be the instructor in this course. I am an expert on the Terraform side and on the AWS side. For the past 8-9 years, I have been well versed with AWS, and so many times I have created infrastructure like the one that you see right now, which takes a considerable time when you want to build it manually and tear it down manually as well. And the next time I needed it again, I had to rebuild it again. It's a nightmare. And it's a pity when you see that this infrastructure is being torn down because you don't need it anymore and you want to save money. And that's the very reason why I created this course, to help you learn Terraform and avoid wasting effort and time building and tearing down infrastructures in a manual fashion. So let me introduce you to the concept of infrastructure as code, abbreviated IaC, and also that will help us get into what Terraform is and what it can help us with. So let's go ahead. So what is infrastructure as code? Before we get into any boring text, let's think about it. What if we could learn a way of coding or scripting where we can build some configuration or a script or a template, if you will, that defines some resources that I need to create? And it could be firewalls, routers, virtual machines, servers, Linux or Windows virtual machines that I need to create maybe on premises in my data center, so locally in my network, or it could be in the cloud. And the cloud could be AWS, can be Azure, can be Alibaba Cloud, can be Google, can be any cloud. So wouldn't it be nice to be able to define my infrastructure as code? And hopefully that code is also, or the syntax is simple to learn. And then we can pass it into a tool, an infrastructure as code tool that can look at my template or my configuration script, and it can validate the syntax, can find out if I have written it in the right way or wrong, and then it can go ahead and understand where this should be configured. So there should be some intelligence within the tool to find out, is this related to AWS? Is it related to on-premises network? Is it related to Google? Is it related to Azure, to a different provider? what is the destination where I should create that resource from or on, or it could be just a local thing that I can do on my local machine. So regardless what it is, it has to be intelligent enough to detect and understand what you are trying to accomplish, what is the desired state that you need, what's the configuration that needs to be implemented, and then it will go ahead to the right destination and then implement that. Not only this, but it will also read information about what was created, and if you have written it to do so, it will provide you with information about which are the resources, the resource IDs, the subnets, the IP addresses, the instance IDs, whatever the resources were that you wanted to create, it will also provide you information on them. And each time from that point onwards, it's going to maintain the state of the deployed infrastructure. So every time you make a slight or a major change to your code and you try to apply it, it will first refresh, read the state again, find out the differences between what you are trying to accomplish and the current state on the infrastructure, decide on the differences, what resources are going to be changed, what resources are going to be deleted, and what new resources need to be created based on your updated script. And then it will go ahead and do it, and again read the state and maintain the state. Wouldn't it be wonderful if we can do this? And it would be amazing if I can get this code and then upload it to a version control system, Bitbucket, GitHub, AWS code commit, whatever the repository for that code would be, and then I can enable version control so I can maintain versioning and we can roll back to a specific version that we know is stable if we run into issues, or just continue maintaining different versions, and then with comments highlighting what is the difference between this version and the previous ones and so on. That would be amazing to do. What's the alternative? The alternative is the manual way. We need to create a virtual machine on AWS. What do? We go into what we call the AWS console, and then EC2 or virtual machines is a service called EC2 in AWS. I can type it here if you haven't used AWS console before. And now I have anything that starts with EC2. I know that it's called EC2. So this is not something that you would guess. That's why we said for the prerequisites, you need to be familiar with AWS. So I go into EC2. That's the manual way, which could be susceptible to errors, which can cause problems, which can take time. You may overlook something. You may create an instance and then realize there were some arguments I did not add. Now I have to go ahead and delete it. All of that needs to be done manually. So we'll go into instances. I'm going to launch an instance. Now I am in the page which I need to be familiar with these parameters in order to be able to launch the instance. I need to provide it a name, so web1 for example, and then I need to choose the operating system or the image, the Amazon machine image. I need to be familiar with that. That's basically at a minimum the operating system that is going to run on your instance, Linux, Windows, Red Hat, and so on. These are all options. Let's say I'm going to go with Amazon Linux for now. Then which Linux do you need? I have multiple versions. Then I need to specify which one. Hopefully it is this one. It's free tier eligible, so we don't have to pay money. Then the architecture. What architecture do you need? What's the instance size? So all of these are things I have to go through and start using manually, which is fine if it is one instance. I mean, I don't mind. It will take me a few minutes. I need to access the instance. So I will create a key, and let's say I'm going to call it Terraform 1. Then I'm going to create the key. Then I need to do the network settings, which VPC the instance is going, or the virtual machine will be created on, which subnet. Maybe I need to pick a subnet. And then do I need to assign a public IP address so it will be accessible from the internet, or no? Let's do a public one. And then do you need to create a new security group, or are you going to use an existing one? So I need to specify if it is an existing one, which one. Let's say I'm going to get the default. And then what size of the EBS volume or the disk drive that is going to be on the instance. Do you need to provide any additional details to the instance? So after doing all of this, and I have to review it, make sure that everything is right, then I can go ahead and launch the instance, which is fine. I mean, It took me maybe 2-3 minutes with you. That's fine. 2 minutes, 1.5 minutes. Maybe if I do it 1,000 times, I'll be able to do it in 15 seconds. But think about it. What if you need to do the same thing every day 4 or 5 times for the same instance, for the same configuration, for exactly the same parameters, but you need to do it again and again and again? You'll get bored. Maybe you'll do errors, and you are just wasting time. Let's say you're going to get to a very good and very fast speed where you can do it in 30 seconds. Within a year, the same thing, you are going to do it 1,000 times. You are the cloud engineer and all the developers love you and they trust you, and they would say, John, why don't you create this for us, that for us, tear this one down, add one more instance, remove this, add that, change this, change that. We have a problem, find out what's going on and all that. Why the instance did not boot up. I tried to do it, but it didn't work out. Can you help me and all that? So if you calculate half a minute times 1,000, that's 500 minutes. That is close to maybe 9 hours, 8.5 hours of work on one resource. What if you are doing other resources repeatedly? Then it's a lot of wasted time. So now we have an instance that is running, life is good, everything is cool, and then I have it, it's running and all that, and it's got the instance summary, the details. Here's an instance ID I have, and here's a public IP address on the internet, and here's a private IP address, and here's the DNS host name, and a lot of information about the instance that it has taken and all that, which is great. I do have it right now. Now, let's say someone sneaks, and when the instance is here and you didn't notice it, but somebody got in and he said, you know what, I want to add a new tag. And the new tag is going to be environment, and the environment is production. Now I'm assuming that someone else is playing with your instance and you don't know. And save. So now we have it. Next time you visit the console and you look at the instance, it's running, everything is cool. But someone has changed a parameter and you didn't pay attention, because if I look here, unless I click on tags, I suspect a change, or I need to create a new tag or a label to the instance, and then I go here, I wouldn't know that somebody has changed it. This is not a tab that we visit every day. Usually we set it, maybe we add it or modify it once in a blue moon, but we don't do it every day. So is there a way I could be notified about such manual changes that have been done? Unfortunately not. I mean, this is not something, or maybe you can build a lot of automation to detect things like that. Is there a way I can build a script with the information I needed for the instance, and I do it once? I test it, I make sure it works perfectly, and then that's it. Every time I need to run the same configuration, I will just execute or run that code, and it goes to AWS, it does all the magic, it maintains the state, so it pulls the information, it refreshes the state, and it can detect any drifts in the configuration, anything that someone has created in the configuration. And then it will maintain that state. The next time I need to make a change, it will say, okay, fine, but here was a drift, so I'm going to reverse that drift, because it was not supposed to be there. It's going to take it back to the original state, and it's going to apply whatever changes that you wanted in the desired state in your new configuration. That would be awesome, epic, because let's say I'm going to spend 10 minutes to work on it if I know Terraform, 5 minutes, but then after I do this, then I have all the access to the same script, which I can use repeatedly, and I don't need to worry about anything. I don't need to click on anything, or I forgot my password. What was the password for the console? What was my username? I haven't used it for. You don't need to go through all of this. And let's demo that, because that's the taste of what Terraform can do for you, which cannot be done manually. So here's a small configuration, just to give you the taste. And you don't need to worry about the details. I'm going to get in, this is VS Code, and I'm going to get, and here, open the prompt, and I'm going to type a command, Terraform init. Please initialize my working directory. So now we have a working directory. It's going to initialize it. To do what? It will detect that I need to work with AWS. Found that from here, from the provider. Now it knows which region I need to work with, and it has the permissions and authorizations to work with AWS on my behalf in my account. So what is the other 3 lines? I want to create a resource of type AWS instance, that's EC2. I'm going to call it a name that I have chosen, my EC2 public. I could call it Ruby, I could call it Joan, Jason, I could call it web instance. It's up to me, but the type, I have to be specific about the type. And then I'm going to provide the AMI. I need to make sure that in the region where I'm going to work, this AMI is available. And I'm going to provide the instance type. Let's do one thing. Let's do a command, Terraform apply. Now it's asking me, are you sure you want to implement this? Yes, I want to. And guess what? Now it has gone ahead and it's creating an instance with this name on the infrastructure. It is following up on what's happening and it's giving me updates. It is still creating. 20 seconds, another update. And guess what? I have one resource completed, it's added, and nothing has been changed, nothing has been destroyed. Well, it's too good to be true. Let's go ahead and find out if this happened. So let's update. And guess what? I have here another instance, and it is running. It is initializing at the moment. And if I click on this, we'll find out that it has taken a public IP address, has the DNS, has the instance ID and everything. Yeah, but how can I verify that this is the one that you created? Well, there is a way to find out. Let's find out. So this ends, the instance ID ends with 7A16. Now, if we go back and here we click on this file and I scroll a little bit down, you'll find that it's going to tell me an instance ID. We're going to scroll down to find out the instance ID, and here we go. It's 7A16. So it's exactly the same one that I have created, and it is of type T2 micro as I suggested, and life is good. So I didn't have to go to the console, no, and its name is EC2, my EC2 public. I didn't have to go anywhere. This is the instance that you created. You didn't even log into the console. You don't have to jump between parameters or anything. It's all about the 2 lines that you have provided. Of course, you can add more attributes to the configuration, but that's it. That's all about it. Let me just go ahead and delete the initial instance because I don't need it anymore. So I'll have to go here and I'm going to go to the one that I created manually. And I wish I had a state like that can manage it, but that's fine. I'm just going to terminate this instance. Now, how about the other one? This one. Well, you can go ahead and terminate it from here, or better off, since it's managed by Terraform, why don't you go into Terraform and then type Terraform destroy. And then it will ask me, are you sure that you want to destroy it? And it, as you can see here, it has refreshed the state first to find out what's going on. It had highlighted that there is 0 to add, 0 to change, there is 1 to destroy. Are you sure you want to destroy? And I'm going to say yes, please go ahead. And it is now destroying the same EC2 instance. I didn't specify, if you noticed, I didn't specify anything about, let me just bring this one up. I didn't specify anything about what do I need to destroy. But since it is managing that and it knows in the TF state what exactly has been created and all the configuration parameters about it and what's the ID, what's the IP address, what's the instance type and so on, then it does understand easily that I want to destroy what you created and you are managing. And if we scroll down, it gives me updates. I'm trying to destroy this resource ID and this time has lapsed and it's still working. And now it gives me an okay. It has heard from AWS that it was destroyed. And it's too good to be true. Okay, let's find out. I'm going to update, refresh. And here is an instance, 7A16, and it has been terminated. So this is the power of infrastructure as code. Spend some time, build the script, test it. It's like a programming language. It's going to have errors, fix the errors, test it again. Now it works perfect like it was supposed to. Keep it, reuse it, and then it's portable as well. So you can send it to someone else, or you can from your own workstation work with multiple regions in AWS, or work with AWS, Azure, and Google through the same configuration file in parallel with no issues whatsoever. You're done with one resource, or you don't want the resources or the infrastructure anymore, the project has ended, fine, destroy, we are done. Maintain the state. Someone goes behind the scenes and tries to change anything, then you know about it. That's the power of infrastructure as code. Hopefully that was clear. So let's go back to the slides and quickly find out what is infrastructure as code. And as we have seen, it's the management of our infrastructure, whether it is networks, virtual machines, load balancers, or whatever it is, in a descriptive model using configuration files. And we have seen an example, a simple one that had showed us or proved to us that we can be much smarter, much faster, and much more efficient when we deal with code that is tested, and that will be how we create our infrastructure. And of course, since it's code, then we can use versioning to maintain that and to maintain the versions of that one. Please remember that infrastructure as code tools, they can work on premises and they can work in the cloud. They can work with one provider or multiple providers at the same time. Now let's look at the benefits. How would I benefit from what we have seen? First thing is speed. Definitely, if we're automating things, is much better than doing things manually. Even if the script takes a little bit of time to build, it's going to be reused, and it's definitely going to end up with less errors and going to end up with much faster results. And consistency. As we talked about, it's the same file, so it will generate the same output every time. When we shorten or when we lessen the time taken to do troubleshooting for errors that have been done manually, and also the time that has been repeatedly used the same time to build the same resources again and again and again, definitely when we shorten that, then the time spent from the FTEs, from the full-time employees on this is going to be less, which means the cost of troubleshooting and the time for troubleshooting and time for configuration is less. That is lower costs. Reusability, it's clear. Now we can collaborate, we can share that with other teams in the corporate, and they can be using this. We can also build modules. So this is for an EC2 instance. That's the perfect configuration for an EC2 instance. Hey guys, anyone who wants to create an EC2 instance, please use this file. I'm going to upload it in a shared repo that everyone can access. And same thing for security groups, for VPCs, for virtual machines, and this and that. So reusability is a good thing because a team, a smaller team, will build things that everyone else can use, which is perfect. Security. Since it is script, we have tools that can scan or can do sanity checks from a security perspective on the code to make sure that everything is good. We have not embedded any passwords. We have not included any credentials or any TLS certificates or anything in our code, and that is going to follow the best practices. So we can do this. Documentation and version control. It's all about VCS, version control systems, where we can upload our configurations. We can have a README file that explains everything about it, and also what files to use, what modules to use, what are the different variables, and so on. So now it's not about Joan, why don't you create for me an EC2 instance with this and this and this and put it in that VPC into that subnet and all that, and then Joan gets confused and builds it in the wrong VPC on the wrong subnet and so on. The ability to roll back on error. If there is an error, I could choose and say, you know what, I want to roll back. Or Terraform will automatically abort and give me an error. It was not done because of this. And then the ability to manage the infrastructure and to detect any drifts, any changes that have not been done using Terraform. They may have been done manually or however. It doesn't matter as long as Terraform can detect it and find out and can reverse the changes we need. That's why when you use an infrastructure as code tool, Terraform is the best one of them so far. So if you use that, then please manage everything from the infrastructure as code tool and don't mix a little bit of manual, a little bit of automated, and then it's going to be a mess. Example tools that can do infrastructure as code, of course, HashiCorp Terraform. In addition to being very easy to understand, very easy to master and all that, it is vendor or platform agnostic. It can be used on any cloud platform, it can be used on premises without any issues. AWS CloudFormation is only for AWS resources. Then we have one on Azure, only for Azure resources, Azure RM or the Resource Manager. We have one on Google, that is the Google Deployment Manager, also only for Google. And we have a library in Python called Pulumi. Again, it's platform and vendor agnostic. And we have OpenTofu, which is now competing, or a lot of advices to migrate from Terraform to OpenTofu because HashiCorp has been bought by IBM, and IBM moved it from an open source license into a business source license. So there is a cost associated with it. So a group of those who supported Terraform, now they have the OpenTofu, and it's a Linux Foundation project. And again, it's platform and vendor agnostic. Right now, Terraform is number one. God knows in a few years what will happen. Maybe it will change. So let's do a quick Terraform overview. So Terraform, it's an infrastructure as code tool for building, changing, versioning infrastructure safely and efficiently. And we have just seen the introduction of that in the previous example. It is a provisioning declarative tool. So we create the scripts or the configuration files following the infrastructure as code paradigm, and that's how we create and manage and destroy configurations using Terraform. So what we do is in our code, we define what we call the desired state, what we need the final outcome to be, and Terraform will work to ensure that that desired state is maintained. So it can detect drifts, as we mentioned before. And it will allow customers to define the infrastructure through repeatable and reusable templates, as we mentioned earlier. And it is built and maintained by a company called HashiCorp. And the templates that we build will follow the HCL or the HashiCorp configuration language. So it's not written in any code. We have to know how to write it. And as we go through the course, you will find out it's very easy to learn. So what are the goals of infrastructure as code, or Terraform specifically here? We need to unify the view of resources using infrastructure code. What does that mean? That means we have a script, we have the template, and we are going to deploy the template, but then we need to maintain the state. We need to find the view of the current view of the state and the resources and all their parameters and all that, as we have seen briefly, and we'll see a lot more in the coming examples. We need to automate and track infrastructure changes. So this is also why Terraform is built. We need to support the modern and agile elastic data center, which is the core of the cloud. And that is infrastructure as a service, platform as a service, and software as a service. Not relevant to our discussion here, but anyone who touched on the cloud will know what this means. And we need to enable collaboration for the team. And that's why Terraform has to expose a way to allow the team individuals to safely change infrastructure using the code that they can work on and they can collaborate on. We need to provide IaC workflows that are technology agnostic. And the meaning here is I can work with Terraform even in the same configuration file. I can have a portion for AWS, a portion that will be for Azure, and a portion that will be for Google, and maybe things that will happen on my machine and things will happen on premises. So all of that can be done in different scripts or in the same main file or the configuration file. And we need to standardize configuration and API calls to the different providers to manage everything. So now we don't have to log in to any console. You don't have to go manually on any platform. Now you are on your machine or maybe on the cloud using Terraform Cloud, and that's how you're going to build your scripts and you will deploy them. So it's all about API calls. What do we mean by API calls? On my laptop, as we have seen, I had a file and I was able to push that file to AWS Cloud, and AWS Cloud understood that I wanted to create an EC2 instance. So that means I had an API call sent to a service endpoint, which is the EC2 service endpoint or URL. It was read and it was authenticated, and they found out that whoever sent this API call had the right permissions on a specific account, and they found out that it is authorized to do that action, and that's how we created an EC2 instance in my account. So now it's all about what? It's all about API calls. But now the question is, if we had the template file and it was done correctly, transformed correctly into an API call, which is an HTTPS call, and it was understood by AWS. So who did the translation between the HashiCorp language, or the HCL, which was in my file, and the HTTPS write format for the API call that AWS understood? This is what we'll learn in the next section. So there is a component that understands the HCL that you write, and it can validate the syntax and its correctness, and then it can understand who is the provider, and then it can translate whatever you have written into what the provider, the right API format, depending on the provider's API documentation, to tell the provider, I need to create this resource. So the provider will also validate the syntax and find out, yep, this looks like a legit API call. Let me find out if the sender is authenticated, if we know who the sender is. And then let's find out if the sender that we identified is authorized to do the action. So the translation happens through a component in Terraform that is called the plugins, and we are going to learn about that later on in the course. So to summarize from what we have learned, Terraform benefits, what are they? And there will be some repetition here, okay? So we can define infrastructure as code, which will enable customers to build and rebuild and change and track infrastructures with ease. And also, it will allow the customers to manage infrastructure on multiple cloud platforms simultaneously through one file or multiple files. And it is a human readable configuration language. As you will see, you will understand it. When you read it, you will understand it. It's not complicated. And it can be combined, of course, with version control systems like GitHub or Bitbucket for version control. And it is platform agnostic. It is not made by AWS, so it's not specific or proprietary to AWS or Azure or Google Cloud. It has a big support community. HashiCorp was established in 2014, so now they are many years in business, and it was launched for these many years, at least for the first 10 years, as an open source. And that's why there was a lot of contribution from the community to add modules, to add configurations, to define resources, to write code, and also to support each other. And it is very fast and exceptionally efficient, and we'll see that through the examples and the rest of the videos and the course. And the customers can validate their changes. So it gives me the opportunity to do a planning first before I execute, and then I can read, and based on that I can validate, yeah, this is what was intended, and then I can go ahead and apply it or execute the changes. So let's look at installing Terraform on your machine. Terraform supports many platforms, including Mac devices, Linux devices, and Windows devices. So you can install it in any one of these operating systems. And it can be downloaded from this URL, developer.hashicorp.com/terraform/install. So let's go ahead and visit this website. So here's the website and installing Terraform. Here you have the Mac OS, and then you have the Windows, and then you have the Linux, FreeBSD, OpenBSD, Solaris, and a lot of other operating systems. So if you are running Windows, unlike me, I'm running Mac OS, then what you need to do is you need to find out, is your machine 386 compatible, the hardware, or AMD? And then click on download, and then follow the steps to run that, and we'll show you a video that will show you exactly what you need to do in the Windows. If you are running Mac OS, then what you need to do is you need to follow these two commands, the brew tab, HashiCorp tab, and then the brew install. These two commands are going to be what you need to do. So let me go ahead and do this. So we can follow the commands. And here is the first one. I have it installed. Okay, so I had two outdated stuff that were installed, and then I need the second command, and I'm going to type it here and install HashiCorp Terraform. And as you can see, I had an older version, and now I have a newer version of Terraform. So now everything looks fine. And if I do Terraform -version, then I'll find out that I have this version installed right now. So thank you, you have helped me to do the upgrade. So this is on Mac OS. It's going to be the exact 2 steps, and you should be good to go. So this is for Mac OS. If you were on Linux, you will need to follow these commands, and it's going to work perfectly. Don't worry about that. If you are on Windows, then you need to download this and then double click and zip the file and then do the executable, and it's going to run. All right. Our next step would be to install visualstudio.com or the VS Code. You need to download that into your machine because we are going to run all our code on VS Code. If you have another IDE that you would like to use, it's up to you. But if this one is good enough, then let's go ahead and do this one for you. Right, so again, available for Windows, available for Linux, depending on which one you're going to use, and then available for Mac as well. So I did download mine, which is the Mac one, and it works. It's very easy to install, so just follow the steps and you should be good to go. Once it is installed, it's very important that you need to go and to click on or extensions, and then you need to find the HashiCorp one. So you need the one that is done and certified by HashiCorp. And this plugin is very important because this is what you need in order to make sure that your VS Code understands Terraform and it can give you the support that you need to do this. And if I click on this, you'll find here, in my case, it is installed and enabled. So now I can uninstall or I can disable. In your case, it's going to be install. And then once it's installed, you need to make sure that it is enabled. So if you click on it again, it will show exactly like this. And again, I'm going to show you a video of how you can do this without any audio because it has been recorded earlier before the installation. So you can go ahead and do it yourself. Very straightforward, very easy. But then once you have that, then you are ready to rock and roll with me during the course. All right. So please go ahead, do the Terraform installation on Windows if you have a Windows machine, on Linux if you are a Linux machine, or on Mac if you have a Mac machine. Then do the VS Code depending on your operating system, and then add the extension, and you should be good to go once you have all of this done. Now let's jump into your laptop and find out what are the components that make up Terraform. Who is the translator that will understand the script and then translate that into the right provider? Also, what if I need to execute something locally? What happens? Then let's jump in and find this block diagram that shows what actually happens in Terraform. So you have now Terraform on your laptop. That's the program itself. This is referenced as Terraform core. Then we have a provider. This is the translator that we talked about, and the translator communicates with your code. So basically, the code through Terraform is going to be sent to an internal software component in Terraform called the provider that is going to translate that. Let's say if I'm talking about AWS, then it will be the AWS provider that is going to translate the script into API calls to be executed on AWS. If it was Azure, then it will be a different provider, not the same. If it was Google Cloud, it will be a third provider. If it was TLS to just generate some certificates and keys, it's going to be a TLS provider. So it's going to be the destination platform or software, even on the local machine, that needs to communicate with in order to execute the script that we intended. So we write the code, and then we do the planning, the rehearsal, the dry run without execution to find out if this is exactly what we wanted. Then we decide, yes, it is. Then let's go ahead and execute it, apply it. And that will send API calls, and then the final execution happens on the intended provider. So Terraform creates and manages resources on cloud platform using their APIs. So at the end of the day, it's always API calls that will go out of your laptop if the provider is outside your laptop, on the cloud, on premises, and an API call, and this is how Terraform communicates with the surrounding providers to create, delete, change, and manage your infrastructures. Providers will enable Terraform, the translator, to work with virtually any platform or service with an accessible API, provided that there is a software provider already built for that platform. So HashiCorp and Terraform community over almost 10 years or more than 10 years now, they have already written thousands of providers. So AWS is one, Google is one, Azure is one. We're talking about thousands of other providers, not only these cloud providers, to manage any different types of resources and services provided by these entities or platforms or providers. So what are the internal components now? Now, this is the dashed line highlights your laptop. So this is your laptop or your machine or the HashiCorp cloud where the Terraform exists. What are the components? We have the actual Golang written code, which is the Terraform core. That's the binary executable file that is on your machine. But there are other components, again, written in whatever languages, and that will include the providers. We talked about what that is. And then we have something called provisioners, but both of them, they are categorized as plugins. So the Terraform core will communicate with plugins through remote procedure call. So it is a well-known standardized communication protocol. And then we have the provider will translate what needs to be done, or the provisioners will translate what needs to be done exactly into API calls through the client library. And then this will go out through HTTPS secure HTTP as an API call to the destination platform where it should be implemented. So let's dive deep and find out what is the Terraform core and what are the Terraform plugins, the providers, and provisioners. So remember, this is now inside your laptop. So the Terraform core, this component, it will use the RPC, remote procedure call, to communicate with the plugins and offers multiple ways to do what? To discover and load the required plugins to use. So the Terraform core, when you have AWS configuration in your script, it will identify that, you know what, I need now to download the AWS provider plugin into the machine, so the machine will be able to communicate. So these providers, they could be half a gig, they could be 400, 600, 800, 1 gig. So it's a big file that will be downloaded when you need to run it, and that's part of the initialization. And Terraform core is intelligent enough to find out who is the provider and then identify what plugins I need to download to execute the specific script at hand. Terraform, what is it? It's a statically compiled binary written in the Go programming language. So Terraform is written in Go like Kubernetes and other tools that we use today. The compiled library is actually the CLI that you have on your laptop, and this is the entry point for you to work with Terraform. Be it on a Windows machine, on a Linux machine, on a Mac OS machine, it is a CLI tool that you need to use with commands. So what are the primary responsibilities for the Terraform core? It includes the infrastructure as code component. So it will read and interpolate configuration files and modules. It's going to read, consume, and understand, comprehend, validate your syntax. And then it's going to communicate with the plugins to execute that. And then resource state management. It will maintain the state. And also, we'll learn about this later on. It will show the dependencies and the relation between the different resources, if any. And then it will do the dry run, the plan, and then the apply part, which is the execution. And also it will communicate with the plugins with the respective plugin. You need to create an EC2 instance on AWS. It will communicate with the AWS provider plugin. You need to execute something on your local machine. It will execute with one of the provisioners on your local machine, and so on. Terraform plugins are also written in Go, and as we mentioned, plugins, they could be providers and they could be provisioners. If I need to execute a bash script Am I going to use a plugin for that? No, it will be a provisioner. If I want to create something on AWS, it will be a provider. So who decides whether it is a provider or provisioner? The script that you have written, Terraform will know exactly what you need to do, and either it's going to download a provider or a provisioner for what you need to do. Basically, that's the simplest way to put this. Plugins expose an implementation for a specific service. So it could be an AWS provider plugin for AWS. It could be a provisioner plugin for Bash. So it all depends on what you have in your code. Then each one of these plugins will expose an implementation for a specific provider or a specific provisioner. It's not going to be one plugin that combines Google and Azure and Bash and AWS and so on. So the plugins are executed as separate processes, and they will communicate with the main Terraform core over RPC, as we mentioned. So when you have AWS and you have Azure and you have Google and so on, they are going to be different providers, different software processes that are going to be running, and they do communicate back and forth with your Terraform core through RPC. Same thing for the provisioners. The Terraform plugins are responsible for the domain-specific implementation of their type, and I think we have mentioned that already. One provider plugin or one provisioner plugin for a service. So if we look at the provider plugins, what are the main responsibilities for this? Initialization of any included libraries to make API calls. So getting ready to initialize all what needs to communicate with AWS. So I'm ready now to expect any AWS related script and then go ahead and do the API calls for AWS. Also, if you would like to communicate with API calls with AWS, who is going to authenticate and authorize? Who's going to tell AWS that this is John Smith and this is account such and such in AWS? Then who's going to handle that authentication? Also the provider plugin. And it makes sense. It doesn't make sense to have all the authentication on earth in the Terraform core where I have an AWS provider and an Azure provider and so on. So it makes more sense to push anything that has to do with that provider and authentication into the provider itself plugin and not into the core. It also defines resources that will map to different services on the providers. Now let's look at the provisioner plugins. What is the provisioner plugin? And I mentioned an example as Bash. So the responsibility for the provision plugins is to run commands either on the local machine or on the resource after it is created or upon the destruction of the resource. And as we mentioned, an example for that would be Bash script. I need to start an EC2, a virtual machine on AWS. Then after it is created, Terraform will know it is created, and now I have a Bash script that I need to execute on that instance. I will define it as a provisioner, and then Terraform will go ahead and start deploying that on the EC2 instance. And for that to happen, it has to connect to the instance. One of the ways is SSH. So we'll see examples later on how we define the provisioners and how they can connect via SSH into the EC2 instance and then execute as if it is a human being typing commands on the machine after it is created. And there are many ways to do that, but let's not elaborate further on this. All right, so let's go ahead and start a new section, which is the Terraform fundamentals. Let's start with the Terraform configuration files, the scripts that we write basically. So Terraform files, they end with the extension .tf files or tf.json file. So the extension of the file is this, and that's how VS Code will find out this is a Terraform file. Let's demonstrate that and you will see it on VS Code. So let's even start a new folder, and I'm going to write test1, for example. I'm going to start a file and I'm going to write the file as test. Okay, so here now it shows as a text file. But if I go ahead and I rename the file and then I add the extension tf, did you see what happened? If I remove the f, then on the left hand side it doesn't show anything. But if I type f, then immediately you will see that the Terraform label or logo has showed here, which means now it is recognized because of the extension that we have installed, and the .tf, it shows that this is a Terraform file right now. And the example that we have seen before, this example, this is a Terraform syntax in a Terraform file. So now it is identified by VS Code as a Terraform file. Each Terraform file has one or more blocks. So if we look at this snippet from a Terraform file, here I have different blocks. So this is one block, and this is a second block. This is called a provider block, and this is called a resource block. And we have different types of blocks that we are going to learn about as we go. So this is just a snippet from the code. Resources are declared through a series of text files in HashiCorp configuration language. So you want to write an infrastructure configuration file, then you need to write and define the resources that you need in that configuration file, and we need to follow the HCL. So this is written in the HashiCorp configuration language. The .tf configuration, you can have all of your configuration in a 400, 500, 2000 lines file if you want, one file, or you can split it into multiple .tf files that will coexist in the same directory that you are working on. The configuration files would typically be stored in some kind of source control, version control, GitHub or code commit or Bitbucket, because you need to control versioning and so on. What else do we need to know about this? So if I split the configuration into multiple files, it would look something like this. Usually in Terraform will look the zoom point or the visibility point is a folder. It's a directory. So all the files in the directory with a .tf, they're going to be inspected and checked, and as if they are combined into one file. So anything here with a .tf or a .tf JSON is going to be inspected by Terraform as part of your configuration. So be careful that you don't have a file that has nothing to do with this, but by mistake because you copied a folder and then now you are starting to create more files, but there was one that you didn't see and you did not delete, because now more resources are going to be created. So it will load all the configuration files within the directory. So my scope is a directory level specified in alphabetical order. So if we look at this, I have a folder called my project. I have a file called ec2.tf, natgateway.tf, s3.tf, subnets.tf, variables.tf, vpc.tf. Now alphabetically, it's going to start looking at the ec2 first, then followed by nat, and then it will look at S letter and the V letter, and the VA will be before the VPC and so on. All right, so the files must end with either TF or .tf JSON. What if I have a file here and then I added an extension BK, for example? In this case, you have invalidated this file and it's not going to be looked at by Terraform in this directory until you remove the .bk or the extension and leave it with either .tf at the end or .tf JSON at the end. For larger projects, we can have multiple configuration files in the same directory, and later on we'll find out that we can even split it into other folders, but not now. For now, let's talk about directory. Each one of these files can represent resources. So for example, I have a big project that has a lot of EC2 instances, a lot of S3 buckets, a lot of security and networking and all that. Why don't I have the database in one and the EC2 in one, and then the VPC and infrastructure in one, and then I have the security in one? And they will be in the same directory, but each one of them is going to be 20, 25 lines instead of having one that is 400 pages filled with code. And of course, this will help us to write cleaner code and also will make the troubleshooting much easier. And here we have a snippet from the EC2 file. I have a resource block for EC2. I have another resource block for another EC2. And I have the configuration for each one of these. All right, so that was about configuration files. Please remember that any .tf or .tf JSON in your folder or directory is going to be compiled as part of your configuration. And if you do plan, dry run, rehearsal, or you do execution, then whatever is within these files is going to be executed or planned. And if there is an error in one of these, then maybe it will be aborted and it will not be executed because of that. Let's now discuss the Terraform providers and how we can define them in our configuration files in Terraform. So as we mentioned earlier, Terraform core, or the program of Terraform that you are running on your laptop, or the CLI, relies on providers to do what? To interact with the cloud providers. That is the way how you, as the user of Terraform, you have been completely kept away from the complexity of knowing the different APIs of AWS. So it's a way of abstraction where you only use the HashiCorp language, and then in the back end, this is going to be translated into the right API calls for the respective provider. So a provider adds a set of resource type. Now, if I load the provider of AWS, then EC2 instances, security groups, VPCs, load balancers, databases, and so on and so forth that has been included in that provider version, they are now all ready for my script to start pointing at which resources are required, and then the right API calls will go out. Remember that also the plugins of the providers are responsible to authenticate the requests with the provider and to make sure that this is permitted, or get a declination, rejection from the provider, and then you will see an error message that the credentials you have are not really are invalid or are not allowed to carry out these actions you are asking for. And where do we find the different providers? And is there a way we can find out where they are documented? And the answer is yes. If you go to the Terraform registry, registry.terraform.io, browse providers, and if we click on that, this page will open, and as you can see now we are looking at the Terraform providers, and I have AWS, I have Azure, I have Google, I have Oracle Cloud, Alibaba Cloud, Kubernetes, and I have more. Now, what's the authenticity and how genuine are these, so it's not going to provide me with code or something malicious in our work and so on. So on the left hand side you will find what is called tiers. Let me just magnify this a little bit. So you'll find tiers here. So you have official, this is HashiCorp, you have partner, you have community. So let's look at what are the differences. Let's untick these two and then we go down. See, anyone that is official by HashiCorp, so you can see here by HashiCorp, by HashiCorp, by HashiCorp. So if it has the certificate, that means it's HashiCorp maintained. So it's developed and maintained by HashiCorp. What if it is partner? How different it would look like? So you'll find, or the handshake symbol here, that means these are done by partners of HashiCorp. And you'll find a lot of different vendors also that they have developed things, partners of HashiCorp, Aviatrix, for example. I have things that have to do with, you'll find here F5, load balancing, Cisco and other companies also, and this is one of 50 out of almost 350 providers. So these are all partners that are developing, and then they are publishing this, and Terraform has reviewed them and everything is cool. And then we have the community, which HashiCorp is not responsible for. Now, anyone can go to the registry and can submit modules and can submit providers and all that. But now these ones, you need to use it or swim at your own risk, basically. Then you need to make sure that you know and you can validate before using these scripts, or at least go through them, find out what exactly they're all about before working on them. But as you can see from the community, they are close to 4,000. Whereas from partners, they are 350. And now we are not talking about configuration files. I'm talking about providers. So these are different entities. 4 or 5 of them are cloud providers, but then the rest are completely other companies that provide APIs, and Terraform can configure on these providers. So if I click these ones again, let's explore the AWS one. So if I click on AWS, you'll find that this is the AWS provider, and then this is official, it's public, and it's maintained by HashiCorp, and you'll find that the current version is 5.59.0, and it has been published 2 days ago, and the source code will be found here because it used to be an open source, now it's a business source. And on the right side also, you can get yourself a little bit comfortable about using it or not. Here you'll find out downloads this year 713 million. There has been a 713 million times where a Terraform initialization for a script happened and it used the AWS provider. And you'll find also downloads all over the time, 3 billion times it was downloaded. So Terraform files were used 3 billion times with AWS providers in this code. And downloads this month, how many, and downloads this week. All of these are good signs that I can go ahead and use it, besides the fact that it was from HashiCorp. Now, okay, fine, but where is, I don't see any configuration or anything about AWS. Then you click on documentation, and this is going to talk about AWS as a provider. And on the left-hand side, you'll find guides and functions, and you'll find the different services in AWS that you can use to configure different things in AWS. So these are different sources or resources that you can use within AWS, as you can see. And if we look for, let's say, if I search for EC2, then I click, I want to see it on the left side. As you can see, a lot of things that have to do with EC2 are available on the left side as well. Or if I search here, EC2, it will bring me that EBS in EC2, data sources, and then Elastic Compute Cloud. Then I have resources, and then I have data sources under EC2. And underneath this is you will find the AMI copy, and a lot of other resources we can create, and we're going to play a lot with them as we go. All right, so this is AWS provider, and this is how you can find it on the Terraform registry.terraform.io, and then providers, HashiCorp, AWS, and then latest docs. And if we go back, then here, as we mentioned, you can have which version you are looking for, and then you can look at different releases if you want to work with a specific one. So you can view all versions, and you can click on a specific one and when it was released, and then you look at the documentation for that one. So that's how you scroll with the different providers. And if we go ahead and let's try to find out if one of the HashiCorp providers that are from the community and compare the number of times it was downloaded to AWS. So I click on this one, and then you'll find out downloads over all time are 3,000 times. Downloads this year, 1,400. Downloads this month is 147. And now you can see the difference between long-term maintained one from HashiCorp, and it is a popular one, and one that has been published. It could be a genuine good one that has been published by someone to do a specific resource or function that is written, which is good if it matches what you're looking for, but you need to choose that based on how many times it was downloaded with comfort and without being worried about anything. Of course, the official, then the partners, and then the community. All right. Let's go back to the slides, and now we can find a list of publicly available providers in the Terraform registry. We have taken a look at that, and they are either official, verified, community, and archived. Providers allow you to abstract away from the individual processes and technology, as we mentioned earlier. So the providers can be defined in what we call the provider block. And here's an example. I have a provider and AWS. It has to be written between quotes, and it has to be AWS lowercase like that. And then the curly braces, and then you can put the configuration parameters here, which region you want to work on, and then which profile you want to authenticate with, and so on. All right. And the syntax here is like this. So the region without any quotes equals, and then double quotes, and then the name of the region you would like to work with. We'll see as we go how you can build these configurations, but not the time right now. And then also you can define the provider in the Terraform block. That's a different settings block for Terraform, where you can define providers and which version of that provider you can use as well. You can specify and restrict versions here if you want. So for example, here, this is the Terraform block. There is no name after that because it's Terraform, it knows itself, but here you need to identify which provider because there are plenty of providers. Then you can have a nested block within called the required providers. Then you open a curly brace, and then you mention that AWS is required. Open a curly brace, you can define where to get it from. So the source, and then the version or versions that are allowed. then this one needs to be closed, and this curly brace needs to be closed, and the third one needs to be closed, and you're good to go. All right? Please remember that I cannot define the region here. So these are not either or. This is a way to restrict versions for the providers. This is a way to define for AWS, for example, which region and which profile you are going to use and so on. We'll see a lot of these examples, so don't worry about it if it seems a bit odd right now, but I promise you this is going to be a piece of cake with a couple of examples coming up. All right, so let's look at AWS provider authentication when using Terraform. We'll talk about provider authentication in general, but then we're going to project that on AWS since we will be using AWS extensively throughout the course. From what we have seen before, we have the Terraform core that is going to talk through RPC to the providers or the provisioners, the plugins basically. And then through the library, there will be an HTTPS call that will go out to initiate, create, change, or delete resources on the providers. The question I have is, how do we provide the authentication and authorization? How do we provide the credentials to Terraform such that when it generates the API calls, when the plugins through the library, they will generate the API calls, then they will carry with the API calls who sent it, so that's authentication, and also they will send the profile basically such that AWS can check and can find out, first of all, if the person is known, and then if the person is authorized to carry out the task specified. So let's dig deeper into this, and this is true whether you are dealing with Google or Azure, or you're dealing with AWS, Alibaba Cloud, with GitHub, or with any other source. You need to authenticate so they know who you are, and then they will find out if you are authorized to do the required actions or not. The requested actions that your APIs or the Terraform API calls are being sent to create, initiate, change, or delete. So let's project that on AWS. In AWS, in order to access AWS, you have to do it in one of two ways, or these are the two major ways that are known in AWS. The first one is, if you want to access the console, this is the console. So if we type here, the console home, you'll find that this is the console home. So basically accessing AWS through the portal, through the UI. This is called console access. So if you want to provide this type of access, then what you need is you need to have a username and password for the user that will access it. What if I need to access AWS from my laptop? I don't want to log in. I don't want to type in a username and password. I don't want every time I want to deal with AWS to go to their website and log in to do something. I hate the UI. I don't want to deal with it. Or maybe my job is not to deal that way with AWS. Maybe I'm a developer. I'm going to write code, and I would like to have what we call programmatic access. So I can be using AWS through the command line interface, or maybe I'm a developer building and dealing with AWS through software development keys or the SDKs, or maybe I need to generate my own APIs, or I have an application outside that needs to communicate with a database in AWS through APIs. Then in that case, you cannot have a username and password to do the programmatic access. You must have what we call an access key pair, and that is an access key and a secret access key. Think of it like a username and password, but in the programmatic world, and not a username and password that you have to type manually. All right, so Terraform falls under this category. Terraform is all about sending API calls to the providers, right? So it has to have access key IDs and secret access key. One profile, more profiles, you need to do that. And that cannot be generated by Terraform. We have to do it on AWS and then configure it in our configuration files or in Terraform, and there are plenty of ways to do that. So step number one is we have to create that in AWS, have the credentials, and then go in Terraform and start configuring that, either globally on the operating system or in the configuration files we are going to use. So let's go ahead to the AWS IAM, Identity and Access Management service, and find out how we can do this. In case if you know how to do it, please go ahead and skip the lecture if you want. So I'm going to go into IAM. And now if I want to create a user, let's say we're going to create a new user. And this user, I'm going to call it Terraform course. Here it's asking you, do you want to provide access to the AWS Management Console? Yes or no? And in this case, I don't want to provide Management Console access. All right, do you want to add the user to a group? And I don't want, for this case, I don't want to add it to a group. And I'm not going to provide any policies or permissions. Here I'm saying I'm going to attach policies directly, and I'm not going to tick. If I tick, for example, administrator access, the user will have administrator permissions. I don't want to do that right now. So I'm going to untick this one. I didn't provide any permissions to the user, and I'm going to click on next. Then I have the user details, the permissions boundaries. If I want to configure them, I don't want to configure any of this. And I'm going to create the user. So I have the Terraform course user right here, okay, with no permissions at the moment. So how can I create an access key ID and a secret access key to the user right now? If you see at the top, you can go create access key, or you can go under security credentials, and under access keys, you can click on create access key. Either one will yield the same thing. So in this case, I want it for the command line interface, and I'm going to click I understand and next. I don't want to create any tags right now. So this is the only chance for you to look at the secret access key. So what do you want to do? You can download it. I clicked and now it will be downloaded in my laptop. Let's see, it has been downloaded already. And if you look at the credentials file, you'll find it looks like this. Let me just zoom in. Let me zoom in a little bit. So as you can see, the file, here is the access key, and here is the secret access key. This is the only chance to look at the secret access key. So please download it and keep it, or at least copy it. You can do this, and then I'm going to go into a file and save it. And then I'm going to click on the secret access key, and I'm going to save it as well. It will be handy, and we're going to use it in the lab. That's why I'm copying it outside. All right, so I have it now, and please remember that this user has no permissions at the moment. Okay, so we have a user with access keys with no permission. That's what we have right now. And if you wanted to look at the key that we have generated, here is the key, but there is no way you can look at the secret access key again. So what you can do is you can deactivate it, or you can delete it. So if I'm going to show you all the details about this, and we're going to provide the user full administrator access, but at the end I'm going to delete it because I don't want anyone to use it in my account. So please be careful when using the access key IDs and the secret access keys. All right. So now I have an access key ID and a secret access key. That's good enough. When you deal with AWS on your laptop, you need to install what we call the CLI tools in AWS. If you have that installed in your machine, that's fine. You can skip this slide. If you don't, please make sure that you are going to click on this link and download it. Now, let me show you where is that exactly. So I'm going to click on that. And as you can see, install or update the latest version of the AWS CLI. And here they have instructions for Linux. They have instructions for, let me just collapse this one, Mac OS. And they have instructions for Windows. So please, if you don't have it installed, go ahead. So you can do this one by one, command line, or you can download this one and run it, and it's going to install it on your laptop. Once I have installed it, that means I have the AWS commands on my laptop. So now I can deal with AWS programmatically through the CLI, the command line interface. In your case, if it is Windows, it's going to be the command prompt, the CMD black window that you can open in Windows. In my case, it's Mac. I'm going to use the terminal. So in my case, I have it installed. So how would I know if it's installed or not? If I can just type AWS --version, you will see that it will tell you that you have AWS CLI version such and which Python it's using and so on. So this means I can run AWS commands from my machine. And here's an example command to list S3 buckets in my account. And if I hit enter, let's see, what did it say? It said that that's invalid access key ID and secret access key. Where is that? Where did it come from? Once you have installed it, what you need to do is you need to create AWS configure, and then you can add a profile name if you want to do a name, if you want to do profiles, different profiles. If you don't put the profile and name, then it's going to be the default profile. If I click in configure, you will see now that I have already an access key ID configured, and a secret access key configured, and a default region configured, and default output configured, but it complained that this is invalid in my case. Invalid access key ID. So that's the situation here. In your case, you need to hit configure, and then you're going to copy the access key ID and paste it here. So for example, the one that I have configured, I'm going to configure it and add it here. The one we created, and I'm going to take the secret access key and I'm going to paste it here. And then default region is fine. You can change the default region if you want, and the output JSON format is okay, and then we'll hit it. How can I confirm that it was configured properly? Then what I can do is I can do AWS configure list, and you will see that this is the default. Also in the list command, I can use the hyphen profile and then the name of the profile if I have multiple profiles configured here. And if we look at this, you'll find that the last letters, and they do match with what I have typed here. And here also the last letters, FXUW, and they do match with what I typed here, FXUW. All right. So now I have a profile configured, but the profile has no permissions. So this is how you configure the CLI in case if you did not configure it before. So let's go back to the slides. Once you have your profile configured, where it's going to end up, there will be a credentials file and there will be a config file. And they will be under a directory called .aws. If this is Windows, that will be under C users and the name, your name on the machine, your username, and then /AWS/credentials. Or it's going to be under the same folder. There will be also the configuration. So this is for the credentials, the access key IDs and secret access keys, and this is for the actual configuration or the different profiles that I have. In Mac and Linux, it's going to be under the home user.aws/credentials or AWS config. Let's go ahead in my terminal and confirm that this is the case. If I do cd and then /AWS, and if I do ls, just to list the files, I have a config file and I have a credentials file. Okay, so this path is important for you to understand. In your case, if it is Windows, it's going to be C and users and then the username and then the /AWS/credentials or config under the same directory, but this is where the files are. And if you open the files, you will find here that which profiles are configured. So for example, if I do cat config, you have here that these are the profiles I have here. So I have the default profile, it's in US East 1, and then I have a profile called new account, and then I have a profile called dev admin, and I have another one called terraform.dev, and I have one called mahat, whatever the name is. So I have multiple profiles on my machine, and if you open the other file, it will tell you for each profile what's the access key ID and the secret access key, and I'm not going to show you that because it's confidential. Basically, it's my account and credentials and all that. But you have to have that, and once you have that, then you are good to go. Now, if I go back, we can also, a useful command we can use here to list the profiles is the AWS configure and then list profiles, and it will tell me all the profiles I have on the machine. So this is an abbreviated form to find out the profiles that you have. Since we have understood how we can do the CLI and how we can create an IAM user and provide the access key ID and secret access key, and how can we do the configuration with AWS configure on the CLI of your Windows or Linux or Mac OS machine. Now we understand that, then now let's find out the different ways we can provide authentication to Terraform to work on AWS. So question number one, how do I get the provider configuration? Or how do I type the provider configuration? Where do I get it from? And the answer is very easy, and please use that as much as you can. You can search on Google for what you want, and you can be directed to it very easily without having to look into the Terraform website. Sometimes if you are new to Terraform, it could be troublesome to search in the Terraform website. But in this case, for the providers, it's easy to get to. So let's find out how. So if you just open a tab, and in that tab, all what you need to do is to type AWS Provider Terraform. And as you can see at the top, AWS Provider in HashiCorp in Terraform. That's the Terraform registry we have discussed before. Why did I provide you that? Why didn't we go through the registry.io and then the providers and so on? This is a practical and easy and fast way if you are learning through the website. If you would like to go and browse the other way, now you have both. Do whichever feels easier for you. So now this is the AWS provider, and you'll find here example usage. So here, for example, I have provider AWS and then the region that we are going to use and then some resources. Or it can be defined, and I can also specify the version of the AWS provider that we can use. And what are the available authentication and configuration methods? You have the parameters in the provider configuration. So you can add the authentication in the provider block. That's one way. It can be environment variables in the Linux or the Windows operating system that you are using. It can be shared credential files. It can be shared configuration files. And there are two other ways we can use as well. So for now, if I would like to add a provider configuration to my Terraform file, I'm starting, I haven't done anything, and I would like to get the provider configuration, all what you need to do is to copy this, and then you can go into VS Code. Inside my configuration, I can just paste it here, and then I start modifying it. And as you can see, it's exactly like the one we have in the template. And here I have an additional statement, but it's commented. The hash at the beginning, that means as if this is a comment, like exactly the comments we are putting here, then it doesn't show that you are using the profile right now. So this one looks exactly like this one without the commented file, which is exactly the same. Now, with time, you may want to write it yourself. So you can write provider, and then you have AWS, and then you can open the braces, type the region that you would like to use, and so on. So with time, you would get used to it, and you will be able to do it manually if you want, or you will have a lot of templates that you can use in order to write that. All right. So that's for the provider part. Now we know, and it's easy to do. How about the authentication part? Let's go back to the slides. So there are different ways: default location profile, parameters in the provider block configuration, as we will see, custom profile credentials, and environment variables, shared configuration file, shared credential file, and there are two more that we're not going to look at here. And all of these can be found, and here is the link for the AWS provider. So that's the same page we have been looking at, and you can use it with no issues. Let's look at them one by one. We're talking about the provider authentication methods, and this is the default location. What do we mean by this? If you are using it on a machine where the AWS CLI has been configured and you have a profile, default profile, then it's going to search in the default location, the user home directory /.aws/config and /credentials. This is where it was going to be looking for by the default profile name. If it finds it, great. If it doesn't find it, then there is a problem. If it finds it, but it doesn't have the credentials to create or do the action that you have in the script, then it will not be implemented. And we'll see that in the hands-on labs. So let's go ahead and look at how we can do this without any profile commands and see what will be the action from the AWS side. Remember that we have a CLI profile configured with no permissions whatsoever. So let's go ahead and look at the first authentication and authorization method and see if it works or it doesn't work as explained. So here's a Terraform configuration that we have. We have a provider, AWS, and the region is US East 1. And I would like to create a VPC. All right. So there is no profile, there is no credentials, there is nothing here. What do I do to use this? I have to initialize the directory. I can right click, make sure that I open the terminal in the same folder. How do I find out if I'm in the right folder? If you do pwd, it will tell you that this is the user Dolphin Ed, desktop Terraform, and this is the file the folder where I am right now. So in order to use Terraform, I have to initialize the folder. Why? Because it needs to find out what are the providers and then download the plugins from the internet that I need to use. So if I click on that, if you look right here, it's installing HashiCorp AWS, and here is the version that it is using, and it's using the latest version. If I go ahead and clear, now what I need to do is I need to execute this configuration and see what happens. How do you execute? Before that, I have to plan. So I have to do the rehearsal, the dry run, which will not do anything on AWS. And after the plan, I need to go ahead and do the apply. So it said, okay, I'm planning. There is one thing to add, which is the resource. So we have here a provider block and a resource for AWS VPC. One might ask, okay, so where did you get the resource format for the VPC from? How did you write this one? Exactly the same thing I said before. I'm going to get here and I'm going to type AWS VPC resource on Terraform. Of course, I could do it this way. I could do it the other way around. For example, here, I have one example for VPC. So I could just copy that and use it. Have another example here, similar one. And I can also go under the documentation of AWS. And then from the left-hand side, I'm going to look at VPC. So it will be one of these. Instead of looking at all of that, what I will search here is I'll search for VPC. And go through them to find out the one I'm looking for. As you can see here, this is the one I'm looking for, virtual private cloud. And under the VPC, I'm going to look for the VPC resource. AWS VPC, as you can see here. And here you can find examples. Only what you need to do is just copy it and paste it in your configuration file. So there's plenty of examples here. And that's the easiest way to get into Terraform. With time, you'll get used to it. You'll see it 100 times. You'll type it, and it will be easy to do. For me, I don't even want to bother about writing it because it's very easy to find and it's very easy to copy and paste. Whichever way you are more comfortable with, go ahead and use it. So now I have that and I have the block. What I will do now is I'm going to go ahead and apply it. So let me just put that in a full screen. And I'm going to go ahead and apply this. Terraform apply. Let's see what happens. And are you okay with that? So until now, Terraform doesn't have any issues with the syntax. Syntax is right. What I'm typing is okay. And it will try to find out the credentials available in default and then send the API to AWS. Then you're trying to create VPC and the operation error, create VPC HTTPS response, and you will see here that you are not authorized to perform this operation. And why is that? Is because the user we are using does not have credentials. And that's why it's unable to create the VPC. How can we prove it? Let's go back to the AWS console. Right here, and we have the same user here. What I will do now is I'm going to go under permissions, and I would like to add permissions to this user, the same one that we have been using before, the same one we got the keys for, and I'm going to add permissions. And I would like to add permissions through a direct policy, although it's not the recommended way in AWS, but that's a faster way right now. And I'm going to add the administrator permissions. So now the user has the administrator access and it takes effect immediately. So let's go back to the code again and try again. So I'm going to repeat the command again, Terraform apply, and hopefully this time the API call is going to be accepted by AWS and we'll have a VPC created. Let's find out. So now it didn't complain. It has a VPC completed in almost no time, one added. And here's the ID of the VPC. It ends with 51CF. Let's go ahead to the console and verify if we have this VPC or not. So I'm going to click on VPC. I'm going to look at the VPCs I have here. Click on this. Make sure that you are in the right region. So if you click here, this is US East 1. If your configuration was in a different region, you need to go to that region and find out if you have it or you don't have it. All right. So if you look here, it ends with 51CF, which is the one that we create, which means I did not provide any credentials, but I have a default profile configured. So Terraform looked for that default profile for the credentials and took that in the API call. When we didn't have permissions, it failed. When we had permissions, it worked and it created the VPC. Let's go ahead and destroy the VPC just to confirm that this is what we are controlling through Terraform. So if I go here and I do Terraform destroy. So now we have learned initialize, plan, apply, and destroy, and we're going to elaborate on these commands later on. But now we need to show you at least, like the getting our feet wet with Terraform with simple commands. So now I'm trying to destroy this and see in no time it has been destroyed. And if I come here and refresh, hopefully it will go away, and it has gone away, as you can see. All right. So this is the first authentication method, which is the default configuration. All right. The second one is by supplying the access key ID and the secret access key inside your provider block. And this is not recommended for security reasons, because if anyone has the file, they will have the credentials in your account. And anything wrong happens, you will be accountable for it. But it's a possible way to do it. So let's go ahead and find out if this way can be done and if it works or it does not work. I'm going to go back to the code again. And I'm going to minimize this to be able to look at the code. So what we need to do now is I need to hash or comment this one so it will not be effective. All right, so let's now try with the access key pair in the provider block. So what I will do is I'm going to create an AWS block. If you look at this, it's the same provider block and region. That's what we had before, but we need to add the access key ID and the secret access key. And I'm going to still have the same resource created here. Okay. And what I will do is I'll just copy from the file I had the access key ID, and I'm going to make sure when you're copying and pasting here that you don't delete the codes and you don't leave anything from what you had before, because these are common mistakes and it could have you spend hours and hours trying to troubleshoot what's going on. Easiest way, look at the first two letters and make sure they are right, and look at the last two letters and make sure they are right. And same thing for the secret access key. All right. Every time you make a change, make sure that this change is saved. So in my case, it's going to be Control S, or you can just go to File and then Save. However you would like to do it, make sure that the changes are saved, because otherwise you're going to be practicing with the old configuration. So it is saved. I don't need to, I'll do a Terraform apply again. Usually we do the rehearsal, the plan, but I'm going to do the Terraform apply to find out if it works or it does not work. Remember that we have commented the initial provider block, and it's not going to look at the default in this case, because I have provided credentials embedded within. So it worked, and it's a VPC with the ID 4DD0. And if you refresh here, you'll find that it is with the 4DD0. So it has been created, and this method also works. So I can go back and do a Terraform destroy, and the VPC will go away. Yes. So if we come here, you'll find that the VPC has gone away. So it doesn't exist anymore. So we're still with the provider authentication for AWS. We are going to look at if you want to provide a specific profile. So you don't want the default to be used, and you don't want to embed the credentials, which is not recommended by security people or from a security perspective. Then how can we do this? And let's go ahead to the code and we'll find out how this can be done. So let's hash the one that we have used before. So this one is not used right now. And let's try the third type. And in the third type, what we'll do, and let's hash also the VPC because I have the block available below. What you can see here should not confuse you, because whatever is commented, whatever has a hash at the beginning, consider that it does not exist, as if it's not there. So Terraform will not look at anything that is commented, it will consider it as the text that we have here, exactly the same. So when you want to check if you have a file like this, just scroll down, scroll up, make sure what is highlighted, and you are good to go. All right. So in this case, what we are trying to do is we're going to use a profile to give the credentials to AWS. Note here that we have, this should be commented because this is text. So I have the provider, double quotes, AWS, curly braces, the region, and the profile. The profile is dev_admin. It does exist on my machine, and we have seen it when we listed everything in my machine. Okay, if it doesn't exist, then definitely we'll get an error. Okay, and I wanted to create a VPC resource. That's what we need to do. Same thing that we have done before, nothing changes. So let me save. Remember, we have to save any changes we make in the file. Of course, in your case, you could use them in different files, in different folders. It's up to you. Do whatever you like. And what I will do here is I want to clear, and I would like to do a Terraform apply and see if it will take the credentials from the profile or it will not. And if it doesn't, then it will get an error as we have seen before. Yes, to approve it. And now we will find out. Okay, so it has been added. A new resource has been created. It took 3 seconds. 3 seconds. Not even the time that you will find to type the username or the password on the console. And this is because, so we have created multiple VPCs. It took us no time because it is done all with API calls. So you spend some effort, some sweat to write the script in a proper way, and that's it. All right, so now we have one created. If I go back to the console and I refresh in the VPC, you'll find that we have one that ends with 5198. Let's see if that's ours. And it's 5198. All right. So this is the third way we can provide the credentials to Terraform to the providers or the plugins to use it to create resources. Now let's hash this and find another way. All right, so the environment variables, the operating system one. So in this case, it's not going to be configured in Terraform. It's going to be in the operating system, whether it is Windows or it is Linux. If it is Mac OS or it is Linux, we use the export command. If it was Windows, we use alternatively to that with the set command, lowercase. So instead of export, you'll write set. And here the $sign is not part of the command. This refers that I am at the prompt, and this is what I'm going to export. So exporting the AWS access ID or the access key ID and the secret access key, and also you can use the region if you want. That means these are going to be available to all the child processes in your operating system, which means you can use them and any program can use them or access them. And that's how Terraform will go ahead and look for them to do the job, basically. So what we'll do is we'll do the export command in Linux or in macOS in my case. And this export access keys and default region can set environment variables that will be available to all child processes. Okay, so what do we need to do now? Let's go ahead to the code. But before that, let's do something on AWS because I need to confirm whether these are correct or they are not correct. So I'm going to go to the console. I'm going to go to the IAM service. You can type it here and it will appear, or in my case, I have it as a favorite. So what I will do is I'm going to go under users here. And in the Terraform course, what I will do is I'm going to go in the permissions and I'm going to remove the permission. Why am I doing this? I want you to make sure that it's not going to be using the default permissions. It's going to be using something else. All right, and what we'll do is we're going to create a new user in this case. And the new user, I'm going to call it Terraform user 2. That will be the username. And I'm going to do next. And I'm going to attach permissions. And I'm going to provide the administrator access in this case. And I will continue. And I need to create for the Terraform user 2 an access key as we did before. CLI. And I'm going to click on OK. Create access key. As we mentioned before, this is the only chance for us to view it, or we can download the file. So I'm going to copy this. You can just click on the next on the side, and I'm going to provide these two. All right. So in this case, we have the default that has no permissions now. So if I try with the default now, it should not work. Let's find out. So I'm going to go back up and I'm going to remove the comments from here. Make sure that you don't have the statements available. So the statement will always have to have that because it's text. And I'm going to also have that uncommented here. Okay, save the file. And then what I'll do is I'm going to do a Terraform apply. I expect that this will be erroneous. Oh no, we have two VPCs. See? It has detected errors and that's why it's complaining. So now I'm going to just highlight, comment this. And as I told you, it's very smart. Save the changes again that we have done. And I'm going to go ahead and do Terraform apply. So my hypothesis is it will not be able to do it. Why? Because we removed the credentials from the user. And as you can see, you are not authorized. The user Terraform course is not authorized to do the action that we have specified. So what do I need to do now? I need to use the third method. So we're going to go through the export. That's what I need. Remember that you don't put the $ at all here. I'm going to get into that. I'm going to copy and I will go to the terminal. So this is not in Terraform, to be honest. And what I will do is I'm going to get the new key, the new access key. And I want to make sure that I don't have any extra letters. So that's the export access key. And then I want to export the access. Oh, I'm sorry. I should have quoted that. All right. So enter now. And then I'll get the export secret access key. And I'm going to open the quotes and then get this. I don't have to do the region because we know about the region and how it works. So this is not our subject right now. So I have this, and let's go ahead and try the same thing again. So I'm not going to change anything here. All I'll do is I'm going, not even saving, but I will do a Terraform apply again and see if I get the error or if it will work. All right, so we did not destroy the previous one. That's why it is refreshing and did not change anything. I'm going to force it to do a change by adding a different name here. So it will consider it as a new resource and it will have to go ahead and apply the changes. But make sure that you save Terraform apply. So now it will do a change. It will add one. And there is one that needs to be destroyed. Why is it going to destroy that one? Because I removed the one that used to be called example. It's not in the configuration anymore. So now it understands I need to get rid of anything else that does not match this configuration file. And here's what it will do. So it will destroy the old one and it's going to create a new one that ends with 9A7B. All right, don't worry about the destroy and change. I forced it to create a different VPC and I removed the old one by changing the name. I removed the old one from the configuration and that's why. But the point here is it has successfully created a resource that ends with 9A7B. And if we go here under VPC, we're going to find that, which means it did not go with the default if there is another way. So the default is going to be the last thing it will try, not the first thing it will try. And as you can see, 9A7B right here. All right. So I'm going to go back and I'm going to destroy this. Terraform destroy. And it will go ahead and destroy it after getting my approval. The answer is yes. All right. So now it has been removed. Now we have looked at so many different ways we can do this. The last way we can do it that we are going to discuss here is instead of putting the access key IDs and secret access key or giving a profile, what if you provide the location of the credential files? So here it's going to be under the user directory dolphin ed AWS credentials and then dolphin ed AWS conf. This comes in handy if you have created the files manually or if they are under a different path than the default path. And then I provide the profile and it will go ahead and get the credentials from them. That's the last way you can do it. And now you are referencing files. But the problem is, if this is going to be used by different teams, what if one has that as conf, one has that as creds, but then another one has it as the full configuration keyword and the other one as the full credentials keyword. So if the paths are different and they're not under the home directory, then it can cause problems. If the paths are different, if I'm trying to use it on my laptop, but the path for these files are different than yours, than hers, then that will create trouble. So that was it about the credentials and the configurations for the provider authentication. Maybe it has been long, but now you have all the different ways that are within our scope for this particular part. All right, so we have touched on Terraform init, Terraform plan, Terraform apply, Terraform destroy. Now it's the time to jump into these because these are the components or the cornerstones of a Terraform workflow. So we need to dive a little deeper into these and find out what are the command options, how does it work, why do we do it? All of that is important now. So let's go ahead and find out about this. So in Terraform, it is a single workflow that we use to plan, which is the rehearsal, the dry run, provision or apply, and tear down or destroy resources. And the workflow has three main stages: write your code, plan your code, execute your code, and of course, tear down your code afterwards. So we have the write, where we have to use the Terraform configuration. And if it is an existing configuration, there will be a refreshing or a state file. We'll talk about that later on. Then you start doing the plan and review the execution that will happen if you decide to go ahead and apply it. And then the last one will be to go ahead and apply whatever you have reviewed here on the respective providers, and they could be parallel providers at the same time. If you would like to summarize, first of all, you have to be in the directory where your configuration is. As you have seen in VS Code, I right-click on the file and then I open the integrated terminal, basically as if I'm ordering VS Code to go forward to where that file is. So now I'm exactly at that folder. And now I start the initialization. And we'll talk about what happens through the initialization. Then, if it is initialized, that means I have the required plugins, the required provisioners, providers, and so on. They are now available. The translation mechanism that is going to take my script, and then it's going to take that and convert it into API to the respective providers. Then we do the rehearsal, we do the plan, we do the dry run. Can you formulate an execution plan that we can review? And then if it is okay, we go ahead and we apply it. So we deploy the infrastructure, and it could be that after a while we need to add another instance, we need to update the image, we need to create a new VPC, we need to do this, we need to do that. Then we update the script that we have, and then we do another rehearsal, a new dry run. And in the new dry run, what will happen is Terraform will read the state from the existing infrastructure and then contrast it or compare it with the updated script, and then it will find the delta. And if there is any changes or drift on the infrastructure from the previous state, then it's going to remove that, or it's going to plan to remove it if I give it the go ahead. Once that has happened, then we apply. At the end, we finish the project, then we go ahead and destroy as you have seen it. So let's start with the first one and look at the init phase. So the very first step. So for all of these, we have used the command Terraform, and then we have plan, apply, destroy, and all that. So the subcommands are init. There is a one called validate. We have not used it yet. Plan, apply, and destroy. And in the global options, we can have help or version or child directory. These are things that we're not going to touch on right now. So this is the Terraform. That's the main command that is being used by Terraform or Terraform core. So the init phase or the Terraform init, this will initialize the working directory, the folder where I am at, where my configuration files are containing the Terraform configuration files. This is very important because if you are in the wrong directory and you open the terminal in the wrong directory and you are initializing, you are now initializing something else away from where you are at the configuration file or where your configuration files are. So basically, let's say that you are at a directory that has an AWS configuration, but now you are looking at a file that has to do with Azure Cloud. If you initialize in the wrong directory, it will download the AWS providers. Whereas you are actually keen on doing some Azure configuration, so it has to download the Azure providers. So you need to be careful that you are in the right directory before the initialization. So this is the first command and should be run after writing a new Terraform code or after updating an existing one or after cloning from GitHub or Bitbucket or similar place. So what will Terraform init do? It will download the plugins, and please remember the plugins could be providers and they could be provisioners. Remember when we said providers like AWS, Google, Alibaba Cloud, and so on, and provisioners like Bash script, for example, with the relevant providers. So it will look at the configuration, find out the providers, and it's easy to find. How many provider blocks do you have? So you have a provider block for AWS, you have another one for Azure, and you have a provisioner block that has to do, we'll discuss provisioner later on. So it will find from the file what is it exactly that you need to download, and it will download that for you. And if you see here that we have that and it's initializing the file, and here it states that I am downloading HashiCorp AWS or reusing a previous version. I'm sorry, in this case, it's reusing a previous version and installing HashiCorp for a random service and then AWS version such and such. Okay, so we are going, this is not an output from a fresh configuration, but I'm going to show you that in a fresh configuration, definitely. The command I can use is Terraform init. So this will initialize the working directory that contains Terraform configuration files and will download the respective plugins. I can do it in JSON format, so the output in the machine readable JSON format. And I can do Terraform init upgrade. Let's say I initialized the working directory a week ago and we have deployed our infrastructure and everything looks perfect. Everything was fine. But now after a week or two, we did some changes and I want to make sure that I have the latest AWS provider, for example. So what do? If you add the hyphen upgrade, it's going to go and search and find out if there is a latest one different than the one that you're using, and it's going to download that one and use it from that point onwards. And this link can get you into the Terraform init command. Then we look at the Terraform validate. Validate will not change anything, will not download anything, will not plan anything. All it does is it will check your code and find out if it is, from a syntax perspective, it is valid. There are no errors, and that's it. So it will not validate whether you have credentials or not. It will not look at if you have API issues when you try to send it or something is missing. That's not its purpose. It will just look at the syntax, find out, did you miss a comma? Did you miss a quote? Did you miss a curly brace? Did you not close the curly brace? That is what it will look at. And if everything is okay, it will just say it's perfect, and that's it. So various aspects, including unsupported arguments, undeclared variables, and other stuff. And the format is Terraform validate. Terraform validate with produce the output in the machine readable JSON format. And again, here is the link to the command if you would like to read more about it. All right, so let's now look at the Terraform init phase, and we are also going to check the Terraform validate. In order to do that, let's go ahead and build from scratch a Terraform configuration file that is going to create an EC2 instance on AWS. So we need a provider block and we need an EC2 block. That's all what we need. So let's go ahead and find out where we are going to get that from. So if we go to the AWS registry, and as you can see at the top, we have the AWS provider. So here's an example provider that is going to create resources in US East 1, and that is good enough for us now to use it. So let me copy this. I'm going to go into VS Code and I'm going to paste it here. Of course, you could just type it. With time, you are going to get used to it and you will be able to do that by yourself. So what is missing here is the authentication part. And then what I will do, I have a profile. I know it, it's in my laptop, and we have seen it when I did the listing before in the previous demos. So now I have the profile complete for what I need to do right now. Then what we need is an EC2 instance resource. So I can go ahead here and I can type Elastic Compute Cloud. Let me just maximize it so you will be able to see it. So Elastic Compute Cloud, I have resources, and if I scroll down a little bit, I'm going to find AWS instance. So that's what I need, and I have example usage. And if you scroll down, you'll find that here is an example for that. All right. So now we have the resource for the EC2 instance, and we have the provider block as well. Let me copy this and paste it into the VS Code. So basically what this is going to do is it's going to create a resource of type AWS instance, and the name is web. I have the freedom, and we'll discuss that later on in resources. I have the freedom to name this anything because it only has local significance in the Terraform file I'm working in. And please note that the file I have opened is called test.tf. And as we agreed, the extension has to be either .tf or .tf-json for VS Code to realize that this is a Terraform file, and for Terraform to realize that this is a configuration file that I want to use as well. Okay. What is not clear now is what is this? I don't know. So I'm going to remove it. We have to put an AMI instead of this. And also the T3 micro, I'm going to change it to T2 micro, because if you have the free tier, if I have a new account, that will be a free tier and it will not be chargeable. And here is just the tag. So that doesn't make a lot of difference. So now we need to get the AMI. Where are we going to get it from? Let's go back to the AWS console. I'm going to go under EC2, the Elastic Compute Cloud Service, and I'm going to click on Instances, Launch an Instance. So I'm pretending that I'm going to launch an instance right now. Let's say I would like to launch a Red Hat real instance. So here is the AMI ID. Not sure if this is visible, but now you should be able to see it. So this is the AMI ID. It ends with 22C. But if I wanted an Ubuntu, confirm changes, then you'll find another AMI. If I wanted a Linux, confirm changes, then it's going to be a different one. So let's say we're going to go with the Ubuntu for now. So I'm going to go with the Ubuntu, and I'm going to copy this, and I'm going to take it into my VS Code. And I'm going to paste it and make sure that we don't have any spaces. We didn't remove the quotes, and we should be good to go. So now I have a configuration file that identifies AWS as the provider. It's going to create resources in US East 1, and the profile is dev.admin. This is where it will get the credentials. Please make sure that if you use a different region, you will have to do the exercise we did in the AWS console. Here, I was here in North Virginia, US East 1. If you are in a different region, make sure that you click the region. So look here, 8529 is the last word, last letters. If I'm going to switch to California, it's going to get me the same page. The AMI ID is going to be different. And let's confirm that. So if I select Ubuntu, you'll find here it ends with different letters, so it's not the same AMI ID. So this is region dependent. What if you put the wrong AMI ID and that does not exist in the region? You'll get an error and it will highlight that this is invalid AMI, and then you will realize you're doing a mistake and you'll go ahead and fix it. So AMIs are related to regions. So that's one thing. If you know it, that's fine. If you don't know it, then that's a new thing to keep in mind. All right, let's go back to the VS Code. And here I am in the configuration file. Right, so what do I need to do now? Please pay attention to what's happening here. So I have only the configuration file, nothing else, right? So let's save. When you do any changes, you have to save just to make sure that Terraform is going to apply to that configuration. And to make sure that I'm in the right directory, the right folder, I'm going to right click on the file and I'm going to ask VS Code to open a shell in this terminal. All right, these are too many. Maybe I can remove one of them. So I'm going to delete this one. All right, so what do I need to do now? Let's try to do a Terraform validate to validate the configuration. Let's see if it works or not. Missing required provider. Now it's telling me, well, I do understand the command. However, you haven't downloaded any providers. So the translators, the interpreters do not exist. How can I find out if this is correct or not? Which implies that the validation is part of the provider plugin that needs to be downloaded first, and then we can compare what we have with the provider plugin and find out. All right. So here the advice is please run Terraform init. And I do agree, we have to initialize the directory first thing. So let's find out what will happen when we do the initialization. So let me just take this one up a little bit. And as you can see here, so in initializing provider plugins, and then what did it do? It went on and it's installing the HashiCorp AWS, the latest version, because it was trying to find the latest version. I didn't add any restrictions on the version I need. And this is signed by HashiCorp, and then it's telling me that everything is green, everything looks fine. If you look at the folder again, not sure if you can see this clearly, but you'll find out that there is a Terraform folder for the providers, and there is a license to use. Let me just minimize this a little bit. There is a license to use that has been also created here that I am allowed to use this. And then the Terraform provider AWS v5 version 5.59.0 has been downloaded. And also there is a file called .terraform lock HCL. We're going to look at this one later on, but here it just states that this is the image or the version that I'm going to use from this provider. So what it did is it downloaded the plugin to my directory, to my folder, and now we can do the Terraform validate. So let's find out if we can do it now or if we still have problems. Let me clear this and I'll do a Terraform validate. Please let me know if the syntax is okay. And this is, of course, for this file. And it's saying everything is cool. So let's play around with it and find out if it's going to detect it. So let me just remove this letter. I'm going to save and I'm going to do Terraform validate again. See now it's saying peer Vider AWS is unsupported block type. So it has to be provider. Okay, fine. I'm going to put this one back and I'm going to remove a quote and I'm going to save and I'm going to try again. Terraform validate. Now it's going to give you a very common error, which is invalid multi-line string. Now it cannot detect where is the start and end because the quotes are kind of like delimiters. The braces and the quotes, they will help to find out where is the end. So now you remove the quotes and now it doesn't know whether the profile is part of it and what's going on exactly. And now it's complaining about a multi-line string. This is invalid. So if I put this one back, but then I remove one of the curly braces and I'm going to save it, clear, and try the Terraform validate again. Unsupported argument, and then it will tell me that in line number 6, you have an argument profile is not expected here. Why? Because I should have started the braces, and now we will see that colors are matching, yellow with yellow, and everything looks fine. So if I do Terraform validate now, after saving, then you'll see that it is a success again. All right, so that was all for this lab. Now we are familiar with the initialization phase, and we know that we have to do initialization before we can do the validate part. So let's look at the second step in the Terraform workflow, which is the Terraform plan. We looked at the init and validate. Now let's do at the planning phase and see what happens. So the Terraform plan command, when used, it will create an execution plan, but it will not implement it. Just the plan. Here's what I see will happen. So I'm going to add these resources, I'm going to change that, and I'm going to destroy these. That plan is for you to review and either to execute or not to execute. It's up to you. So it will let you preview the changes that Terraform plans to make to the infrastructure. If you agree to it, then you go ahead with the next phase, which is the Terraform apply. Okay, so when Terraform creates a plan, what actually happens by default? It will read the current state of any already existing remote objects to make sure that the Terraform state is up to date. What does that mean? So if you have an existing infrastructure, you did some changes to the script, and now you need to do a Terraform plan. So in that case, it has to do a refresh for the state of the infrastructure, find out what's happening in the infrastructure, find out if there is any drift that has been done manually away from Terraform by comparing that to the state file. We're going to look at state files in a bit. And then it will compare that to the script and find out the differences, what needs to be created, what needs to be changed, what needs to be destroyed. And then it will come up with, this is what I will do if you want to apply this exactly at the moment. And then you review, decide yes, no, maybe, and then you go to the next step. So it will compare, as we mentioned, the current configuration to the prior state, and it will note any differences. And it will propose a set of change actions that should, if applied, make the remote objects, the infrastructure, exactly like the scripts and the configuration files. That's what the plan phase does. The function of the Terraform plan is speculative. What if you do the plan, then you go to lunch, and one of your colleagues was working with you, and then he goes into the script and says, what is this for? No, just let me remove that one. If that happens, and then you come after lunch, and he saved the file after removing that, and you do a Terraform apply, guess what? You are not applying what you have seen before lunch in the plan, because that was based on the configuration file at the time before you went to lunch. But now you came back from lunch, and now the script is different. And you will type Terraform apply, hit enter, and then it will ask you, do you approve? Yes, go ahead. Guess what? It's now doing what you expected to be done minus that resource that your colleague has removed. So, okay, what's the solution to this? The solution is when you are doing a Terraform plan, you can output the plan into a file. So you go to lunch, you go meet someone, you finish, and then you come back, then you apply what is in that file. And even if someone tampered with your file, it will not be the file that will be implemented, but the plan that was out of the Terraform plan and you saved it in a file, that will be the file that will be applied. But of course, you have to do Terraform apply based on that file, not based on the script. So these are ways where in a team setting that you can make sure that this is the file we need to deploy. So if anyone played with the infrastructure, please make sure that this is what we're going to do. So in an automated Terraform pipeline, we're talking here about automated like CI/CD, like the software pipelines, applying a saved plan file will ensure that changes are the ones expected and scoped by the execution plan. So that's a smart way to do it. If you do a Terraform plan and that's it, Terraform will tell you, this is what I'm planning to do, but please be careful you did not save it to a file. If you want to save it to a file, then you add the -out equals and the file name of your choice. And it's going to be in the same directory. Or you can have the Terraform plan and the output in JSON format. And this is the directory where, or the link where you can find this into the HashiCorp CLI. So let's click on that and visit it. So this is the plan command, and you'll find here the usage and planning modes, what you can do, and the different options and all that if you would like to read more about it. We did not explain variables, so don't worry about it. All right, so let's go ahead and do a hands-on on the Terraform plan to understand it better. So on the same file that we have here, now we had the initialization and we had the validate. Now let's go ahead and do a Terraform plan and see what will happen. So we have here that it states, let's just pull this one up and see what the Terraform plan does exactly. So Terraform plan, Terraform used selected providers to generate the following execution plan. Resource actions are indicated with the following symbols, and here it's saying that wherever you see a plus sign green, then that means this will be created. Terraform will perform the following actions. It will create an AWS resource, instance resource, and the name is web, and it will be created. Then it will create the AMI, and this is what we provided. A lot of other things are going to be specified after you do the apply because they are not known yet. The instance type which I provided is T2 micro, and there's a lot of other things that are going to be provided once they have been done. And then we have the tags, the hello world tag that we are providing right here, and anything else is going to be also provided after the apply. The result is 1 to add, 0 to change, and 0 to destroy. You didn't use the out option to save this plan, so Terraform can't guarantee to take exactly these actions if you run Terraform apply now. Because maybe someone, if you are reading through these 2 hours after you did the Terraform plan, maybe someone changed that. So you either do a Terraform plan again and check the recent one, or you do a Terraform plan out to a file. So for example, I'm going to do here, Terraform plan, and then -out equals, and let's say I'm going to say plan at, let's say the time I did it, 12:00 noon, and that was on, let's say 13 September 2050. Okay, so I'm going to hit enter and see what happens now. And you'll find that there is a file that is created, plan, and whatever I have written. And if you see here, it's not open, it's not in a format that you can read, but at least I know that I have it. And here it's to perform exactly these actions, run the following command to apply. So Terraform apply, and then the name of the file between quotes, between double quotes. All right, so now I have the planning done, and we have looked at it, and it works without issues. What we have not seen here is it did not refresh. So when I did the Terraform plan, let me just bring this up again. So when you did the Terraform plan here, when it started, it didn't do a refresh because there isn't an existing configuration or infrastructure. After we do the apply, we're going to do a plan again, and you'll see that it starts with refreshing, reading the status or the information about the existing infrastructure, and then comparing that to the configuration file and deciding what will happen exactly. That is how it works. Now let's look at the apply phase. So we have a configuration file. We did the initialization of the directory, and we have done the planning. We reviewed and we made sure everything is fine, and we took the output to a file that we know, the plan 12.00 13 September 2050, the file that we have seen. And the next step is we need to apply it. This is what we're going to discuss right now. So the Terraform apply has the mission, or has the action of, if we have an infrastructure, Terraform is going to check the status of the infrastructure, compare that to the configuration file, and then it will decide, okay, here are the changes that are going to make everything look like the configuration file, which we call the desired state. What if we don't have an existing infrastructure and we did the planning already and we have reviewed and everything is fine? Then Terraform is going to take whatever is in your script of resources and instructions and is going to start passing that into the provider or providers, the plugins that are relevant, and they are going to start generating API calls to the respective providers or platforms in order to execute what you have asked for. Of course, if the authentication is right, the profile is right, and everything is okay. And as you can see here, the apply without any extra keywords is going to ask me always for a yes if I accept and approve to proceed. And then it will start creating whatever needs to be created, and then it will give you a feedback that this one has been added, 0 has been changed, and 0 has been destroyed. Of course, the number of how many have been added and how many have been changed and how many have been destroyed depends on how big or small and what are the actions involved in your configuration file compared to an existing infrastructure. All right. So what's the command we use? We use the Terraform apply without any keywords. So this is going to initiate the execution of the plan. And then we have the Terraform apply. If I don't want to type yes every time, then I can do -o to -approve, which means don't ask me to approve and I don't have to type yes, just proceed as if I'm telling you you have everything that you need in order to proceed. And of course, I can provide the planning file that I need to be executed as we explained in the planning phase. All right, so now let's go ahead to the VS Code and let's play with this for the same configuration file we did before, the one that creates an EC2 instance. Let's go ahead and move to VS Code now. So as we have seen before, we have done through the plan and we had the output, which is the plan 12.00 13 September 2050. It will tell me that if you want to apply this, or you would need to use this command. So let me copy and paste the command and go ahead and apply it. Notice what will happen here, that there is a TF state file that did not exist before, but now it has been created. And if I click on that, you'll find that it is empty right now, but the instance is creating. And as soon as the instance gets created, you'll find that this file gets populated with the information about the resource that has been created, which is the EC2 instance right now. And that's how Terraform continuously finds out every time there is a change or update in the file. Then it does a refresh first, find the differences, and then compare that to the file, and then it's going to decide what needs to be done. As you can see here, it is completed. I have an instance 7C13, and you'll find that the file has been populated. So I have the file has no outputs. We'll talk about outputs later on, and then resources, and that's a list. So I will have multiple items if I have multiple resources. And then I have the mode managed, and the type is AWS instance, and the name is web. And if you scroll down, you'll find the AMI that we have supplied. You'll find the ARN, or the Amazon resource name, the ID of the instance, and which availability zone it has been created in. And then if we scroll down more, you will find here the instance ID again. What's the status of the instance? It's running. The type is T2 micro. And if we go all the way down, we'll find private IP address, public IP address, and also the tags that we have provided, the hello world tag. So as you can see, Terraform, through the TF state file, it reads everything about any change or any new resource that it creates. And that's how it maintains that. And that's how it finds out what was the last state after we did the last change or the last resource created. And that's how it will be able, if anyone did a manual change, to compare. So it will refresh again. Let's try now and do one thing. Let me try to do a Terraform plan again. You'll find that the very first thing, because it has a TF state file, it will read the information first before deciding if there is anything that needs to change or to be destroyed. So if the very first thing, it is refreshing the state of this resource, the 7C13, and it found that it is identical to what's in the TF state file. And also there are no changes in my configuration, and that's why it is okay and it doesn't want to do anything else. If I did, for example, that here I have the environment, and I'm going to say equals, and I'm going to add another one, prod, for example. So now I have made a change, and let's try to do the planning again. So Terraform plan once more. Now, there is nothing changed in the infrastructure, but there is a change that has happened in the file. So that's why it will say 0 to add, 0 to destroy, but there is 1 to change. And if I scroll up a little bit, I'll find out what needs to be changed, and it would say that this is a change in place, and tags environment production needs to be changed. And if I do a Terraform apply again, let me just clear this, Terraform apply once more, you'll find that there is a new tag that has been applied, and it will also be added into the TF state after it has been applied. So let's see. It's asking me if I approve, and I'm going to approve, and you'll find that change has been done. So now it is modifying, not creating. And if we go ahead now and check our instance for tags, let's see. And we have two of them. We have env and production. Let's go ahead and remove the tag and see if Terraform will be able to find it and delete it. So I'm going to go back to the file again. Let me just get this one down, and I'm going to delete this file, save, and apply again. Clear, and we'll do an apply again. It will ask me for the approve. Yes. Modifying again. And there is one that has changed, and if I update, I should see that one gone, and it is gone right now. All right, so that's about the apply, and as you can see, it always refreshes before applying, and if the infrastructure was changed, it will always do also refreshing before planning. So now we are at the Terraform destroy, the last one in the workflow. And this is being used if you would like to destroy specific targets, or we are done with the project and would like just to destroy everything we have created. That is managed by the Terraform configuration file and the TF state file that we have at hand. So Terraform destroy is a convenient way to destroy all remote objects managed by a particular Terraform configuration, the one that we are going to use the Terraform destroy from the respective directory or the directory of that one. So we can use the Terraform destroy, hit enter, and then whatever is in the TF state from a managed resources, it's going to refresh, look at that, and then it's going to find out from the TF state file what is managed, and it will ask you to approve, and then it will go ahead and do it. Of course, I can use the minus or the hyphen auto approve as well here, and that is going to do it without asking you. So that is also possible here. What if I need to destroy a specific resource, not anything? Then you can do Terraform destroy and then hyphen target, and then you put the name from the TF state, so the exact name of the resource from the TF state. You can also do Terraform apply hyphen destroy. This is similar to this one, but this is basically an alias for the Terraform destroy command. And then we can do Terraform plan hyphen destroy. So the apply hyphen destroy, it will destroy the resources. Plan hyphen destroy means tell me, give me a plan, show me what will happen if we use the destroy command, and it will give you the output and it will not execute a destroy. So this is helpful if you'd like to see first what will happen in case of a Terraform destroy before you go ahead and do it. Apply hyphen destroy will execute the destroy. But plan hyphen destroy will do a plan and show you what will happen if you use the destroy without executing it. And then of course we can get the minus help or the hyphen help if we would like to know some help about the Terraform destroy command. All right. All right. So let's go ahead and do that in the VS Code. So we have here our infrastructure, the one that we have created before. And now when we look at the TF state file, we'll find out about the managed resources. What do we have available? And when you look at the resources, we have one, that is the AWS instance. And that's it. That's all what we have here. So now what I need to do is just to provide the Terraform. Which one do you want to do? The destroy or the apply-destroy? Destroy, I am sure it's going to destroy it. We have seen it before. So let's do a change here and use the other one, the Terraform apply-destroy, and see what will happen. So it did not ask me about which resource. What do you need to do? So it will refresh the state based on what it knows here. And then it will tell me there is only one resource you have and I'm going to destroy it. Do you approve? And I'm going to say, yes, please go ahead. And guess what will happen? It will be destroying this resource. It will take some time and then it will give me feedback that job is done, mission accomplished. I have destroyed your infrastructure. And if I have multiple resources, then I need to know the name of the resource that I need to destroy. And then I'm going to apply it. And we can look at that later on as we go into the names and resources and all that. I don't want to jump gun right now. All right, so getting close, get ready. Okay, and there you go. So 0 added, 0 changed, 1 destroyed. If you look at the Terraform state file now, you'll find that the pages and pages we had, now we have no resources and I have no outputs. And basically, this is all our TF state file right now. A good thing that we have is we have a backup of the file. So in case if you have deleted that by mistake, you can just remove the .backup and make that the new TF state. But here I'm not going to do it because we have deleted the resources and I know we have deleted the resources. Okay, so now everything is cool and I can just close that one off, but let's confirm that on the console it has been removed. If I refresh, as you can see, we don't have anything running. And if I remove this, you'll find that the 7C13 hello world has been terminated. So we are good to go. And this is a good practice after you do any lab testing, any project you are trying and all that. Please go ahead and make sure that you did the destroy. And it will be helpful if you make sure that also it has been removed and make sure that you are in the right region so you can see the resources where you have been playing with. Let's now do a deeper dive into Terraform resources and understand a lot more information about them. So what's a resource in Terraform? We're using Terraform to create things somewhere, right? Maybe create EC2 instance on AWS or create a VPC in AWS, create a subnet, or maybe create a VNet virtual network in Azure, or maybe a virtual machine in Azure or similarly in Google, or maybe on premises. So I'm using Terraform to create an infrastructure for me, services for me, and then manage them on my behalf. And maybe when I don't need them anymore, just destroy them, as we have seen before. So that's what the resources are. What do I need to create a resource? We need to create a resource block. So the configuration will end up being a number of separate resource blocks. You can do references among them, but they are very easy to write. It's a separate block, then followed by another block, followed by another block, but the resources are different. So the syntax is, you need to start with the keyword resource for sure. Then you need to provide the resource name as documented on the Terraform documentation, because that's the only way for Terraform to understand, or the provider plugin to understand what you're trying to do. And then you have a local name that has only a significance within your directory or the set of configuration files or the one file that you are using. So this has only a meaning to you. It does not have any meaning to the provider. Then you need to leave a space indentation, and then you write your argument or arguments. Some of them are a must, some of them are optional. So here's an example that we have seen before. Resource. That means Terraform knows you are trying to create something, a resource. The type is AWS_instance, and you don't have a choice about this. This is how it is documented by Terraform. This is up to you to define. Please don't forget the quotes. So this is the resource opening statement, and then you have the opening curly brace and the closing curly brace. Then you define arguments. You can be very specific or you can be very general. It depends on how you want to lock it down. And then you put the AMI, the instance type, and so on. The name of the arguments, it's not up to you. It's how it is documented as well. So to find out more about the instance and the type and the arguments and all that, let's go ahead and visit this link on the AWS registry or the AWS provider on the Terraform registry. So if you look here, this is the resource AWS instance, and it is very clear, provides an EC2 instance resource. Where did it get it from? The link, we copied the link, of course, from here, but if you scroll down to the letter E, you'll find Elastic Compute Cloud, and within you have the resources. And if you scroll down, you'll find the AWS instance. So you can look at it here, or you can just go on Google and write AWS instance resource Terraform. And that's it. You will be given that link. Click on it. You'll open this page. It's up to you, however you would like to do it. On the right-hand side, you have the argument reference and the attribute reference. So these are the arguments and how they should be written, and it's up to you to choose which ones you want to include, unless if they are mandatory. And then the attribute reference, this is information about the resource after it has been created, like the instance ID, the public IP, the private IP, and so on. So this is what you can add, the list of what you can add in the arguments, starting with the AMI, associate public IP address, true or false, availability zone it will end up on, and there's a lot more parameters that you can go through and find out which one is relevant to you. The instance type, we have used it multiple times. The key name, if you are using SSH keys, and then you have the launch templates and so on. The placement groups, if you'd like to do that. Private IP, if you want to allocate it. And security groups, if you would like to provide this. And here, if you look at the right-hand side, it will tell you what type it should be. So this has to be a list of one or more security groups. So they have to be within brackets. Otherwise, it will not be accepted. You will get an error. Secondary private IP address if you want to allocate one, and so on, and the tags and the subnet IDs and so on and so forth. And you can see here it is optional or if it is mandatory. So if it is mandatory, it has to be there. If it is optional, it's clear. It's up to you if you would like to include it or not. How about the attributes? So these are the arguments, and if you decided to include any one of these, it has to be exactly in the same format that it is written right here. So user data, user_data. Nothing more, nothing less. No upper, lower case, just stick to how it is written. And then we have the attribute reference. And here, information about the instance after it has been created. So I have the ARN, I have the ID, password data, primary network interface ID, private DNS, public IP, and so on. And again, you have to stick with how it is written, the tags, the volume ID, and so on. Okay, so this is the list of the arguments and the list of attributes, and you have to stick to how they are documented and written here. The local name, as we mentioned, has only a local significance, and it has no meaning outside the module. And by the way, when you have a directory you are working on that has one or more Terraform configuration files, this is called the root module, the Terraform module. That is the directory where you are working basically. What if we need to create two instances? So you said, I can't change this, but I can change this. If you would like two resources of the same type, the local name must be different. You cannot have two resources of the same type with the same name. So it's better to use different local names for your resources within the files. As you mentioned, there are arguments and attributes for each resource, and it depends on how it is documented and also the type. Is it an integer? Is it a string? Is it a list? We have to find that out from the documentation. And of course, if we go back here, you'll find always there are examples, good examples at the top that you can use, and we can just grab this one instead of typing. I'll grab it, I'll paste it, and then I'll massage it a little bit, delete something, add something, and that's it. So this becomes my EC2 instance configuration. It's up to you. You want to train on typing that from scratch? Again, it's up to you. However you would like to do it. Depending on which resource we are using, some arguments, they must be declared. And that's up to the documentation, and others, they could be optional. So we can include them or exclude them. So as we looked at the AWS instance resource, we found out there were so many arguments, but it's up to us. We included the AMI, the instance type, and tags because this is what I need. I can add more, I can add less, it's up to me. Here's another example. If I would like to create a resource for an IAM user in AWS, so the type is AWS_IAM_user. The local name I used is administrator, and this is the name that is going to be in AWS. And then I have the tags. If I would like to visit the page for the IAM user and find out about the arguments and attributes, you'll find that here is it, the AWS_IAM_user. And this is in identity and access management service. If I scroll down under resources, you will find that here is the IAM user, and this is where I am exactly right now. Examples, here's an example. You can just copy it and paste it, and you should be good to go if you wanted to. And I can look at the arguments. So here for that name, it is required. It's not up to me to include it or not. It has to be an argument in the documentation, but as you can see now, we have optional other stuff that I can assign, and the number of arguments are very limited because that's what you need. I mean, that's the maximum you would need for an IAM user, and also the attributes are also very limited, as you can see. All right, so that's another example, and then we have a very important thing, and that is, how can I reference one of the attributes, the documented attributes, not up to me, of a resource in my configuration files? So here, for example, I have an AWS instance. That's the type, that's the local name. And I'm assuming here that I have already created it, so the attributes are available. Now, how can I reference them? And that's very simple. Put the type of the resource dot the local name in your configuration dot the attribute that you'd like to reference. And again, these attributes are based on what is documented, and it has to be as it is written in the documentation, not up to me to decide. So the general syntax, resource type dot local name dot attribute name. That's how you reference it. And here's an example. Now I need to cross-reference one of the attributes of an EC2 instance inside a block that creates an elastic IP. So how can I do this? Here, for example, you'll find that this is a reference for, here's the resource type, local name.id. So that's the ID of this EC2 instance. Why am I providing this as a value for an argument called instance in an elastic IP? Let's find out. And also, what is the domain equals VPC? Let's go ahead to the documentation and find out how this is documented. So here's the elastic IP, AWS EIP. And if you would like to find out where this is going to be, this is under Elastic Compute. And if I scroll down, you'll find that we are here exactly under the Elastic Compute Cloud. If I look at the arguments, you'll find the address. And then if you scroll down, you'll find the domain. There is no word optional here. This means it is going to be used with a VPC or within a VPC. And then I have another argument I can have, and this is an EC2 instance ID if I want to allocate this elastic IP address to an EC2 instance. So it has to be the ID, not the public IP, not the IRN of the instance or anything like that. Okay, so that means I am associating the elastic IP that I have created here with this instance, and I am referencing the ID by the type, local name, and the .id. All right, so let's take another example on this. Hopefully it becomes more crisp. So the other example, I would like to create an ad gateway, and I would like to allocate an elastic IP for it, but beforehand I would have to create the elastic IP. So resource elastic IP and a local name. Domain is VPC, and that means it is going to be used within a VPC. I have to have it if I'm going to use it with a VPC. There is no instance equals here because I'm not allocating that to the instance. So we go to the resource AWS underscore NAT underscore gateway, and here is the local name. Now I need to allocate the Elastic IP to the NAT gateway. So the allocation ID, what do I need? I need the ID of the Elastic IP resource. So the type local name.id, and that's how you assign the Elastic IP to the NAT gateway. Let's go ahead and take a look at the NAT gateway in the documentation. And here is the resource, AWS underscore NAT underscore gateway. And then if you scroll down, you'll find here the allocation ID, like the example we have done. And if you look at the arguments, what does the allocation ID mean? It's an optional attribute, and this is the allocation ID of the Elastic IP address for the NAT gateway. So that's what the ID is. And also here I have another attribute that is mandatory. I have to include it, and that is required, which is which subnet is going to end up on. And as you can see in the example, they have it here as well. So here I'm assuming, although it's not shown here, there is an AWS subnet type, and the local name is example, and this is the ID of the subnet, but it's not shown here in this snippet. So if I go back to the slides, that means my configuration, and that's why we put the dots. So if there is anything else mandatory or optional you want to add, you can add it here. All right, so that's it about the resources. Hopefully it is clearer now and you are more familiar with the documentation. If you would like to start typing and get yourself used to writing all of these on your own, that's fine. If you'd like to just do it the way I prefer, which is go to the documentation, copy it, bring it back, look at the arguments, add the ones that you want, and this will become your reference for that specific resource. Build your references with time and check the documentation every now and then to find out, or what if there are any updates, incorporate them, and that's it. All right, so let's now do a hands-on lab where we are going to build a main configuration file or a Terraform configuration file from scratch. We will deep dive into how we can build resources from scratch, and also how we can cross-reference attributes of a resource into other resources. So let's go ahead and jump into it and find out what we need to do. So here is what we need to do. We need to do these 3 tasks, which include 3 different resources. In Terraform, by the way, if you want to write comments in VS Code and you don't want these to be interpreted as commands or as Terraform code, you just do at the beginning a /* as like this, and then at the end of the comment or the lines you want to comment, you can do an asterisk and then /. This automatically will be considered as comments without having to do a hash at the beginning of each line. Okay, so what do we need to do? We need to create a VPC in US East 1, and the CIDR block is this CIDR block. It's up to you if you want to change the region, but please pay attention to which region you created this in, because you need to go on the console and check and verify that it has been created and deleted afterwards. After creating the VPC, we'll create a subnet with the CIDR 10.0.2.0/24 into the above VPC. So now, since we said into the above VPC, we have to cross-reference the VPC into the subnet configuration. Then create an S3 bucket in the same region. All right, and I have an empty file. So we'll start from scratch. Let's start with what we have learned before. I need to configure this to work or to create AWS resources, right? So I have to define a provider. And since we have the plugin for Terraform, then it understands what I need to do. So provider, and then it's going to be AWS. The brackets are available. And now if you are typing this, you need to just indent a little bit inside. So it will be under the block. And then I'm going to write here that I need to work in region, and the region is going to be, as requested, US East 1, and that's it. Then authentication. If you have a default profile, you don't need to do anything else. If the default profile has the right credentials to work with VPCs, subnets, and S3 buckets. If you have a profile that you want to work with, a specific one that has the credentials you want, then like in my case, it's called dev admin. In your case, it might be called administrator, Joan, Smith, Sarah, whatever the name is. So now I'm ready to initialize my directory. And now Terraform will understand that I need to work with AWS, that's why it's going to download it. So if I do a Terraform init now, it's going to download the latest version of HashiCorp AWS, and that means I'm ready to go. As you can see that there is a Terraform directory here created and the log HCL file. We'll talk about this later on. And how did it find out that this was all Terraform? Because I wrote the file name is main.tf. All right, so in your case, it could be test.tf, configuration.tf. As long as it is .tf, Terraform will kick in and deal with this file. So let's now clear and look at the requirements. I need to create a VPC in US East 1, and here's the CIDR block. That's fine. Let me go to the documentation. Here is the documentation, and I'm going to go under Virtual Private Cloud. Here's the VPC resources. I'm going to scroll down until I find the AWS VPC. And luckily, the subnet and the VPC are on top of each other. We'll need the subnet next. So here's an example or multiple examples of the VPC. Let's take this one. And luckily also it's the same CIDR block. So I'm going to get this, go to VS Code, and then I'm going to paste it in VS Code. It doesn't matter if you paste it at the top or at the bottom, it doesn't matter. It's going to look into it. I don't have anything to do with instance tenancy required here. And this is the right CIDR block that has been requested. And it's up to me if I want to call it main or I can call it lab VPC. So this is a local name, has only significance within the file I'm writing right now. And now we have done that. It's up to me if I want also to call it main or call it just custom underscore VPC or lab VPC or Dolphin Edge VPC, whatever the name you would like. This is just a tag, a name for the VPC, so it's easier to locate on the console. All right, what's required next? Subnet with CIDR block 10.0.2.0/24 into the above VPC. So let's go to the documentation. I'm going to go to the subnets. And if I look here, I will find that here is the resource, AWS subnet. It's called main in this case. VPC ID, so there is a reference to a VPC where the subnet is going to be created. And that's the reference, or this is how the attribute, the ID of the VPC is referenced. And here is the CIDR block and the tag. Well, let's look at the VPC ID argument, the details. So the CIDR block is the IPv4 address, but then I need to look at the VPC ID because I need to understand. So this is the VPC ID where the subnet is going to be created, and it is required. It's not optional. So it has to be there. All right, okay. So let's go ahead and copy what we have here. And I'm going to go ahead and paste it in VS Code. Here it is. Now, how can I cross-reference? I have, if I want to define the VPC ID, then I want which VPC. This is the VPC I want. How can I write the VPC ID or the attribute for this VPC? It should be AWS underscore VPC dot local name lab underscore VPC dot ID. Here it is AWS VPC main dot ID. So this is the wrong VPC. I need to have it under lab VPC. So now it's exactly the same name and we are good so far. Now it's up to me what I want to call this. I can call it first subnet, for example. All right, then I need to create an S3 bucket in the same region. They didn't give me a name, so I need to choose a name. All right, I'll go here and the S3 is under simple storage. If I click enter, and then if I go up, simple storage, and then the first resource is the S3 bucket. Let's look at how it is configured. And here's the type, and this is the local name, and this is the suggested name for the bucket on AWS. Be careful because there will be tens or thousands or maybe millions of people who tried the S3 bucket creation, and maybe some of them are using the same name. So it's better to have your own name in this case to avoid any errors. Going back to the VS Code, and then I'm going to paste it here. And I'm going here to remove this completely. And I'll call it Dolphin Ed. And then 1, 2, 3, 4, A, B, C, D. I think this is a good and a unique name. It's up to me if I want to leave this as is or just call it bucket test. And these are the tags. It's up to you. We can just have one tag. That's enough to identify it, my bucket. And I think now we are done. There's nothing else here that we need to do. So what we need to do now is I need to save. And then I need to go ahead and plan, make sure that I'm going to have the 3 resources planned to be executed. And it tells me that there are 3 to add. If we go up, we'll find out here's the VPC resource with the CIDR block we provided. And okay, I noticed a mistake here. So this is 10.0.1.0. I think the requirement was 2.2.0. So AWS subnet, and the name is main. That's fine. It's going to be in the VPC that will be created. So we'll know the VPC ID after it is created. And then we have the S3 bucket resource that will be created. Okay, fine. Now we need to go ahead and fix the subnet to be .2.0, not .1.0. So don't just copy and paste without reviewing. And it was great that we did the planning, so we spotted that mistake. All right. So let me now go down, clear, save, because we did a change the subnet value. So we'll save, and then we'll do a Terraform apply. Of course, you can do a plan once again just to make sure that everything is okay. But in our case, it was only that glitch that we noticed. The auto approve will have Terraform applied without asking me or waiting for me to enter yes manually. So I'm going to do auto approve. If you have any errors, it will appear right now. If you have no errors, then it will go ahead and create everything without any issues. So now, as you can see, it has created the VPC, and it has created, so the lab VPC, the bucket is complete here, and the subnet is completed here, and the VPC is completed here. If we go on AWS and check this, I'm going to go on the console. Let's check for the buckets. Let's check for the bucket. Let me refresh this. And we have it, Dolphin Ed bucket, 1, 2, 3, 4, A, B, C, D. And if we go under VPC to check what's going on, and your VPCs, and make sure you are in the right region, we have here the custom VPC, and it ends with DA0B. If I go to VS Code, DA0B, as you can see, then we are missing checking on the subnet, and we should be good to go. Subnet, and we have the first subnet, and it ends with 43D4. And here we go, 43D4. So now I have the resources. If I check the TF state, I'll find that we have 3 resources. We have no outputs yet. We have 3 resources. And if I bring this down, I have the S3 bucket with the name we have provided, as you can see here. And we have the tags, my bucket. And then we have a second resource managed, which is the AWS subnet. And then we have the 43D4, as we've seen, and the right CIDR block. And the first subnet, the tag. And then we have a third one, which is the AWS VPC, Lab VPC, and the VPC ID DA0B, as we have seen. Now it's time to destroy it. And I want you to notice one thing when you go about the destruction, that Terraform now knows that we have infrastructure in place. So if I do Terraform plan or destroy or anything else, the first thing it will do, so let's say, for example, if I will do a plan, it will refresh the state, read the information about the resources again to contrast that to the configuration file. In this case, I didn't do any changes, so it will tell me no changes. What you have in place is exactly what you have in the configuration file, so there are no changes. What if I call this, for example, my bucket 1, and under the subnet, I'm going to call it subnet public. First subnet, and then hyphen public. So now there are things that needs to be changed. And if I do a save, Command S, or if I go here and do a save, then if I do a plan again, now there are differences, but these are only changes. It doesn't require destroying the resources and creating new ones. But still, it does a refresh, finds out if there are any differences, and then here it's saying Z2 to change. This is how it works, okay? So I don't need to do that. I'm just going to do a Terraform destroy and auto approve, so it does not ask me for anything. It will just go and destroy the configuration we've had. And these resources are light, not like the EC2 instance. The EC2 instance takes time to initiate, like 50 seconds or so, but these ones are only a few seconds. Now, what if you want to redo the lab and you want to do it from scratch? What do you need to do? The TF state file is now blank, doesn't have any resources. So if you delete all the files except for your configuration, you can go ahead, and this is the backup of the TF state. In case if you deleted the other one by mistake, all I need to do is just rename, and then I do remove this here, and then it becomes the TF state file. But of course, this is wrong because now we deleted the infrastructure. So it doesn't make sense to bring a TF state file again, which does not exist. Now, I will delete this. I don't need it. I just wanted to explain what the backup is all about. And then if I delete the directory and the file, then my directory is going to be a blank one that doesn't have anything. How can I confirm that? If I did a Terraform plan now, it will tell you that please run Terraform init. If I do a Terraform apply, it will ask you to do Terraform init. If I do Terraform validate, it will ask me the same thing. So basically, you have brought this one back to the initial state, and you can do the lab again and again and again. So now you know how to start from scratch and how to bring it back to square one again after you finish, if you want to redo the lab again, or if you want to keep your configuration files in a clean state that can be used anytime. There is a dependency between the resources we create. So let's say, for example, I would like to create an EC2 instance, and I would like to create an S3 bucket. But the instance, when it is loading, it will download something from the bucket. Or maybe it will upload something in the bucket. So I need to ensure that the bucket is going to be ready before the instance is created. Or it could be that I need an EC2 instance and I need to assign an elastic IP address to the instance. So when I create the elastic IP address, we need to have the instance ready to assign it to it. These are dependencies. How can we handle that in Terraform? This is what this video is all about. So there is an implicit dependency and there is an explicit resource dependency in Terraform. Implicit means Terraform will understand it by itself. It will automatically find out the dependencies, and then it will do the sequence of resources according to that dependency between the resources or among the resources. To achieve that, Terraform will build a graph, a Terraform graph that will show all the dependencies, and based on that, it's going to decide which one should be created first, and then second and third, and so on. So how can we have that implicit dependency? How would Terraform know by itself that from the configuration that this one depends on the other one? And here's an example. We looked at it before. So let's say I want to create an EC2 instance. Here are the details of the instance type, and the AMI. And I would like to create an elastic IP, and the elastic IP will be assigned to the instance. So how would I tie or reference the instance into the elastic IP to clarify or explain to Terraform this elastic IP should be assigned to the instance? We did it before. I have the instance argument under the elastic IP, and I'm going to reference the instance local name and the ID. The instance type dot the local name dot the ID. This is exactly what we are doing here. So from this line, Terraform automatically, it will comprehend that we need to create the instance first before the elastic IP. Even if the elastic IP comes at the top of the configuration file, still we need to grab the EC2 instance first, create it, and then do the elastic IP and do this functionality. How can we confirm this? Let's go ahead into our VS Code and do a lab on this. So let's look at this hands-on lab, and that's exactly what we have seen in the file. So this one has the provider, AWS, and then it has the resource elastic IP, my EIP, and it is going to be used in a VPC. And then we have this reference to the attribute of the instance, but it is hashed. Since it is commented like this, that means Terraform will behave as if it did not see it at all. You want to confirm this? Let's remove it completely. All right? So now we don't have it at all. All right? So now we have a resource, AWS instance, the type, and then the local name, and then we have the T2 micro, and then we have this AMI. What we need to confirm here is that this AMI is existing in US East 1, otherwise we could get an error. So now there is no dependency whatsoever between the two resources. There are no cross references, and that's why Terraform would say, okay, fine. I'll create this independent from one another, and that's it. So let's open it in the integrated terminal. Let's save because I have removed that line. So you are not going to suspect that Terraform read it or implemented that. So we'll do initialization. Now it will be initialized. We'll have a directory downloaded here with the plugin provider. So I have it locally, the translator or the interpreter. I'm going to do clear, and I'm going to go ahead and do Terraform apply. Realistically, and in production, you need to do plan and review. But this is very simple, and we need to go straight to the point. So I'm going to do apply with auto approve, so it will not ask me. Let's find out which one will be created first in this case. So it's creating the Elastic IP first, as you can see, and then getting into the instance. The Elastic IP creation finished, and the instance is still ongoing. So in that case, it took the first resource and then it went into the second resource without any dependencies between the two, which is fine. So the instance will be completed. We are going to destroy it. Okay, let's do Terraform destroy with auto approve, so it will not ask me about to stop that. And I will tell you why we are doing this. So now it will go ahead and destroy it. Now let's go back to our configuration. So the destruction is ongoing. Don't worry, it's going to be removed, I promise. So it's destroying the instance right now, and the Elastic IP has been removed or destroyed. So let's go ahead to the documentation now. And I want to put back the Elastic IP. So Elastic IP. And if you go under Elastic Compute Cloud, we'll find it somewhere. It's right here. And what I need to do is to get the cross-reference to the instance. And I'm going to go back and paste that one back again. So I'm going to go here, and here is the instance. And the ID needs to be different, of course, because this is called my EC2, not web. So my EC2. And now they should be identical to this one. So now there is a reference in the Elastic IP to the instance, and I'll do a save. And destruction has been completed. So let's do a clear. We'll do Terraform apply, and let's see if it will change the sequence. So this one is still at the top, and let's see what will happen right now. Yes, go ahead. And we'll see. So now it will start with the instance first, because now it understood the dependency. And after the instance is ready, it will go ahead and start creating the Elastic IP. Despite that, the fact that the instance creation takes about 40-50 seconds, it will put the Elastic IP on hold until it creates the instance, and then it will go ahead and create the Elastic IP and then assign it to the instance. So as you can see, it's implicit dependency from the configuration. Terraform by itself can find out what's going on, build that graph, and from the graph, it can identify who goes first and who should follow because of these dependencies. So only now, after the instance was completed, then it started creating the Elastic IP and it worked. So this one took 45 seconds and this one takes only 3 seconds, but because of the dependency, it made the sequence right in order to be able to make this happen. And that's the ID and Elastic IP allocation. So let's find out from the TF state what are the values of these resources. Let me find out what's the instance ID. The instance ID is E31B. I'm going to go here and I'm going to go into instances to confirm. And I need to know which instances are running. I have only one running. And if I click here, you'll find that the IP address. Let's check the Elastic IP address. Here's the Elastic IP address, 54.158. So let's go back. So this is the Elastic IP. So the value is 54.158. And if I go on the instance, on the instances, and I have the running one, you'll find that 54,158. So it has been allocated to the instance, and this is how the implicit dependencies worked in our favor to fix the problem or to get us to where we want it to be. So now let me go ahead and I'm going to clear and destroy Terraform. Destroy. Let me just bring this one up. Okay. So now destruction, it doesn't matter which one goes first. Terraform will handle that with AWS and we don't need to care about this. But now the destruction is working fine without any issues. All right, so it's destroying and everything is fine. Now let's look at the explicit dependency. And as I mentioned before, if you want to bring this one back to the initial state, all you need to do is to delete these files. Just to show you once again what is happening. And after destruction, of course, the TF state file is going to be blank again once everything is destroyed. And as you can see, it is blank again. We can go ahead and remove these two files. And now you are back to square one and you can redo the lab as you like again. For the explicit dependency, now what if I cannot configure the dependency implicitly in the configuration? So for example, I have an EC2 instance that when the instance boots and runs or gets created, I wanted to either download something from an S3 bucket or upload something in an S3 bucket. There is no argument I can put here that in the configuration that is going to say upload or download to that specific bucket. So there is no way to do that. So how can we compensate for that? I can use the depends underscore on argument. And then I put a list that identifies what is it that I need to depend on. So here we have a resource with the type S3 bucket dot and then the local name. So what I'm trying to say here to Terraform, I'm saying that there is a bucket resource of type S3 bucket and the name is the local name is example. The EC2 instance needs that bucket and it depends on that bucket. So please make sure that the bucket is available before you create the EC2 instance. So that's the explicit dependency because it cannot be configured in the configuration. We cannot put any attributes about the bucket into the configuration to be implicitly understood. And both implicit and explicit dependencies affect the order as we have seen, and we'll see now for the explicit as well. So they affect the order that the resources are going to be created or destroyed. By default, Terraform, as we mentioned, will analyze and determine the resource dependencies and build the graph. And based on that, we'll find out which resources go first and then which will follow. Using the depends on argument can be used to create explicit dependencies, as we just said. This will tell Terraform that the creation of EC2 instance, for example, in our previous example, depends on the S3 bucket. So we have to be careful that you create the bucket before the instance. But when using the depends on, it's very good to add a comment to explain why we are putting that in. So if anyone is looking at the configuration, they will make sense of why we did this. So let's do a hands-on lab and find out the explicit dependency and how it works. So let's go under the explicit dependency now, and I'm going to go right click and move the cursor into that file. And I can do pwd, and here also I can do ls to make sure that I'm in the right directory. Let's do a Terraform init, and then we will look at what is the configuration all about. So we have the profile here, the provider, I'm sorry. And then we have the EC2 instance, and the depends on is commented. And then we have the S3 bucket resource available. So let me do a clear now. Let me just remove this one completely so you are comfortable with the configuration, and let's save. And let's see what will happen if we do a Terraform apply now. So I'm going to do a Terraform apply with auto approve. So it's creating the bucket and creating the instance. The bucket will finish quickly, and then the instance will go ahead. So as you can see, it started creating both of them. And even before the bucket was created, the instance was started. So this is what happens without the statement that we put in place. So let's put here the depends on again. Depends on. And that will equal to the name of the bucket. Let's write that down. AWS S3 buckets. I'm going to take all of this. I'm going to paste it here. Then let's do this dot example. And then that's it. Right, so we have that done. Let's do a Control S. So we have the resources created. Everything is cool. Let's do a Terraform destroy. Notice that the two were started simultaneously at the same time. So we'll do a destroy. And once it is destroyed, and we need to do a save for the change we have done for the depends on. And I'm going to say yes, go ahead. So after this is destroyed, we're going to do a create again and find out, is it going to complete the bucket and then start the instance, or it will start both of them simultaneously as happened in the previous try? We still could have used a depends on inside, let's say, a VPC or something, or a subnet resource, just to speed it up. But let's see what happens now. All right, so now it is destroyed. I'm going to do a Terraform apply again with auto approve. It should create the S3 bucket completely before starting the instance. So let's see if this is what will happen now. So it's creating the bucket, did not start the EC2 instance. The bucket was completed, and then it started creating the instance. So see the difference? Before, it started both of them. So let's just go back up. Here it started creating both of them at the same time simultaneously and did not wait for the bucket to complete before it started the creation. While here, it started the bucket, it completed the bucket, and then it's starting the instance. And that tells you that the dependency, the explicit dependency, works as well. And now I don't need it anymore. So Terraform destroy with auto approve. And I think the point is clear now about the dependencies. Now, please, when you add a dependency, add a comment. So you can, for example, here, you can add a comment that states the instance needs to download or maybe upload startup logs to the bucket, for example. So now anyone who uses that will understand what was this for and why it was put in place. Now we need to bring that back to the initial state. Then what we need to do, delete. And same thing here, so you can enjoy doing the labs again and again if you'd like. But please do the deletion after you have destroyed the infrastructure, not before. All right, so let's look at Terraform output block, a new block that we are going to introduce. And the main reason for that is, let's say you are creating a load balancer or an S3 bucket. And after it is created, I want to have Terraform display the ARN, the Amazon resource name, or the ID of the bucket, or the ID of the instance, or the public IP of the instance. Of course, I can go and look at the TF state file and I can search and find it out, but that's cumbersome. If I know that this is what I want, that's fine. I'm going to add it in the configuration and output block. And once that resource is created or that attribute is available, it's going to output that on the screen. And also it's going to be in the output section of the TF state file. So the output block is used to display one or more attributes of the deployed resources in that configuration module or file, in the Terraform module. The way we write it is, let's say I have here an EC2 instance, and I would like to display the ID of the instance after it is created. Then I have to add an output block, and I have a name for the output block. It's up to me. I can name it whatever I like. And then we type value equals, and this is constant. This is always in the output blocks, value equals. and then the name of the attribute, or how I can cross-reference the attribute. And we said about that, the type of the resource, the local name, and then the ID. There are optional arguments that I also can add in the output block. So I have the value equals, and then I can add optional blocks. Like what? I can add a description, which would say, what is this, or why I am outputting that one. Then if the output includes sensitive information, I don't want it to be displayed on the screen. Maybe I have some people looking over my shoulder in the office, and I don't want to show the database password, for example, that is going to show. And also we can add the depends on argument in the output block. Remember the depends on, so don't show me this attribute until something has happened. That's exactly like the one we used in the resources. So the description will help me briefly describe the purpose of each value. So we have value, AWS instance, server.private IP, and this is going to say, what is this? What is this that we are outputting and why we are outputting this? For the sensitive, then if I'm, for example, typing a database instance password, then I can add a description, and I can add the fact that it is true, it is sensitive, which means when it is displayed on the screen, it will not show the password. It will just put the greater sign and smaller than sign, and then sensitive, the word sensitive. If I need to find the information, I have to go and see it in the TF state file. I know you might ask, all right, so you did not show it on the screen, but you kept it in a TF state file. And if anyone has access to the TF state file, then they will be able to see the password. So what did you actually do? I would say this is better than showing it on the screen, but it's not the ideal case. There are ways in Terraform, but not the scope of this video, where we can have better protection for the TF state file and not allow anyone to access it unless they have the permission to do that. All right? All right, so let's say that I have already done the execution, the apply command, the output appeared on the screen, and then we did a lot of things on the command line, and now I need to find out a public IP address for one of the instances. What do I do? Do I have to keep looking in the history of the CLI to find out where that is? Or do I have to jump into the TF state file to find it? Or is there another way? We can use the Terraform output command. So if I use this command without any options, it's going to list all the outputs in the current configuration module or the root module or the list of configuration files we have already executed. And if I want a specific attribute, then I can name the attribute here, and only that attribute is going to show to me. It will show on the screen, and if it was sensitive, it will show as sensitive as well. All right? So the sensitive option, as we mentioned in the output block, this is how we use it. So I have here the value, load balancer address, for example, AWS ALB, application load balancer dot local name dot public DNS. That is not critical. I can show it on the screen. I don't care. But then there is also a password I'm going to display on the output, or include in the output in the TF state file, but I don't want it to show on the screen. And in that case, I'm going to output random password. This is the type, and then password, that's the local name, and then result is the random password. One might ask, okay, so what's the random password? Don't worry about it. This is a resource type that is supported in Terraform. We're going to see that in the lab. This is not an AWS thing. Now, based on this configuration snippet, if I do a Terraform output, it's going to show the load balancer DNS name, and it's going to show the password, but it's not the value, only sensitive because of this line here. What if I only need the password, or I only need the load balancer DNS name? Then I can use the command Terraform output, and then I can say the name of the load balancer, the LB address. I can do this. So now I'm using these names and not the local names and all that. I'm using these names, the output block names. That's what I'm using here. And if I wanted the load balancer, then this is going to be what I would be looking at, the LB address. This is how you address the value here. All right. Last but not least, the depends on, which I can include also in the output block. Remember this we have done in the resource block before. So here what I have is, I have an output block that is supposed to show the public IP address of an AWS instance, the local name of which is server. This is only a snippet of the configuration. The rest of the configuration is not shown here. And there is a description. Okay, and what is the depends on all about? Here it's saying, please don't show this until there is a resource, AWS security group rule, and it's called HTTPS rule. Also, it should be available in the overall configuration, not shown here. So when this rule is created, only then show me the output, the public IP. And what would say, what does the public IP address has to do with the rule? It could be that we had the instance, all right? And then we have the security group around the instance. And this specific rule could be for the inbound. It will allow, let's say, port 80 or port 443. And I don't want anyone to get the IP address. Go ahead and try to use it from a laptop to SSH or maybe connect to the instance, and then it will fail. I want to make sure that it will only be displayed when the right security rule that will allow the proper ports is already created, and then I don't mind showing that on the screen. Right, so let's go ahead and do some hands-on on Terraform output so we can understand it, and also we can understand the meta arguments, the description, sensitive, and depends on. So let's go ahead and start. All right, so I have 3 hands-on labs for you that we are going to look at here. Let's look at the plain one first. So output.examples, and I have the output, the AWS. So we have a folder that has 2 files. These are different folders, so they will not be considered as configuration. And I have 2 .tf files, AWS provider and output examples. And as we mentioned earlier, then this one is going to be a valid configuration file that will be processed, and this will be our main one that we'll look at. So what does this one do? This one creates an S3 bucket. We don't have the provider here because it's available in the other file. So as if we had it here on top. Then we are going to create a VPC. Nothing magic, we have done that before, so I'm not going to go into documentation. You know how to do it, you have done it, and you should be the master on this now. What do I need to do? I need to output the ARN, the Amazon resource name of the bucket when it is created. So I'm going to add an output block, and I have the freedom to call it whatever I like. And then I'll put the value, and here the AWS S3 bucket, that's the resource type. My S3, which aligns with this one, and then .arn. So that's the attribute I'm trying to output here. Then we have output VPC ID, and we are going to output the ID of the VPC, lab VPC ID, which aligns with the one that we have right here. All right, so very simple one, nothing fancy. And let's go ahead and go into the terminal. Let me pull this one down so we can have the ability to see both. And I'm going to go ahead and initialize the directory. I think you are used to this now, and you know exactly what we are doing. All right, so clear. Of course, we need to do Terraform plan. In order to do the planning, I'm talking about the best practice, the way we should use it. In the hands-on labs, you'll see that sometimes, or most of the time, I may skip it. But here we have, as you can see, 2 resources to add. And if we expand this one, you'll find the 2 resources are the S3 bucket with the details, and then we have the VPC with the details. But there is something new here, that there will be outputs that will be displayed, the VPC ID and the S3 ARN. Please notice that what is displayed is not the references here, but it's the name here. So VPC ID and S3 ARN. S3 ARN is completely different than what we have here. But you can see that the output is going to output this and the S3 ARN, which is this, the name of the block, the local name of the block, not how you reference the attribute. All right, so that's fair. Let's go ahead, clear, and then I'm going to do Terraform apply with auto approve, so it will not ask me if it can proceed or not. You'll see that the TF state file is now created, but it will be an empty file because we don't have anything created yet. Now it's creating the VPC, creating the bucket, and both are okay. And here are the IDs, we have them here. So look at this. It has sent to the output on the screen the VPC ID, which ends with 4146, and the S3 ARN, which ends with 8910. If we look at the TF state file, you'll find the same values available. So for example, this one here is exactly what is in the output here, VPC ID, and that's the value, and it is a string. Then I'm still in the outputs block here or section. We have the S3 ARN, and then it's the same ARN that we have here, right? And then after we finish the output section, then we get into the resources, and then it will tell me about the AWS S3 bucket. And if we scroll down, then we're going to get into the VPC and the name of the VPC and so on, right? So now this is how the output works. And please remember that you will always have the same outputs available here in the TF state file. All right. So that is it for this simple, straightforward lab. And we're going to look at the other ones. But before I forget, let's do the Terraform destroy. Of course, I'm not validating on AWS because we know they exist. I mean, I don't have any worry or any concern that they will not be existing. But anyways, if you want, just to make you feel comfortable, then I would like to find out if you have the S3 bucket that ends with 78910. And if you have a VPC, the ID of which ends with 4146. So we can go into the console. And here we have the VPCs. I'm going to click on this and you will see, let me refresh, that we have one that ends with 4146. And if we go into S3, we have a bucket that ends with 78910. Okay, so because I trust Terraform, that's why I'm not checking with every lab, but please feel free to do that if you want to do so. All right, so I'm going to destroy with auto approve again, so it will not bother me with a yes input in order to continue. All right. So now it's destroying, everything is okay, it is destroyed, and the Terraform state file will return to empty, and we should be good to go. Now let's go ahead and look at the second lab. So let me just collapse this one and look at this one, the output sensitive one. So we have a configuration here, and I'm sure that when you looked at the slides, you were concerned about what is this random password and what is all of this and why we don't have an AWS provider here, we don't have an AWS provider here, and this is still going to work. Let's go ahead to the documentation and find out the random password that is supported with Terraform. Let's go here, and then on Google, I can just write AWS random password Terraform. Random password in resources in HashiCorp. And here the documentation, it's not the AWS documentation as you can see. And this is identical to random string with the exception that the result is treated as sensitive and thus not displayed in the console output. Read more about sensitive data in the Terraform documentation. Okay. So here we have the resource that is called the random password. We can define the length. We can define the special characters, if any. And we can be using this for example, here for database, I can use the result coming from here into the password. So the attribute for this is going to be the result. And if we look at this, the length is a number. And we have a lot of optional things that we can add. And at the end, we can get the result, we can get the ID, and we can get the bcrypt hash as well. Okay, so the generated random string, we're going to get it by reading this. I mean, call it attribute, call it whatever you like, but this is where the dot result is. So this is where this is coming from, the dot result right here, when you want to output that value. All right, so let's go back to our configuration. So this is called the random provider. Random provider allows the use of randomness with Terraform configuration. This is a logical provider, which means that it works entirely within Terraform's logic and does not interact with any other services. So this does not require AWS or Azure or Google or HashiCorp or Alibaba or anything. It is a randomized provider that is within the logic of Terraform. And we have multiple resources we can deal with. We have random ID, random integer, random password, random pet, random string, random UID. So I'm going to look at the random password. So the random password as a resource within the random provider that doesn't need to be identified as a provider. It generates random passwords, and here it's the same thing. The name of the type of the resource, that is random password as it is written here. And this is the local name. It's up to you to call it whatever you like. And whatever is generated here, we can reference it by the ID or the result. Where did I get that from? If you scroll down, you'll find what are the read-only things that you can get. And you'll find here the result, which is the generated random string, and the ID, a static value used internally by Terraform, and this should not be referenced in configurations. That's fine, fair. And we had an example as you have seen about it, okay? So if we grab this one from here and tailor it, or just use the one that we have. All right, so I think now we understand, and the length is a required attribute. So if we look here, you'll find that the length is required and the rest are optional. So I can just put the length and I should be good to go. All right, so we have here that this is the resource. And if we look at what is the special true, let's go back to the documentation again. What is that special thing? Special means include special characters in the result. Special characters like this. Default is true. So that's the default. If I did not mention it, I should be fine. So that's what we have here, the random, and I'm not going to call this password, just let's call it anything else, PWD. I want to differentiate between this and this. Okay, so the length is 16 and special characters are allowed. All right, and let's call this also, I want to make it different, passwd. Okay, so I have the name here is different than the name here. That's what I'm trying to highlight here. So the value equals random password dot password dot result. This is the attribute or the read-only value I can read from here. So this should match, so that you know, this should match the PWD at the top. All right, but if I want to call this output, I have to call it by the passwd. We'll look at this now, okay? And I'm not going to use the sensitive now. It is commented, which means as if it does not exist. All right, so let's save. And I'm going to go ahead now and move into this directory. I'm going to initialize because it's a new directory. See, it did not download anything because it is not any. So this is installing HashiCorp, this one, and installing HashiCorp random. امسح من أول بتاع. امسح من أول مكان هنا. All right, and if you look here, there is no AWS or anything. It just gets the latest version of the HashiCorp random process or function that runs within the Terraform logic. It does not interact with any external entities or providers. All right, fair enough. So what do I need to do now? Let's run it and see what happens. So without the sensitive keyword, Terraform apply and -O to approve. There is something that it doesn't like. Yeah, it is objecting that this has to be set as true. Why? Because this is a random, because this is a password and it is known it is a password. So it will not accept it without the sensitive keyword. Okay, fine. I'm going to do this. And let's remove this and Control S, and I'll try to do it again. So now it did not object anything, but it told me that the password you would like to output is sensitive. So here, even when it generated it, it did not type anything about it because it is a sensitive thing. But if I go into Terraform and I look at the output, you'll find that the password in the output, here is the value that was generated. So you don't show it on the screen, but it is in the TF state file. All right, so this is how the sensitive thing works. All right, so let's go ahead and destroy this. We can do this in a different way as well. I'm going to show you. Let's do the random string. So the random string, I'm going to take this. This one is not as protected or as secure from the Terraform random. So hopefully it will not give us an error if we use it. So let's go back to our code. So what I will do now is I will go back to the file. I'm going to hash this as if it does not exist. I'm going to enter the new one here. And this is called random. Let me also copy this one to the top. And I'm going to hash this again. So I'm not going to use the old configuration at all. I'm going to massage a new configuration that should allow me to use the sensitive or not up to me, not up to Terraform. So here I'm going to call this random. I'm going to call this sensitive test. And this is going to type the value in the random resource. Okay, so the value here has to be, and it's not a string, it's not password, it is a string. So I have matched what I'm going to output with this exactly. And I don't need to worry about this, especially is fine. So random string dot random string dot random dot result, and the sensitive equals true. I'm going to highlight this one now. I don't want to use it now. Let's save, and let's go ahead and do a Terraform plan. So now it doesn't give me any objection so far. Let me clear, and let me do a Terraform apply now. See, it showed me the value because in the process, in the random string, it will not force me to make it sensitive. Now, what happens if I run the exact same thing again? But let me first destroy this. And I'm going to run the exact same thing, but this time it's going to run with the sensitive equals true. I'm going to save to make sure it is applied. And see, so now it did not show me the value, which shows you the difference between if you use the sensitive or if you have not used the sensitive. So here it showed me the value without any issues. Here it told me it is sensitive, but it is in the TF state. So if I go to the TF state, I'm going to find the value available, and that should explain the concept of sensitive. All right, so we are done with this one. Let's destroy it, and let's look at the next one. So let's do kind of a lengthy lab. We're going to create a security group. We haven't seen how we can create a security group resource before, but it's a very easy thing, just following the same approach we have done before. We are still with the Terraform output block, and we are going to use a depends on meta argument as well, just to show you how we can use this, but we're going to build it from scratch. So I have the answer, but I'm going to build that from absolute scratch. So you are going to work with me on creating that. It includes VPC, subnet, security group, rules, inbound and outbound, and an EC2 instance. So kind of a mini lab, but it gets you closer to being able to build architectures on AWS. So it's not the depends on for the lab, it's the AWS Terraform kind of expertise that we need to build in our course. So we're going to create a VPC. The VPC is called main, and the VPC will be in US East 1 in North Virginia, and the CIDR block is 10.0.0.0/16. Inside the availability zone A in that region, we're going to create a public subnet. This is going to be the public subnet range. We are going to create an inbound rule that allows HTTPS 443. We're going to create an outbound rule that allows all traffic. Inside the subnet, we're going to create an EC2 instance, AWS Linux EC2 instance, and we're going to assign the security group to the instance. So this is what we are going to do right now. All right, let's go ahead and find out how we can create this. So here is the task list that we need to do. First thing, we need to create a VPC in US East 1 with the local name main. The CIDR block is 10.0.0.0/16. Where do we get this from? Before we get into that, where is the providers block? We have a blank file here. So the provider block is right here, and we have done it so many times, so there's no point on typing that from scratch again. VPC, we have done it before? Yes, we have done it before. Let's go ahead and get the VPC configuration. So here we go. Let's go into virtual private cloud. And as I mentioned before, you can go in the Google search engine, just type AWS VPC Terraform, and you will get it. So scrolling down, we have done this before, so we don't need to stop for long. And luckily, it's exactly the same with the same name and everything. I can, of course, change the CIDR block. I can change the name if I need to. So going back, let me minimize this. We don't need that for now. So I'm going to paste this here. You can add tags if you want. It hasn't been requested, so I'm not going to do it. Now, let's do a security group. Create a security group with the local name allow TLS. It can be application 1, web, app tier. It can be anything. The security group allows HTTPS inbound from the VPC CIDR block, so from this range. And all traffic outbound, the security group must be in the above VPC. So we have to tie the security group to the VPC, and it needs to allow HTTPS inbound and all traffic outbound. So this is what we need to do right now. Let's go ahead to the documentation and find that out. So under the virtual private cloud, if you scroll down a little bit, you'll find we have the security groups. It's right here. Okay. So AWS security group. Resource is AWS_security_group. You find here some notes about an old way of configuring the security group. If you would like to, if you come across a different way of writing the security group, please read about this, because you are discouraged to use the old way. We're going to teach you the new way. All right. And here's an example. Resource AWS_security_group. Luckily, same name that we are trying to create. Then we have an argument name, and this is the name. If you don't specify it, Terraform is going to generate a random name for your security group and submit it with a request. This is a description. What does the security group do? And then tying the security group to a VPC. And luckily, also, this is the name of our VPC. If it was a different name, I'll just copy this and change the name and should be good to go. So this is the security group itself. So where are the rules? The rules in the AWS security groups, in the new way of creating that, they are completely separate resources. So I have a resource, AWS VPC security group ingress rule, that's one type. And then we have AWS VPC security group egress rule, and that's another type. How do we configure it? How can I tie the rule to the security group? We have this here that is going to tie the security group rule to a security group ID. So now this ties into the above one. And what's the CIDR block that we should allow? Here it is referencing AWS VPC main CIDR block. So believe it or not, this is exactly what we need. Then from port 443 to port 443, and the protocol is TCP. Okay. This is how we can do the same for IPv6, but it's irrelevant here. Then we need an egress rule that will allow all traffic in this case, and the CIDR block is 00000. That means all destinations. An IP protocol, and then double quotes -1 means all protocols, all ports. And we are tying it to the same security group right here. All right, that sounds good. Sounds very close to what we need to do. And if you want to read more about the rules, the security group rules, it's right here. AWS VPC security group egress rule, AWS VPC security group ingress rule. But this is a perfect match, so I'm going to take it. I'll go back to VS Code. In your case, if you wanted to give it different names, you can train yourself on that. I don't need the IPv6 in my case. And also I don't need this IPv6. We have the VPC, the correct name, the CIDR block here, and we have the security group, the same name as well. So I don't need to change anything. It's a perfect match to what I need to do. Then step number 3, create a subnet with the local name public subnet in the above VPC. So it has to be tied to the VPC in the availability zone US East 1A and the subnet CIDR block. Let me go ahead and create this. We have done it before. Let's do it again. So it is also in the VPC, the subnet. So it's right here. And I'm going to take this example. I'll go back and let me paste it under the VPC. It makes more sense. Terraform is going to look at all of them. So we have here AWS subnet, but the name that we have been suggested is not main. So let's go ahead and look at that again. So public subnet, that's the name I need. So I need to change it. And the CIDR block is 10.0.10/24, which is the same one. And it has to be in availability zone US East 1A. So the subnet right here. So the name, I need to change it. Public subnet. Okay. And we need to tie it to availability zone. And as you can see, it shows me here exactly what I need to do. So the availability zone, and it is US East 1A. Very easy to do. And you can see the IDE help is really important. All right, so what else do we need to do? Subnet to the local name. Let me just check 10.0.1.0. Hopefully that was the right one. Yes, it's the right one. So we're good to go. Tags, they are always recommended. You can leave them, you can remove them. It has not been required, but as a good practice, always add tags because they are helpful to locate that. If you would like to look at the console, they are helpful for cost considerations. They're helpful for a lot of things. Now we need to create an Amazon Linux EC2 instance in the public subnet above. The instance size is T2 micro. Choose a suitable AMI, but they have requested it to be AWS Linux. Let's also add one thing. Apply the above security group to the instance. Also, let me add and ensure that the instance gets a public IP. So we are going to be comprehensive in what we do here. The next step, it will ask to display the public IP, and that's why I added these two. And since we created a security group, why don't we see how we can attach it to an instance? That's what I'm trying to do now. Fair enough. Let's go ahead and get the AMI and the instance configuration. So to get that, the instance configuration, I'm going to go under Compute Cloud, Elastic Compute Cloud. I'm going to scroll down to the instance configuration, and I'm going to copy the one that we have used before. I mean, this one is very nice. Let me go back and paste it. I'm going to paste it here. AWS Instance Web. They didn't say anything about the name, so I'm going to keep that. And we need an AMI that is AWS Linux. Where do I get that from? Go back, get here, and go to EC2. I'm going to pretend I'm launching an instance, And in that page, I'm going to scroll down. Here is the Amazon Linux. And I'm going to take this AMI, go back to the configuration, and I'm going to paste it here. They said that the instance is going to be T2 micro. So that's cool. Now I'm missing three things actually. First one is it should be in the public subnet. So there has to be a reference to the ID or the subnet ID attribute inside the instance. So let's do this one first. So here I'm going to type subnet ID, and as you can see, the help is very helpful. And we're going to do AWS underscore subnet dot, and then we have the public subnet. So see, it has read it from my configuration, and then .id, and we're good to go for this one. All right. What else? I need to associate a public IP, and you can see here it's available, and this should be true. If I didn't know it exists here, I would go to the instance again. I would go here and I will look at the arguments, and here you'll find associate public IP address. This is optional, but it is, if it is true, that means definitely it will get a public IP address. All right, what are we missing? So now we need to do the security group. We have two ways to do this with EC2 instances. If I'm using the default VPC and non-VPC instances, I can use security groups. If I'm using a VPC, I have to do the second one, VPC security groups. And here I have to provide a list of the IDs of the security groups I'm going to use. So ID, and then I'm going to go back here and massage this one as well, and I should be good to go. All right. So let's go to the documentation and confirm where did I get that from. So under AWS instance, we have security groups. And this is under arguments, just for you to know where we are. So this is only in case of EC2 Classic and default VPC. This is list of security group names to associate with. And then if you scroll down till the end, we'll have the VPC security group IDs. And this is a list of security group IDs to associate with. All right. So are we done? Let's find out. Let me save this. So we have our work saved. We need to display the public IP of the instance. However, this should not be displayed as an output until the security group ingress rule has been created to avoid issues on port 443. We need to validate the configuration, check everything, and then destroy the configuration. All right. So what do we need to display the public IP? I need an output block. Very easy. And I'm going to call it EC2 public. All right. And then we open the braces and we type the value equals, and then the name of the resource, AWS instance web, and we need dot, and then we'll go with the public IP. So if you scroll down, public IP right here. Okay, but this will depends on, and the fact that we have the ingress rule created. So we need to add it here. Right here. AWS VPC security group ingress rule allow TLS. And here if we type AWS underscore security, you will find here the ingress rule that we have, allow TLS IPv4. We can remove the IPv4 reference and we remove it from the top as well, because we don't have IPv4 and IPv6 in our case. So this one and this one, I can just remove this. So now this name has to be exactly like the one we have referenced here, and it should be okay now. So what do I need to do? Now I need to initialize the folder. I think we are done now. Let's do integrated terminal, make sure that we are in the right place, and then do a Terraform init. We're initializing the folder, and you will see here now the Terraform directory and the plugin has been downloaded. Clear. Let's do a Terraform validate to check that our syntax is correct. We don't have a quote here, a brace or something that is missing. in the output block, I can add the description as well here and state what is this exactly and why do we have a depends on. It's always recommended to do that, although I have not done it in this example. So let's go ahead and apply, and auto approve, please. I mean, I have kept you for long. We don't need to wait for another yes, although it is recommended in production. So you can look at what will happen and then decide on whether you want to go ahead or not. So now it is creating the VPC, the subnet, VPC security group, and the ingress rule, the egress rule, and the one that will take a little bit of time will be the EC2 instance. As you can see here, the ingress rule creation has completed, and that's why it can provide me the public IP as soon as the configuration is done. We have a TF state file, but right now it's going to be populated. See, we don't have outputs yet. It's not implemented. We have the resources, AWS instance. It's getting created right now. All right, and here is the public IP address. So it ends with 11.195. Let's go ahead and check that here and see if we have an instance with that IP address. We have a running instance and it has the same IP address. If I go under VPC, I should find a non-default VPC. If we had a tag name, we would have found the name here. But anyways, this is 427. And if I go back, the VPC is, I can look it up here in the TF state. So let's find out which one. So this is AWS instance. And if we scroll down, we have here the security group and the subnet. Here is the VPC. Let's look at the ID is 3427, which is what we have here, 3427. All right, do we have the subnet, public underscore subnet? We do have. All right, so I think we left the tag as is, and that's why it is showing as main here. Let me double check. Let's look at the subnet tag. Yes, here it's main. So let's change that, and I'm going to apply it again. I want you to be comfortable that what we are doing is correct. And I'm going to do a Control S, and I will do an apply again. Nothing will change except for the public subnet. It will be updated in place. So it's refreshing state for the VPC. It will refresh everything, and then it will tell me that it needs C. It's going to change the tag from main to public, basically, and it didn't take any time. So this is what it will change. Now, if you go back and check, let's refresh this. You'll find that we have public subnet right here. So that's the correct one. All right. Do we have a security group? And we should be good to go after this. So if you scroll down, security groups, do we have one called allow TLS? Yes, we do. And it allows inbound HTTPS from the VPC CIDR block, and outbound allows all traffic to everywhere. All right. So that's exactly what we needed to happen. Let me go ahead and do a Terraform destroy, and we should be good to go. Please don't forget to do that, because otherwise you may leave resources that will start to accumulate cost, and you will be surprised with an unexpected bill. All right, so now it's refreshing state. It will start destroying them one by one. I did the auto approve. I know we have talked about the Terraform state, but let's give it its own video because it's worth it. As we mentioned, after Terraform will deploy the configuration files in the respective module or in the current module, Terraform is going to store the state of that infrastructure in the TF state file. And we also understand that the Terraform configuration files, the TF files or the HCL, the HashiCorp configuration language files that we create, is the desired state. That's what I want to happen. These are the resources I want to be created. These are the tags I want configured. This is the MI I want in the instance. So that's all the desired state. Whereas what we have in the TF state file is the current state. So there is a current state and there is a desired state. What does Terraform do? Terraform will always read the current state. When you want to do a plan or apply, as we have seen, it refreshes its information about the state. And then it compares that to the desired state, which is the configuration files, comes up with the delta, and that will be the Terraform plan output. So this is what I'm going to do. This will be created, this will be updated in place, this will be deleted. Terraform will always struggle or thrive to make sure that the infrastructure is in the desired state. That's the purpose of Terraform. And that's why using the local state or the Terraform state to create plans, when you do a Terraform plan, it has its own knowledge about the infrastructure, then it refreshes, so it has an updated knowledge of the infrastructure, compares the two, finds the delta, then compares that to the desired state, and then comes up with the plan at the end that will be deployed with the infrastructure. Before we do any plan or apply, as we have seen, Terraform does a refresh from the actual infrastructure to find out what's the latest. Somebody changed the tag, somebody deleted an instance, somebody changed a rule in a security group. So it needs to get the most updated state of that. The state is stored in what we call the terraform.tf state file or the tf state file. And the state can also be stored remotely. So usually, or the default, what we have seen so far is it is saved in my laptop when I'm working, in your laptop when you're working, locally as the terraform.tf state. Is there a possibility that I can store this state remotely? That's possible, but not the scope of this lecture. You can do a Terraform show. So the Terraform show will display the human readable output, easier to read output from the state or the plan file. So this is not going to read from the infrastructure. This is very important to note. And then we have the Terraform show -JSON, which will display the same thing, but in a JSON format. So these two are about inspecting the TF state information, not reading information from the infrastructure. What if I would like to refresh the knowledge that Terraform has about the deployed infrastructure? So let's say we applied everything 2 days ago, 2 weeks ago, and we have the TF state file. The TF state file is not a continuous synchronization about the state. It is when you do an apply, then it will read the state of the deployed infrastructure and save it in the TF state file. So if you did not make any changes, if you did not do any applies or any destroys for the past 2 years, the knowledge in the .tf state file is going to be about the 2 years deployment that happened. So what if I need to refresh that information based on the deployed and not based on the TF state? The Terraform show is about the TF state file. The Terraform plan or Terraform apply -refresh -only, this is going to update the Terraform knowledge of the current deployed infrastructure state with any changes that has happened from the last time we got the TF state information. And the Terraform -refresh -only with the plan or apply does not modify the implemented infrastructure. So even if you do Terraform apply refresh only, I mean, it's obvious. It's telling the infrastructure, do not change anything in the deployed infrastructure. The plan, the same thing. And here's a use case. Let's say that some resources have been changed manually outside of the Terraform management. So this command can reconcile the state file that we have to match with the current implemented infrastructure without updating the .tf state file. That's which one? The plan. But if you do a Terraform apply -refresh only, it will update the TF state file, but it will not execute anything on the infrastructure. All right. So Terraform plan -refresh only gives me and Terraform the knowledge about the current state, but it does not change the TF state file. Terraform apply -refresh only, it will update the TF state file, but will not change the infrastructure. And here's a zoom into the two commands. Terraform plan refresh only, reconcile the state file with the current state without any state file modification. Terraform apply refresh only, reconcile the state file with the current state and update So we have an update to the state file without infrastructure modification. So both of them will not change the infrastructure. The apply version will update the TF state file. The plan version, it's only about reconciliation, but it will not update anything. All right, so that's all for this video, and I'll see you in the next one. So let's do a quick hands-on lab where we are going to look at the Terraform state, and we'll also try the Terraform plan -refresh -only and the Terraform apply for the same option. So let's go ahead and find out what we are going to do. All right, so we have a very simple configuration which only creates an S3 bucket. That's it. And we have the providers as we have learned before, so there is no point in discussing that. All right, so these are the two files I have. And what I have here is just the S3 bucket, nothing else. So we have a resource, AWS_S3_bucket. That's the resource type. And then the name, the local name. And then we have bucket, the name of the bucket equals, and then a long name, hopefully that's unique enough to make it happen on AWS. Then we have these two tags. We have the name, my bucket, and the environment dev. So what do we need to do? First thing, I'm going to create the resource, and I would like to have a look at the TF state file. We have looked at it multiple times, but again, let's do that. So let's go ahead and initialize Terraform init. And then I will clear. Let me just grab this a little bit up and do a Terraform apply -auto approve. So as we learned before, we'll get the TF state file. Now it's still empty, but then it will be populated as the bucket is created. And as you can see here, we don't have any output blocks, so we don't have outputs. And for the resources, it's a managed resource, and that is AWS S3 bucket. The name, the local name is example. And then we have the ARN, we have the name of the bucket, the domain name, and so on and so forth. And at the end, we're going to have a look at the tags that we have provided. So I have environment dev, name, my bucket. All right. So what do I need to do now? We can use the command Terraform show. So let's look at the output of the Terraform show. Please remember, the Terraform show is about what is in the TF state file. So if you compare this view that you can see here to this view. So you do a Terraform show, and then it is much more organized. They are all indented equally, and then you have the information that you needed without the too much JSON stuff that we usually see. And we have the tags here. So the same information, but from the TF state file in a much human readable format. Compared to what? Compared to what we see here. If I take this down, compared to this. So instead of looking at this messy representation, I mean, not messy, but I mean from a human readability perspective, we get the better one, which is the one that we looked at. Okay, fine. So now we have done that. And now let's look at the behavior when we do changes manually. What happens? We'll demo the behavior when we manually change an attribute that is tied to an argument that is explicitly defined in the Terraform configuration file. So we will play with the tags. I will go ahead on the console, and I'm going to add a third tag. So I'm going to go ahead to S3, look at the buckets. And then we have this bucket right here. And what I will do is I will go into properties, and this is where the tags are hidden. I'm going to go in, add a tag, and I'm going to state test yes. It doesn't mean anything, but just a third tag, a change that has been done manually away from Terraform's management. And now let's do a clear, and I will do Terraform plan. So the plan is based on what? Is based on this configuration file representing the desired state and what it will know from the infrastructure based on doing the refresh. So here it has refreshed the information in the bucket, the actual deployed infrastructure, and then it found out that there is a change in place. This means update in place, as you can see here. And it's going to remove this label or this tag, and it's going to nullify that tag. Why? Because it does not exist in the desired state. And all Terraform is about is to make sure that your infrastructure is 100% compatible with the desired state, which is the configuration file. So right now, if we do a Terraform apply, before we continue, I would like to show you the TF state file. Let's look at the tags at the end. You'll find that the Terraform show did not change anything here. The Terraform show, because what it does is it reads that information. That's what Terraform show does. And also the Terraform plan is about an execution plan. If you do the apply, this is what will happen. So it did not update anything in the TF state file as well. So I'll do yes here. And nothing will change in the TF state file. So it did a modification. It did not do a destroy. It did not create anything. But here it said one change. And if we go here, go at the bucket, refresh. If we check the tags once more, we'll find that there are only 2 tags again. So the test yes has been removed. All right, fair enough. Now we need to try the Terraform plan - refresh only and the Terraform apply - refresh only and see what they do. All right, so let me go ahead and you know what? I am insisting to make a change manually. So let's say that location USA. So we made a change. All right. Now I have the TF state file and I would like to reconcile, find out the differences between the TF state file and the deployed infrastructure. So what do? I do Terraform plan - refresh only. So it is refreshing the state. And look at the TF state. I'm focusing on the tag side. Nothing has changed. And here it will tell me that the update in place, this has been added as it shows here and here as well. So they are saying this is not in the TF state file, but it does exist on the deployed infrastructure. This is what it's telling me here. And here it's saying Terraform will not take any actions to undo these. If you are expecting these changes that you can apply this plan to, record the update values in the Terraform state without changing any remote objects. How can we do that? We can do it with the Terraform apply. So this is if you are accepting this. So let's find the difference between Terraform plan and Terraform apply. So now we reconciled and we found out that there is an extra tag that's available on the resource. I agree to that tag because I remember I did it. Now I want to add it in the TF state file. What do? So you can do Terraform apply - refresh - only. And let's look at the tags here and what will happen to this. Yes. And as you can see, it has been added into the TF state file. So the Terraform apply - refresh - only is about to find the delta, reconcile what is in the infrastructure state, the deployed infrastructure, and then add that into the TF state or remove that from the TF state. That's what it does. Whereas the plan is only about showing me the differences, but not doing anything. So let's try it again. Let's go ahead in the tags again. Let's remove this and this. All right. So let's do that again. Let me clear, and then I will repeat the Terraform plan. It is refreshing again. And it's telling me that there are 2 that have been removed. The USA and the name have been removed. So the environment is the only one existing right now. If I'm okay with that, then again, I can do the Terraform apply refresh only. So it will update the tags and it will refresh my TF state, but it will not do anything on the deployed infrastructure. All right. So now it removed everything, despite the fact that my configuration file is calling for 2 tags. So now it's about reconciliation between the deployed and the TF state, not looking at my desired state. Now, if I do Terraform plan, that's completely different. It will look at my configuration file, compare that to the infrastructure. It will find out there is a tag that has been removed, which is the name, and it will add that. It will need to add that. So here, as you can see, it will add the my bucket in order to conform to the desired state. So now you know the commands that deal with the TF state, you know the commands that deal with the infrastructure, and compare it to the desired state, which is your configuration file. So I think now you are clear on this. All right, so let's talk about a new block that we can include in our Terraform modules or Terraform configurations. It's called the Terraform block or the Terraform settings block. So what is that for? Let's say that you are dealing with an older version of Terraform commands that you would like to use, or you are used to, let's say, version 1.1 of Terraform. And that's what you have on your laptop. So you'd like to restrict Terraform to only accept that version of Terraform. I'm talking about Terraform, not the provider, not the AWS plugin, not the Azure plugin, not the Google plugin, or any such a thing. Where do we define that version constraint? And that's inside the Terraform block, among other things that we can also configure there. So here is a Terraform block. Notice that it has to start with the word Terraform. There is no local name associated with it, which is special for this block. And then the curly braces. And one of the things we can define here is the required underscore version and equals. And this is going to be a string that defines which Terraform versions are required for your code. And this is definitely critical if you have a reason why you want to restrict to an older version or a newer version of Terraform. Inside the same block, we can also nest another block called required providers. So this is for Terraform. This is for the providers I'm going to work with. And I can have more than one nested block for different providers inside the required providers. So I can have what defines AWS constraints and what defines Azure constraints, what defines Google Cloud constraints, Alibaba Cloud, Oracle Cloud, Kubernetes, whatever providers you are going to use, and you need to define parameters for and the sources where to get them from and constraints for the versions. You can do it inside the required underscore providers block. So how does it go? It flows exactly as the required version. So they are all indented the same inside the block, the Terraform block. And then I can have the provider name. This can be AWS. This can be Azure. This can be Google. This can be a local name that you can choose as well. So I can call it my provider. I want to refer to AWS as my provider, my preferred provider, preferred cloud. So it's up to you. This is locally significant only within your configuration. Then I define the source. This is for AWS. So where I get that from? So this is from HashiCorp underscore AWS. That's the plugin that we'd like to use. How about the constraints for the version or versions of the AWS plugin that you would like to use? I can add it here, version equals, and then we'll look at these arguments and what they mean and how we configure them. And the required providers gets nested inside the Terraform block. And of course, this is important because of the script, the way you have configured the security group, the EC2, the network ACL, the elastic IP configuration. All that relies on which correct version of the AWS plugin we are going to use. And if you have tested everything to that version, it's better to put a constraint for that inside our configuration to avoid any surprises. Please note that the provider version and the Terraform version, they have different versions. They don't follow the same distribution and the same version numbering. So they're completely separate from one another. Now let's look at the arguments, some of the common arguments we can use when we are defining the Terraform version constraints or a provider version constraints. We can do greater or equal. So if I do greater or equal 2.7.0, what does that mean? That means 2.7.0, 2.7.1, 3.0, 4.0, 5.0, all of that are available ones and the numbers in between. Less than or equal, very clear, it's the opposite. So equal, if I reverse this and say less than or equal, that means 2.7.0 is included, but then anything lower than that. What if I need something in a specific release? So 3 point, I don't care what, but it has to be 3 point. I can do it with a tilde greater than, which means 3.0.0, 3.1, 3.2, 3.3, to 3.99, and that's it. I cannot go 4 and I cannot go below 3.0. What if I need to define a range? So I want it to be within the 4.0 and less than 4.6. So equals or greater than 4.0 or less than or equal 4.6. I can define it this way. So once I configured the required providers, do I still need the provider block? And the answer is absolutely yes. You cannot configure the required region here. Earlier on, we could have configured the version constraint here, but it's deprecated now. So now we have to do the version here. But I want to do the authentication. It has to go here. So configuring the required providers does not eliminate the need for the provider block for the respective provider. That's one thing. The other thing is, here it shows you that I have chosen a local name that is completely different for the AWS plugin than the word AWS. And I'm using this, instead of writing AWS here, I'm going to write the preferred name that I have used. And it will work. Either you do it this way or that way. As long as this is correct and it's referring to AWS and this is the constraints for AWS, you're good to go. All right. So let's do this in a quick hands-on lab. All right. So here I have a very simple configuration. I have a provider block. You are used to this, but you are not used to see something different than AWS here. Before we said we have to make it AWS, but we can change it actually. All right. So provider, my cloud. And then it refers to, or the actions are going to be in region US East 1. I can add the profile here as well. It's not required now because we are not going to do any resources, but I can do the dev admin, which I know is a profile that I use and it is available on my CLI, AWS CLI. But there is no reference to AWS here. Where do I refer to that? I go inside the Terraform block. I define the required version for Terraform, and then I nest the required providers block, and then I choose a local name, my cloud, which is exactly what I'm using here. But then I define a version constraint that it has to be 4.4.0. And from here, Terraform will understand that I'm pointing to the AWS plugin that is maintained by HashiCorp. And here's the source. So would it work? Let's find out. Terraform init. And it's not complaining so far, so everything looks good. And it's going to download not the latest version now. It's looking for a special one that matches the constraint, which is the 4.4.0. And it looks like it found it, installed, and now we are ready to go. So it does work as we explained, and there is nothing wrong with this, and there is nothing wrong with including the provider block, and there is nothing wrong with using a local name of my choice. But definitely, I cannot here point to AWS by my cloud because that does not exist. So if it does not exist, or maybe if it exists by chance, then you will end up getting the wrong provider because that's not AWS that you want. All right, so let's talk about Terraform data sources. What if I'm working in a region and based on the region setting in the provider block, I would like to find out what type of EC2 instances are available in this region. I do not want to do it on the console, and I do not want to do it manually. Or maybe I want to launch an EC2 instance and I'm not sure about which one is the Linux AMI 2023 or the Linux AMI version 2 or the Red Hat Enterprise Linux version 9. I don't know which one is the AMI. And I would like my script to be intelligent enough to find out that by itself. I don't have to do it manual, and I don't have to have static values. I want it to go fetch that information. Then I can use the information fetched in order to create an EC2 instance. This is called Terraform data sources, and they are available in the Terraform documentation in every single provider where applicable. So let's go ahead and find out the data sources and what are they? Terraform data sources allow data to be fetched or collected for use elsewhere in Terraform configuration. So instead of static writing that, then we can fetch it and use it. So for example, there is a data source called AWS region. And that would tell me what is the AWS region I'm working in right now. How would it find out? From the provider block, we have the region. It will find that out. One might say, okay, but yeah, what exactly did you do? I mean, it's already in the configuration file. Let me give you another example. So we do data AWS availability zones. That's a data source, AWS underscore availability underscore zones. And that will give me a list of the availability zones that are in the current region. One might say, okay, but I can go on AWS and find that out. I know. We're not creating new information. We are fetching information without having to go into the AWS documentation or the AWS website or into the console. That's what we are trying to do now. So in this example, the data sources, I want to output what is the region I'm working in right now. What's the region ID? So I can do an output block, call it whatever you like here. This is a local name. So in our previous examples, we used to put the value as the resource type and then the local name and then the attribute. If it is from a data source, we have to add the word data dot. So if you found any argument in any Terraform configuration that starts with data dot, you should know that this is a data source, or this is the data from a data source. All right. And also I can do the same thing. I can output in a different output block. I can call it whatever I like. Here it's available underscore zones. And then I can do value. Again, it's a data source. And then the type, AWS availability zones. And then the local name, available. And then dot names. This data source returns a list because it's a number of availability zones, right? And they are usually A, B, C. That's how they are identified in AWS. So this means, the asterisk means, please return all the availability zones. What if I put 0 here instead of asterisk? Then it's going to be availability zone A, the very first one. If I put 1, that will be B. If I put 2, that will be C, and so on. All right? So this is going to return a list, not a single value. And that is going to be all the availability zones that you have in this region. And this link here can show me the region data sources, and we're going to look at that in a second. So the data source is accessed via a special kind of resource, which is the data resource, which gets declared using a data block. So each one of these is called the data block. I didn't put any attributes, but it has the curly braces, it has the type, and it has the local name. So instead of the word resource, now we are typing data and then the type and the local name and the brace. All right, let's go ahead and check this link and find out how it looks like. What is this thing about data? All right, so here is the data source that is called AWS region. And if I scroll down, where is it exactly in the documentation? We'll find it under a group called metadata sources. And this is only about data sources. It does not have resources. AWS ARN, billing service account, default tags, IP ranges, partition, region and regions, AWS service and service principal. So if I look at the region, here it's saying providing details about a specific region. All right. So if I do this like it was in the example, what does it do? It shows you how the resource might be used to obtain the name of the AWS region configured on the provider. Where is the provider? The provider is what you have, provider AWS and then region and the name of the region. It will tell you what that is that you are working in. So what's the difference between this one and regions? If you use an S, so this is about AWS regions, not a single one. So if I have the same previous one with an S instead of AWS region with the same configuration, this is going to give me the enabled AWS regions for this account. Now, tell me all the AWS regions, regardless whether they are available for this region or not. Then you need to add the argument, all regions equals true, and that would do the trick. And here you can find the argument reference, all regions, or a filter if you want. And the attribute reference, I can get the ID of the current partition and names of the regions that meet the criteria. So names, not only a single name. All right, so let's look at the availability zones resource. And instead of going to the VPC, I'm going to do this, availability zones, AWS Terraform data source. AWS availability zones, data sources. And if we scroll down to find out where is this located exactly, we'll find it under Elastic Compute Cloud, EC2. We have resources that we have been playing with, and now we have data sources, and it is right here. So I have zone and I have zones. What's the difference? So let's look at the zone first. Provides details about a specific availability zone in the current region. These are the arguments. All availability zones equals true. Filter name, the name of the availability zone to select, and you can put filters and you can put state, whether it is available information or impaired. And also you can do the zone ID. So if you specify a single name for the zone, it will provide you which one. And if you have a zone ID, then also that is a specific zone that you are selecting. So this is if it's availability zone. What if it was availability zones? So we have the S, and here this is going to be data about the availability zones in your case. All right? And here's another example, all availability zones. And you are filtering based on the one that you are opted in. All right, so what are the arguments? All availability zones. I can do exclusive names, I can do the state, and what do I get out of it? Group names, ID, names, and zone IDs. Zone IDs is a list of availability zone IDs available in the account. Names, list of availability zones, names available to the account. So both of them will return a list. So the brackets and the asterisk in between now make sense. Why did we include them? All right. So let's move on. Now let's look at an example that will read the AMI in a specific availability zone or with a specific data that I need. Okay. So there is a data source called AWS AMI _, and then I can use the local name however I like. Do you want the most recent? If you set it equals true, if it has more than one result, it's going to return the most recent one. Who are the owners? And here I'm saying that the owner is Amazon. Or it can be self, which means one of my AMIs. It can be AWS Marketplace, if it's available in the Marketplace. Third party, it can be Microsoft. So there's a lot of things that we can put in here in order to identify where to look for that AMI. Then this is going to return a lot of AMIs, right? So we can apply some filter blocks and we can have multiples. So this one, for example, is going to talk about the name. And the values starts with Amazon 2-AMI-HVM and then an asterisk. So that means there could be more to the name. There is another filter that we can use. Name is root device type. The values can be EBS or they can be instance store. I can have another filter that talks about the virtualization type. It can be HVM, it can be paravirtual. So if you know more about what you need to add more filters, and that will definitely help you narrow down what you can or the results that you're going to get. All right, so let's have a look at the link here, which is for the data source for the AMI. And as you can see here, this is going to be under Amazon Elastic Compute Cloud, and it is right here. Remember, if you want to create resources, you have to look at the resources section. And then we have AWS data sources, which has the AMI, MIDs, and availability zones and all that. So if you go under the AMI, you'll find here AWS AMI, that's the type, and then example. And then we have most recent, yes, owners, self, and then we have filters here. If you look at the argument reference, what else can we configure? Owners, most recent, And then we have so many of them. You have filter blocks, one or more name value filter blocks that can be used. And of course, if you want to know what exactly you can use, you can refer to the AWS documentation. There is a lot that you can specify here. And what are the possible values? And if we look at the attributes, then you can have the ID, and also there is the ARN, and there is so many other things. And also you have the image ID, and it should be the same as the resource ID. All right. So whatever you like to use, please feel free to go through the documentation. It's always there. You can reference, and then when you have a specific use case, you can return here and check again. All right. Let's go back. And here's another example. I would like to find out about the instance type offerings. It could be in a region, it could be in a availability zone if you like. So this one, for example, it's talking about the AWS EC2 instance type offering. And then we have a local name. So that's a data source. How did I know? With the word data at the beginning. And then we can have filters. And here I have the name. The filter is instance type. And the values, I can have a list of the values that I am searching to find a match in this availability zone or in this region. Default, if you don't have location type, that will be the region. And then do you have any preference? Yes, I have a preferred instance types, and I have T3 micro and T2 micro. It will search for the preferred ones until it finds a match with the first one. That will be the returned one. And we have another source that's called offerings, not offering. Let's go ahead and look at both of them. So this is the data source for the EC2 instance type offering. And if you go down to find out where we are in the Elastic Compute Cloud, and we are under the data sources. We have instance type offering, and then instance type offerings. So this is going to return only one type. If there is more than one match, it's going to give you an error. That's why you need to add filters in order to narrow down, and you make sure that you get only one. So let's look at here. Here you have the name. This is the name of the filter as an argument. And then we have values for a list of one or more values for the filter. But the attributes, the instance type, it's going to be only one, or the instance type ID is going to be only one. So you have to be careful about this. Here, the preferred instance types, it's an ordered list of preferred EC2 instance type. The first match in the list will be returned. If no preferred matches are found and the original search returned more than one result, an error is returned. Okay, so you need to use the preferred instance type such that you get one match and it will not return an error. You can get the ID or the instance type out of it. So what's the difference between this and the offerings with an S? So the offerings with an S here, this is going to return multiple values. So again, you can have the location type, default is region, or you can specify an availability zone. You can have types that is going to search as filters, and here, and you can return the ID of the region, and you can return a list of EC2 instance types that have matched. So let's do a hands-on lab on Terraform data sources. So we have two files. One of them is the normal thing about the provider. One of them is the provider with US East 1 as the region. The second one is supposed to have data sources. So here's the first one. This is about the region. And of course, it will detect from the configuration file that this is about US East 1. And then we are going to output the region. Remember that this is a local name. It's up to you to choose it. And this is a local name. It's up to you to choose it. Has only significance within the configuration file. Then we're going to have an output block where we need to find out what was the ID of the region. So data.awsregion.current.id. All right. I need also to find, so this is a single region that I'm going to work or perform at. I would like to find out the enabled regions for my account. So I'm going to use the one with an S at the end, AWS regions, and I'm going to call it current_regions. And here also, I'm going to type it as regions. So now I'm going to have an output block that is going to have regions as well, so it will be different than the other one. It will not confuse Terraform. And value is dated AWS regions.current regions.names. Of course, here I could have called it anything else, enabled regions. So you're not going to confuse regions and regions again. Okay? And I'm going to type the names of the regions, or have that in the output block, the names of the regions that are enabled for my account. Then I'm going to have a data source, AWS availability zones, and then I'm going to, and here's the local name. And here's the local name. Then I'm going to have an output block for the availability zones, data.aws availability zones dot available dot names, and then we have the asterisk between brackets, which is all the availability zones basically. Then I want to find out the AMI, and I'm not going to specify a location, but I have filters for the AMI. So I'll have a data source for the AWS MI as a type, and I'm going to have a local name my AMI. I want the most recent in case if more than one are available. Then I want it to be by Amazon, so the owner is Amazon. Then I'm going to have a filter, and the filter is going to state that the name starts with Amazon 2 -AMI -HVM. This is for Amazon Linux 2. What if I wanted it to be with Amazon Linux 23 or 2023? Then the name starts with AL2023 AMI 2023. Where did I find this? In order to find out, we have to go to the console. All right, so let's head to EC2. And on the left navigation pane, we have images and AMIs. I'll click on that. And then here, I'm going to have public images. So these are the public images that are available. And if we scroll to the right, you'll find owner alias Amazon. And there are differences as well. So let's do owner alias equals, and let's type Amazon. So as you can see here, these are the ones by Amazon. And if we scroll to the right, we'll find here the column for the AMI name. And you'll see here, for example, this is Amazon 2 AMI. If we scroll down a little bit, let's not select this one. If we scroll down a little bit, we'll find also one Amazon 2 again, Amazon 2 again. And then we have here one that is Amazon Linux 2023, for example. And if we click on that one, you'll find some specification or some details about the AMI. For example, the AMI ID, the name, creation date. Remember when we said the most recent? So this is the creation date, July 19, 2024. So you'll find here information about this, and description is Amazon Linux, as you can see here as well. So from here, you can find information about which one you want, if you want to filter based on that. So if you are going to work in, let's say, Tokyo, and you would like to find the Amazon Linux 2023 AMI, so you can just use the first letter from the AMI 2023, and that's it. And then put an asterisk, and then it will give you what is available in that region. All right, I hope this is easy. And also it shows you here the EBS root type, the virtualization type. So a lot of information that you guys can use in the filters if you would like to build a filter like the one that we have seen. Let's go back to VS Code. All right, so at least now you have an idea about how we get the name. And then we have another filter for the root device type, and this is EBS. It can be instance store as well. And then a filter for the virtualization type we're going to match on HVM. I'm not going to go through the details. This is more AWS stuff, but at least now you know that we can narrow down the results by using filters. And then we are going to have two output blocks. One is going to show me the AMI ID that we have fetched, and the other one is going to show me the name of the AMI that we have fetched. Last but not least, we are going to use the fetched AMI as a value for the argument AMI in an instance that we're going to create. And of course, also there are ways we could have done the same for the instance type instead of statically configuring that here. But this one explains the concept of the data sources and how we can benefit from that. So let's go ahead and initialize the directory. Let me expand this. Terraform init. Layer. Let's do a Terraform validate, just to make sure that we didn't do any mistakes. Looks like it's good. Terraform LAN. And as you can see here, we have already fetched an AMI. We have also got the AMI name. And let me expand this. As you can see, a lot of things have been read. So availability zones that are available in US East 1, and they are 6, that's correct. The current region. And then these are the regions that are enabled for my account. As you can see, a long list, and it starts with a bracket, ends with a bracket. And then here's the AMI, and here's the name of the AMI. If you apply now, then the instance will be created using this AMI. So let me go ahead and do a Terraform apply -auto approve. But you can see now how important this could be. It's fetching all the details again. You can see how important this could be to create scripts that you don't have to configure setting information in. You only need to define the region, and then it will go fetch the AMIs. We can also configure the same concept in order to get all the EC2 instance types available, the virtualization filters and all that we have done. So you don't have to provide the AMI, you don't have to provide the instance types available. And then your script is going to find, based on the region you have configured in the providers block, will find all this information. And that makes your script portable. It can be reused in different regions. It doesn't have to be static only for one region. That's the beauty of using this. So now we have the instance created, and then we have the output values here. If I can go to the TF state, I will find there is so many outputs now, availability zones, available zones, and here are the values. Then we have current region. We have current regions for the enabled ones for my account. Then we have the fetched AMI, and then the fetched AMI name. All of that is available. And I have an AWS AMI data resource. Let me bring this one down. And then we have the availability zones as a data source. And also we have the AWS region as a data source. And we have AWS regions as a data source. And then we have the AWS instance, which is a managed resource in this case, not a data source. And as you can see, the AMI is exactly the same one that we have fetched right here. All right, so that explains the concept. Let's go ahead and destroy this because we finished the lab. So clear Terraform destroy -auto -approve. And we are good to go. All right. Hopefully that was beneficial. Don't forget to clean up your directory in case if you want to use the same configuration once again to repeat the lab, or to play and tweak here and there to learn better and exercise more. So let's start a new topic, and that is the Terraform variables. or how can we use variables with Terraform. So let's take a step back and explain what is a variable, and this is true for any programming language. A variable is a way to reference a place in memory, a location in memory where we can save values. It can be different values at different times, but you can think of it as a box, and we are going to reference it by the word box. So that is going to be our variable. What is inside the box? We can put apples at one time, we can put oranges at another time, we can put coins, we can put cheese. So every time we can have only one thing inside that box. So this is a location in memory that we can reference it by name, and that will be the variable name. And inside the location or inside the box, there is a value, which is the variable value. This is in layman terms what a variable is. So the variable name is used in our code to reference the location, to reference the box, and the static value that is inserted within that location or the item that is in that box. To understand how variables work, let's assume that I have, let's say, a Terraform configuration that has a security group. And the security group is going to allow an IP address 192.168.118.10, let's say 3 times, 4 times, different rules for the same IP address defining different ports, inbound or outbound. So in that case, I am forced to go in each rule and configure the IP address statically. What if this IP address changes? Let's say this IP address was the home internet IP address of an administrator that used to work with us, but now this guy has moved to another location with a different IP address. So now we have to go in a rule by rule and do the change of the new or the update of the new IP address, right? What if this was in 10 rules, 20 rules? Then it becomes cumbersome and it's a waste of time to go statically in each line in the code or each segment in the code where the IP address is used, and then start updating that. Takes time. It's not that flexible to update. So what would be the alternative to doing this? And very simple. We can just refer to this by IP add. It could be admin IP. It could be any name. And then we create a box or a variable with that name. And instead of using the static value all the way in every segment of the code, why don't I just reference here the variable or the box name, and then in the box name I can put in the static value, and every time I need to change the 20 or 40 or 60 code segments that are using the static value, I just update the box itself, the variable itself, and then the rest is going to change automatically. So that's the beauty of using variables in your code. And of course, it increases the reusability and the portability of your code as well. So let's look at a Terraform configuration without using variables. So let's say I have a security group, and the security group needs to allow port 443 and port 80 on the inbound direction ingress rules for this security group variable demo. And I want to allow the CIDR block all the time to be the 118.10.10.118.32. Let's say I have 5 or 6 more rules, and they are all allowing 443, 80, SSH port 22, and maybe port 3306, and so on. So I have a lot of entries for different ports, but they are all about the same IP address. Is there an easier way to do this? And the answer is yes. You can define a variable, and this is a variable block. So it starts with the word variable, and then there is a local name, a name for the variable that you can use, and it is only significant within your configuration. Then I can assign it a value. So 118.10.10.118/32, which is exactly the same that I have been using multiple times in my code. All right. So now I'm going to have the same security group, and instead of writing the value, this value as I did here every time, I'm going to reference the variable, and the referencing happens by using var dot or variable dot and then the local name. So var only, not the entire thing, the first 3 letters, dot the local name, and I'm going to use it in the 5, 6, 7, 8, or 9 rules that I have. If for any reason I want to change the IP address, then in this case, without variables, I have to go in every one of the 9 statements, and I have to delete this IP address and then put in the new one. Whereas in this case, all I need to do is I need to change it only once here, and all the 9 references are going to be assigned the new value. So this explains to you the concept of the box that we are talking about, that whatever you put inside the box, any reference to the box is going to have that value. So the way we define the variable block, as we have seen, is variable. This is always the same name in any variable definition. And then a local name, which you cannot have more than once in a configuration file. So if you need to define another block, it has to have a different local name. Then you have the option to do a default value, and any reference to that is going to use the value defined here in this case. And how do we reference it? var variable dot and then the local name. That's how it works all the time. So let's look at the variable assignment approaches. We have different ways to assign variables static values. And this is what we're going to look at, and we'll look at if we have used different variable assignment approaches, which one will have priority or precedence over the others. We can assign variables or static values to variables in many different ways, including command line flags. So when doing the Terraform apply, we can pass the variable values in the command. So we can use the -var equals. This is fixed all the time if you want to pass a static value for a variable. Then you need to define what is the local name of the variable. So it has to be in the configuration files. For example, variable, then image underscore ID. And then the static value. So this is your static value, and this is your variable name that you have configured. And this way, Terraform is going to take this value as a value for, or a static value for, the image underscore ID, and that will replace any encounter where the image underscore ID is used. Then we can use it from a custom.tfvars file. This is a new file type or extension that we are talking about right now. And why are we saying a custom? So the name can be anything you choose. For example, I have here testing.tfvars file, and it can be that the image ID value is such and such, and availability zone names are US East 1 and US East 2. This is just an example. Don't worry much about the construction of the file. We are going to look at this later on. In that case, how can I instruct Terraform to look at that and find the variable static values? Then again, we do the -var, but then -file appended to it. So this means I am dealing with a variables file, and this means I'm assigning one value for a variable. By the way, any variable file can have multiple variables. It doesn't have to be only one. And then between quotes, I do the testing.tfvars, which is the name of the file. And also here, when we assigned this, we used the double quotes. So don't forget that, please. Then we can do it also from a terraform.tfvars file. And in this case, it's going to be automatic. I don't need to do the -var -file at all, because this is the only name that will be searched automatically if available for variable static values. So in this case, I'm going to use Terraform apply without any -var -file or anything. Also, we can assign static values to the variables using environment variables. Remember when we did the tf log, we do the export for Mac and Linux, and we do the set command if it was Windows, and then we do the tf_var_. So this is, or this has to be in this format, and then the name, the local name of the variable, and the static value you'd like to assign to it. We can also do it from the variable defaults. When you define the variable, you have the local name, then you can write a default equals, and then what's the default value. And we can do it using the command line interface as we have seen here. So if I have defined a variable with all of these different methods, which one will take precedence? Which one Terraform will trust more? Which one will Terraform choose to take it as the most trusted static value for the variable and will be used to replace any reference to the variable within the configuration? This is very important to know. Okay, if we have the variable defined through environment variables, if present, that will be the least important one or the last one to look at. Then if we have the terraform.tf vars, this one, so the number on the left means higher precedence. If it is present, then this is going to be taken. And remember that the terraform.tf vars is searched automatically for the variable assignment. Then if we have a terraform.tf vars.json file, if present, then any o2.tf vars or o2.tf vars.json are processed in alphabetical or lexical orders, depending on the file name, alphabetical order. Then what is higher precedence is any -var or -var file, which means this is something that you are declaring in the command line. This is going to be a higher precedence one. What if none of these? So this is going to be the first priority, second priority, third priority, fourth priority, fifth priority. So this is the least and this is the highest, just to reiterate and you don't get confused. If none of these is present, then it will look at the variable defaults that are defined within the variable block. If present, what if it doesn't exist in any of these and not in the default? Then you will be prompted to enter it while you are doing the Terraform apply. So it will find that there is a variable with no static values and it will ask you to assign the static value for it. Now we have the main configuration file, and then we can configure variables in a file, and then we have tf-vars file. What is the best practice? As a practitioner using Terraform, should I just put everything as default variables, or should I put everything as .tf-vars? What do I do? And the answer is, please make sure that you use the tf-vars and use variables, and in the main configuration file you don't add any static values. So here, for example, we have the cider var and then admin_ip. Of course, these are static values. This is static value, this is static value, but we did not want this to be complicated. We just took one example of how you should think about converting everything into variables. So we have the cider block var, which is a reference to a variable, and then the name is admin_ip. So this is the main configuration file. Where do I define the variable admin.ib? And that you can define it in a variables.tf file. So here I have a variable admin_ip, and then don't assign values here. Then we assign the values inside the .tf-vars file. It can be the terraform.tf-vars if you don't want to worry about providing that in every Terraform apply as a -var-file equals and the file name. And then inside the tf-vars file, I can take the local name of the variable and then assign it the corresponding static value. And here, since I'm using tf-vars, I can have multiple tf-vars, one, for example, for development, one for production, and here I define different static values in the tf-vars, and it's going to be the fact that the main configuration is going to be the same for all environments, for production, for dev, for testing, for pre-production, and so on. The variables tf file is going to be exactly the same, and the only difference will be in the tf-vars files. So I can create multiple versions. Each one of them is going to be for one of the environments. And that way you can reuse your code, and the only differences are going to be in the .tf-vars files. If you didn't do this, then you should have created multiple variables.tf files. You cannot reuse the variables.tf files, and that would have made it less reusable. But now it's only the static values files that will change or will have multiple versions from. All right, so let's do some hands-on on variables to understand the different ways to assign static values to the variables and also the precedence they take if we have more than one used. So let's move to our VS Code. All right, let's see what do we have. So I have a main configuration file. This is about demoing how we can assign static values to variables, and also we're going to demonstrate the different ways we can do this. Okay, what's the resource? We are trying to create a security group, AWS security group, and the name, local name, choose whichever name you like. And then here's the name of the security group and a description, testing variables in Terraform. Then we have ingress rule called allow TLS IPv4. And this is the reference, or that's the implicit dependency on the security group. So it's AWS security group dot variable underscore demo, variables underscore demo dot ID. And here for the CIDR block, I'm going to use a variable, and the variable is defined inside the variables.tf file. So this is the variable, and the comment here, this is as if I don't have this at all. Because, you know, the comment means Terraform, please treat this as text, description, whatever. Don't even try to look at what is included. All right? So that's where the variable is defined, the variable and then the local name of the variable. How do I reference that? Var dot and then the local name, which is admin underscore IP. Don't worry about the ports and TCP. I know these are static values, but we are going just to take one to learn how to use it. We don't want to have many and then we get confused. Then I have another AWS VPC security group ingress rule. Again, the same security group. And again, the same reference to the same IP address. And this is port 80. So this is TLS. This is for HTTP. And then I have a third one for SSH, as you can see. And again, all of them are referencing the same static value for the same variable, which is var.admin underscore IP. All right. What do I need to do now? I need to run this, and then we need to assign the variable static value in different ways. So once we are going to use the default, and we are also going to use the terraform.tf vars, and that is going to be the one that will be inspected automatically, the only TF vars file that will be inspected automatically. And as you notice here, we have an IP address 200.10. In the default, we have 118.10. And then we have a dolphined.tf vars. That is a custom TF vars file. And then we have a completely different value. We are going to implement it when we have multiple ones. And then we are going to see which one will take precedence over the others. And of course, I have the providers, US East 1 and the profile. These are the 4 files or 5 files that we have right now. All right. So this is the variable. Please note that when you have TF vars, how you allocate how you define the variable, you use the local name and not the variable.local name. Like here, it's admin underscore IP without the quotes, and then the value you are going to assign to it. Here, same thing, admin underscore IP. So we take this part without the quotes, and this is what we assign values in the TF vars files. All right. If we have everything like this, so default, and this is also commented, here it's commented, and here it's commented. So basically, I don't have the variable defined anywhere right now based on the comments we have. So we don't have a static value allocated to the variable anywhere. Let's see how Terraform is going to behave. So let me initialize. And after we initialize, we'll try to do an apply and see. Without any static allocation for the variable, what is going to be the response from Terraform? All right, so let me clear. All right, so it looks like we have everything now in place. So let's go ahead and do a Terraform apply with auto approve and see what will happen given that we have not assigned a static value to the variable in any way possible. So see here, it's asking me, I need a static value that will correspond to var.admin underscore IP. And we are going to go ahead and let's say assign it a 2.2.2.2/32. Right. Creating security group. Okay, so here's invalid group duplicates. The security group dolphined variables already exists for this VPC. So let me go up and change the name here and put _1, for example. And let's repeat the command again. So let's do the same 2.2.2.2/32. And let's see if it works, and it will create the security group this time. It looks like it's working. It has created 4 resources, 3 rules, and the security group. So let's go back to the console quickly and find out if this one exists. So here, and then just refresh. And we do have one here, $_variables. And if you look at the inbound rules, we have the SSH 80 and 443 from 2.2.2.2/32. So that's step number 1. So let me do a clear, and then I will get here and then allow the default to kick in. So let's see if it will ask me or if it will go ahead and do it without asking me. So now it is doing changes. Okay, so as you can see, the 3 of them have changed. And if we want to check in the console to see what are these IP addresses, here's $variables. And now you can see that the value is 118.10.10.10, which is the value right here. Okay, let's open another source. Let's open the terraform.tfvars and find out which one will have higher precedence. So I'm going to save, apply again. So now I have the default and I have the terraform.tfvars. It's going ahead and changing stuff again, and again 3 changed. And if I refresh here and look again at the same security group, you'll find that the value now is 200.10, which means the TFVARs takes precedence over the default. All right, so let's look at another way of doing this, which is I'm going to unmark or uncomment this one. And we have a command that we can use for this, which is providing the name of the file when we are creating that. So let me do a clear. I'm going to paste, but the name is not testing. The name is dolphin_ed. So dolphin_ed. So that's the name of this file here. And I'm going to apply. It will ask me because I did not have the auto approve. That's okay. Yes. And the value in the TFVARs, as you can see, it's 30.40. So let's go ahead and check that. Let me go back and then get into this one. And you'll see now that the 30.40 is the one that takes precedence in this case. Then we have the last method of trying this, which is using the export TFVAR here. So what I will do is I'm going to take this part and let's clear now. I'm going to export, but the name is not image ID. The name is admin_IP. So what I'll do is I'm going to assign it, let's say 5.5.5.5/32. All right, so let's do a Terraform apply and see which one is going to kick in right now. Let's do with O2 approve. So 0 changed, which means it's not of a high precedence. So which one was taken? Let's look at the TF state. That's another way we can look at it. And you can see here, it still has the 30.40.50.60 as the value allowed. Okay, so let me comment this one. So now we're doing the reverse to find out where it's going to take the 5.5.5.5. Okay, let's now go ahead and do a Terraform apply auto approve after we commented this one and see which one will kick in now. So there are changes happening, and as you can see here, it will take the 200.10.10, and that's the one in the TFVARs. So let me comment this one and then repeat the same command again. So what's the value now? It's going to take the environment variables. So it's the custom TF vars, and then the automatic TF vars, and then the environment variables. And now if I unset the environment variables, so this one, I'm going to unset it now. We need to remove this when we unset it. Okay, so now it's unset. If I run again the Terraform apply, which one do you think it will take? So it will take the 118.10.10.10, which is the one in the variables file. If I comment this one, then now it doesn't have any source to get that information, but ask me again on this. So Terraform, apply auto approve. Now it will get back to asking me for the value. So I'm going to abort, and I will do a Terraform destroy, because now we have done what we wanted to do here. Variable, oh, we could have done also a different way. So let's say 1.1.1.1/32 for the destroy, and it should be happy. Okay, so we can also do the Terraform apply, and then we pass the variable itself as part of the apply. So let's go ahead and do this. So let's do this command. I'm going to copy this, and then we can state here that admin underscore IP equals, and don't forget the code, and this is going to be, let's say, 8.8.8.8/32, and then we close the code. So if I do yes, it's going to be quick. And if we look in the TF state file, we will see that it's 8.8.8.8. All right, so hopefully you get the point, and I think it's very simple to remember. And destroy it. And that's it. So let's find out how we can improve and enhance our code when we deal with Terraform even much better, and also how we can allow reuse, portability, easier troubleshooting, which are all advantages that we all need when we deal with scripting or coding. We will discuss Terraform modules and workspaces in this section. So let's start with Terraform modules. Let's see without Terraform modules what we have been doing so far. We used to build a configuration file, we used variables, we used locals, and we learned how we can use the count, the for each, dynamic blocks to enhance and have a cleaner code or a cleaner script. Now, let's take that to the real world. In the real world, there will be a team collaborating, working on Terraform. Or there could be, if it is a big organization, there could be different teams working on Terraform separately. How can we get them to reuse their code instead of having each one of them do their own code? So let's first look at without Terraform modules. What will happen if we have multiple teams? So let's say we have a DevOps team, we have an SRE, an Ops team, we have a developers team. And these separately are going to be working on Terraform. The disadvantages are there will be a lot of repetition of code. Everyone has created security groups. Everyone has created code for VPCs, for EC2 instances, NAT gateways, load balancers, and so on. So there is a lot of repetitive effort across the teams. And when a specific provider syntax changes, or maybe a feature is added, now to adopt that or to make the changes, then all the teams, they have to do changes across all the code. Otherwise, they will get errors when they try to apply it. And if everyone is working on their own, it's very hard to standardize. Some will be using T2 micro instance, some will be using T2 large, some will be using security groups with specific ports or with 0.0.0.0. Some will be doing different things, and then we cannot have a standard across the different teams for the corporate. And if standardization cannot be adopted enough, then code reusing is going also to be difficult, because I am from, let's say, the SRE DevOps team. For me to reuse the code from the DevOps team or from the developers team, I will have to go through it very carefully, study it, maybe have a couple of meetings with them to understand how they do it. And then maybe I will agree or disagree. Maybe parts of the code I will say, no, this is not how we do it. Then I'm going to just leave their code alone, and I'm going to go back to my team, and we will continue to build it the way we like it. Could be wrong, could be right, but it's our way and their way now. And if that's the case, then also collaboration across the teams when we have a problem and I would like to troubleshoot it. I'm not going to bring someone who doesn't know anything about our code when we have an urgent situation, and then I will expect him or her to go through 300, 400 lines of code to figure out what we are trying to do, and then to start help us to troubleshoot. So standardization would help in both of these. So now, if we bring in the Terraform modules into the story, then we need to understand what Terraform modules are. Terraform modules are simply containers for multiple resources that are used together. So a single module is a set of configuration, and it can be a .tf, one or more files, or a .tf.json files kept together in a single directory. That would bring us to something that we know. We know that the root module, or the main module that we used to deal with, that had a lot of files, .tf or .tf JSON, and maybe .tf vars files, and all of them are kept in one directory, and that's what we have been doing throughout all the previous videos, right? So we know what a directory is, and we know what a module is. But now we are talking about having multiple modules and not only the root modules. So modules are a main way or a main method that we can use in order to package the script or the configurations in Terraform and to allow that to be reused across the different teams. And we can reference these modules in our code, and it can be used in multiple code parts. So here's an example. So I could build my EC2 configurations in a module in a specific folder that has to do with EC2. So EC2.tf and variables.tf. Maybe I have also variables.tf vars or terraform.tf vars that is specific to EC2. So all this module does is about creating EC2 instances. Then I can have another one for security groups. I can have a third one for VPCF, a fourth one for database, and so on. So I can have that. In Terraform, we have two types of modules. We have modules that are loaded from your machine, your laptop that has Terraform installed, or this is the Terraform machine, and these are called local modules. And also the modules can be loaded from a remote source, from S3, from GitHub, and so on. For the remote sources, it supports a variety of sources, including Terraform registry, we'll discuss that later on, most version control systems, Git, GitHub, Bitbucket, and so on. HTTP URL, so it could be on an HTTP endpoint. HCP, the HashiCorp Cloud Platform, or the Terraform Enterprise Private Module Registries, which is basically a private implementation of Terraform in the enterprise, and then we can have private registries. We are going to focus now on local modules. And if you'd like to find out a list of the available sources for the remote modules, you can reference this link, but we are not going to discuss remote sources now, so I'm going to leave it aside. So we are going to focus on when you have the modules on your laptop that has Terraform, where you do the scripts and where you do the Terraform init and Terraform plan and Terraform apply. This is what we are going to focus on right now. So what we have been dealing with all the previous videos is called the root module. So this is where we had our configuration file and maybe the provider.tf file, and then the variables, if any, and so on. This is what we used to do all the time. So if we look at this hierarchy, then project 1 is the root module for these Terraform files. So that's a directory that has all of them. Now one might think, okay, but here's a directory. No, this is already initialized. So this is the .terraform where the plugins are downloaded. Okay, so project 1 in this case is the root or the main module if you wish. Now, if you create other modules, they're not going to be in the root module. They're going to be in what we call child modules. So we have the main configuration calling other modules. The main configuration will be the root. The others are going to be called the child modules. any module that is called within the root module is called or is labeled a child module. So for example, here I have a folder called modules. Underneath, I have a folder called EC2, a folder called security group, a folder called VPC, a folder called databases, and so on. So each one of these, if referenced in the main module or in the root module, these are called child modules. How can I use a child module inside the main module? So this is a snippet from the main.tf file in this directory. The snippet to call a module is going to start with a module block, curly braces, and then a local name. So this name is only significant in the main or the root module. Then I have to identify where to get that from. So that's the source for that module is, and in this case, that means as if I'm doing cd dot twice, or moving up 2 steps in the file system. So now once we have Terraform implemented, that's very good news. Now we have no repetition of code. Hopefully that across the enterprise, the different teams are going to sit together, or maybe the team entitled to be the automation and scripting team or the infrastructure as code team, they are going to be the ones who are going to build these modules, and they are going to provide the links or the URLs on how to get them, how to use them to the rest of the team. Now we have no repetition of code. Now we have consistency, and also best practices including standardization can be met, and we're going to be able to reuse the code across the different teams because it's only one format, it's only one template, it's only one way of using Terraform. And also that can help us later on to provide self-service. So basically have the developers and have other team members who know nothing about Terraform use these modules just by the source URLs that we are providing. And there will be less errors and also less cost, because now I have one team focused building and then a lot of reuse. So we're saving on time to build the configurations, which means we're going to save on costs, because time by people is money, right? These are salaries that are paid. And now they can focus on doing other things that are more important, or maybe build more modules. And also whenever there is a provider change, syntax change, or whatever needs to be done, that changes are going to be done in a central place, in one place. So hopefully that is clear. All right, so let's look at how we can call child modules within the root module. Whenever you call a module from within a different module, so the calling module is the root or the main, and then the called one is called the child. In Terraform, to call a module means to include the contents of that module into a configuration in another module. And of course, if the child module or if the called module, the one that we are calling, has input variables, there is a chance or there is a way that we can supply input variables as well when calling the child modules. So these are going to be values for the variables in the child module. And here's an example. When we call a module, we call it within a module block. So the module block starts with the keyword module and then a local name that has only local significance within the module. We need to specify the source, and the source can be a local source for the local modules, or it can be a remote source when we are talking about Terraform registry or version control or HTTP endpoint and so on. So the source argument is one that we can use, and here we are referring to a directory that is down or one step deeper into the current directory. So a directory from the current directory. Then this is a keyword servers. This is an input variable for a variable called servers that is going to be in the child module, and we are assigning a value to it here. Modules allow you to use the following arguments. So source is one, then we have version, and this is in case if we are calling a remote module from a registry or so on, like this example. So we have here a module, and the module is called not from the local file system, It is from the internet, HashiCorp console AWS, and then we can put a version constraint if we are doing this. The version keyword is not used with local modules. Then we have some meta arguments like the count. We have looked at it before, the for each. Providers, if you would like to pass the provider values to the child module. If you don't, then the child module is going to inherit the main module or the root module providers. And then we can do explicit dependencies using the depends on argument. Now, if I was creating an EC2 instance from a child module, would I be able to put the AMI argument or the other arguments that we have seen in the EC2 or AWS instance resource? And the answer is no. This is a module block, not an EC2 instance resource block. So you have to follow what is defined in the child module, and the input variables or the input values, they need to be for variables that exist in the child module. So it's not up to you anymore. You're following what is in the module. And if we look at the modules block to get a better insight, let's go ahead and check this link. So as you can see here, we have the syntax for the module blocks, how it would be. Let me just maximize this a little bit. Yeah, resize it. Okay, I think resizing is better. So here I'm calling a child module, and we have this example that we looked at. And as we said, that we can pass the input variables, the value for the input variables that exist in the child module. Here are the keywords or the arguments we can use: source, version, and then we have the meta arguments as we discussed before. And also we can provide arguments to the input variables defined by the child module. The source, and then when we look at the version, we discussed that, and the meta arguments allowed are count, for each, providers, and depends on. Now let's look at a local path example. So here we have a folder, level 0. Underneath we have two directories. Please look at the indentation. So level 1 and security modules are at the same level of indentation, if you agree with me. Then under level 1, we have a directory called EC2_module1. And we have a directory as well called root module. Under the root module, we have the main configuration.tf and the provider.tf. And we have a subdirectory under the root module called EC2_module_2. And with level 1 at the same level, we have another directory called security modules, under which I have two subdirectories called NACL, network ACL module, and security group module. Let's look at operating system key references that we can use that will help us define the path from the main module, from the root module to the others. So if we use ... and a /, this refers to the parent of the current directory. So for example, if from the root module, which is right here, if I would like to go to level 1, then if I type ... and / without a space in between, this is equivalent to me typing cd ... and then the /. And this is true for PowerShell, for Windows Command Prompt, and for Linux and for Mac OS. So this is across all operating systems. So if I want from the root module to go to EC2_module_1, so root module to EC2_module_1, then I have to do ... /, which means going one level up, going to the parent directory. Then if you want to get to the EC2 module, then after that I can write the name EC2 module here, and that's it. This is where the directory lies. So this is how to get to the directory, not to the files within the directory, just the directory. And here's how this is written. All right, so what about ... and a /? What's the difference between this and this? Big difference. If I do ... and /, that means the directory where I am right now. If I add any name afterwards, that means a subdirectory within the directory. So let's take an example. If I want to go from the root module, which is right here, to the EC2 underscore module underscore 2, which is a subdirectory within the same directory. How would I type that? How would I write that? Then I can do dot / and the name of the subdirectory. So this is equivalent as if I typed cd dot / and the name of the subdirectory. That's exactly the same. But if I did this only, that means the current directory. So if I wanted to reference this main.tf, then all I need here is to write main.tf. So this is referencing the main.tf on the same directory because it has an extension. But if it was only the name like here, that means a directory or a subdirectory. What if I want to get from the root module into level 0, for example? Then what do? You can do the .. That means take me from the root module to level 1 and then from level 1 to level 0. Now, if I want to get or to know how to get to the directory called security group module from the root module, then I have to do one step up, another step up. Then now I'm at level 0. Level 0 includes level 1 and it includes the security modules. So now I need to do a / to security modules and then another / to get to security underscore group underscore module. And this is how it is written. One level up, one level up. Then I have a folder called security underscore modules. Then the folder exists within that one. So that's why I have a / to security modules and then a / to security group modules. Let's look at how we can call child modules using these references that we have just looked at. How can I call child modules within the main module? So assume that these are snippets of the configuration in a root module, all of them. What do you want to do? So in the first one, I have a module that creates an EC2 instance called EC2 underscore module underscore 1. And on the left-hand side, if you see, I have expanded this so you can see what is inside. I have an ec2.tf file that's a Terraform file inside this module. But when we reference the modules and not the specific file within. Why? Because I could here have multiple files. A file for the main configuration of the child module, and then another one for the variables, and then maybe another one for the TF vars. So I refer to the module, I reference the module, and I don't reference, so basically the directory and not the files within. Please keep that in mind. So if I want from the root module, which is right here, so this is my starting point, the root module. So I am at the main.tf file here, and these are snippet from the main.tf. So this is where I am referencing. That's the start of the referencing point or the referencing path or the local path if you would like to call it. So from here, what do I need to do? I need to get to the EC2 underscore module underscore 1. So if you look at this, the main.tf and the providers are under the root module. So I need to get one level up to level 1. And this is where I find the EC2 module, if you agree with me. How do we do this? .. and then the name of the module. Done. So this is a second module block, and I can have multiple module blocks in my configuration. There could be multiple configurations calling the same module at the same time. So this works without any issues. So I have created an EC2 instance using the ec2.tf file here. All right. For some reason, I would like to create another EC2 instance, but in this time, it is from the EC2 underscore module underscore 2. If you look at the file system or the file system snippet here, we have the root module, and underneath it, we have the subdirectory EC2 underscore module underscore 2. So now I would like to reference the source as from the current directory. I'm going to get to EC2 underscore module underscore 2. And that's why I have only a single dot, which means the current directory, and that's a subdirectory under the current directory. So what is under module 2? If you look here, if I expanded that, then we have another file called ec2.tf, but it's not the same. This is creating an instance, a specific instance size, and this is a different configuration. We will look at that. All right. What if I need to reference this file, security group.tf, which creates security groups? And this is under this child module, which is called sec_grp for group and underscore module. So how can I get from the root module to this module? Easy. I mean, we know how it works. So root module, // that's one level up, // that is a second level up. So now I am 2 levels up. And by the way, I can go 3, 4, 5 levels up if I want by using // for each level up. Then once I get to level 0, then level 0 includes level 1 and security modules. So now I need a / into security modules. And this is a subdirectory under security modules. So another / into this folder. And here it is. Source equals double quotes. And then one level up, forward into this directory, and then forward into this subdirectory. All right, I think this is getting clearer now. Please remember, when you have a module block, the input or the arguments you can have here are very limited. And the input variable values that you can include here, they must exist in variables in the child module. And it's not up to you to decide the arguments from the AWS resources we have looked at before and put them here. You will get an error because this is not expected and is not known, basically. I can have the same module called in multiple module blocks. If you would like to repeat the same module block multiple times, you can use the count, you can use the for each, and I can have multiple module blocks depending on how many child modules I'm calling. All right, so let's do a hands-on lab and understand modules, referencing, calling child modules, and all the stuff that we have discussed. So let's go ahead and do this. Here we go. We have this setup, or this mini file system, I would say, where we have a directory called level 1, and then another one that maps to it, same level, called security modules. All right, and both are under level 0. Level 1 and security modules are under level 0. So level 0 is a parent directory to level 1 and to security modules. All right, let's expand level 1 and let's collapse all of these for now. All right, so under level 1, I have a folder called root module and a folder called ec2 underscore module underscore 1. The ec2 underscore module 1 has a Terraform file called ec2.tf. What does it do? Nothing special. It creates a resource of type AWS instance called myec2 underscore nano. And it has an AMI and it has an instance type. That's it? Yes, that's it. So it's called nano because the instance size is nano. All right, that's easy. And here is the root module. This is the main configuration module that we have. And the root module has a file called main.tf and a providers.tf. So this is my root module that I'm going to be using, and it has a subdirectory called ec2 underscore module underscore 2. If you look at this subdirectory, it has an ec2.tf, a Terraform configuration file to create an ec2 instance. If you click on that, it has nothing special. It's an ec2 instance with an AMI, but here the size is T2 micro and the local name is myec2 underscore micro. So nothing special, but it's going to have a different configuration because of the size than the one that we have seen here. This is a nano, whereas this one is a micro. All right, so let me collapse these directories again. So I am at the root module right now, and I have the main.tf and the providers. And the provider, we know this is the region where I want these to be created, and the dev underscore and the admin, the profile for authentication and authorization. And please make sure that the AMI, if you change the region, the AMI here and the AMI here, which is the same, exists in your region. So that's very important. Otherwise, you'll get errors if you change the region without selecting or replacing the AMI with the right one. All right, so that's all easy until now. What is the security modules? I have only a pencil in, a placeholder for a network ACL module that I have not created yet. And I have another one for security group module. And this is a Terraform file. And if you look at it, what it does is let's go through the resource first. So the resource is an AWS security group with the name app SG, app security group. And here's the name that will appear on AWS, my app-sg. And then this is written in the old way. The ingress description, allow inbound to my application. What do you allow? Port 80, protocol TCP from anywhere. And on the egress, allow all ports, all traffic to all destinations. All right. This could be any different resource. It could be even written in the new way that wouldn't make a difference to us now. I'm just showing that we have modules, different configurations for EC2 and one for security group. I could have other modules and other folders for VPC and for database and for load balancers and so on. But this is enough to show what we are trying to do. So now we know what are the modules that are available. The security group module, and then I have the EC2 underscore module 1 and the EC2 underscore module 2. Great. Let's go and look at the main.tf file. So the main.tf, the requirement is I want to create one EC2 instance using the EC2 underscore module 1, which creates a T2 nano instance. All right, what else? I need to create another instance, but this is going to be the T2 micro using the module that is right here. And then I need a third module that is going to create a security group module. Let's look at the referencing using the dots and forward slash and all that. So if I would like to get to create one from the EC2 underscore module 1, this is the main.tf. So everything has to be referenced to the root module as a directory. That's the reference. So now I am within the root module directory. I would like to get to the EC2 underscore module. How do I get there? From the root module, I have to do one level up to level 1, and then forward slash the EC2 underscore module 1. And that's why we did the one level up, and then the forward slash, and then I have the module I would like to get to. How about the other one? The other one is a subdirectory under the root module. So how do I get there? My starting point is going to be from the root module. So that's the current module. And then it's a subdirectory under the current module. How do I get to this module here? Easy. I need from the root module to do one level up to level 1, another one level up to level 0. I can go one forward to security modules and then another one forward to security group modules. So one level up here, and then another level up here, and then I'm going to go forward into the security modules, which is this one, and then I'm going to go into the subdirectory, which is this one. I think it's clear, easy. Let's go ahead and save and do a Terraform initialize. So as you can see here, it's initializing EC2 module underscore 1, which exists in this path. And it's initializing EC2 underscore module 2, which is in this path. And then the security group module, which exists in one up, and this path. Please remember that we are referencing the directories. The child module is a directory. I don't care whether it has one file, 10 files, it's a directory. So I should be referencing the module as the directory. The root module to us has 2 TF files. We're not talking about a file, we're talking about a directory. And then it downloaded the AWS plugin because I have the providers right here. That's why it downloaded it. I should be ready to go. So let's do a Terraform plan and see what is the plan. If we go up, we have 3 resources to add. That's correct. I have 2 EC2 instances and 1 security group. So let's have a look at them. So here's my command, Terraform plan. The plan is to create. Then I have 1 instance that will be from module EC2 module underscore 1 dot AWS instance dot my EC2 nano. Look at the path. So the module and then the module name and then dot AWS instance, which is in this file. If you look at it here, AWS instance.myEC2 nano, and the word module and the EC2 module underscore 1, which is the local name that I had here. So I had module dot ec2 module underscore 1 dot aws underscore instance dot, and then the name from that module. I think it's kind of clear. All right, and then I have the nano, which is correct. And of course, the AMI will be mentioned here. Then if I go down, I have the other instance, which is micro. And now it is module dot ec2 module underscore 2, which is coming from here. Module dot ec2 module underscore 2 dot aws underscore instance dot, and then the name my ec2 micro. All right, so here is the name for the second one, and it's correct that the T2 micro. If you look at the security group resource, so module dot sg module security group module dot aws security group dot app sg, and then we have the ports and all that will be configured. So if I do a clear and then I do a Terraform apply, let's see if this one is going to work or if we are going to have problems. And as you can see, it's creating the instance, creating the security group, and now I'm quite some time into it, so everything is working fine. It's just a matter of time, and it will give me the okay that the resources have been created without any issues. Right? So let me now go back to the main. Also, let's say I wanted 3 of this one, not only 1. So I can do count equals 3, and I can do here count equals 2, and then let's do a Control S, and I'm going to do a Terraform plan and see what happens. See, it's going to create 5, and there will be 2 that are going to be destroyed. So it will create the 3 and the 2, but it will destroy the previous ones and create new ones. All right, so let me do one thing. What if I think, you know what, this is an EC2 configuration, so why don't I just go here and state instance type, which is known to be an EC2 instance argument, and then I can have here, and I say, let's do a T2 large, for example. What will be the behavior if I'm calling a module that will create an EC2 instance 100%, but now I try to mix the arguments from the resource of the EC2 instance, which are not supported under the module? What will be the response from Terraform? So let me do a Terraform plan. And you'll start to get errors because this is not expected to be here. This is not supported. So this confirms what we mentioned, that it's not up to you anymore within the module to mix and match, call the module and then assign arguments for the resource that are not supported by the module block. So what you are allowed here to do is, if the module had input variables, then you can assign values, and for that you have to follow the same name of the variable that is in the child module. So as if we are saying that now the module has the upper hands, and whatever variable names that are configured within the module, these are the ones that you can configure here and you assign values. And then you have the version if the module was from a registry, not from a local path. And then you have the for each, and you have the depends on. That's it. So when you are calling the module, basically you are submitting to what is configured inside the module, and the maximum you can do that relates to the module would be to allocate or assign the input variable values, and that's it. All right, so that's enough. Let me go ahead and destroy the resources, and we are good to go. Let me do an auto approve as well, so I don't have to wait for a long time. All right, so we are good to go. All right, hopefully you have found this course beneficial, and it has introduced you into what Terraform is and the magic of Terraform, and also the ease of learning and the ease of use of Terraform to automate a lot of stuff that could be cumbersome or error prone or it's time consuming to build infrastructures and to tear them down. And you have seen the beauty of having a file that will have all your configuration. So you can have that file on an S3 bucket or on GitHub or in the cloud. And no matter where you are, you can just pull that one and apply it. Now, if you loved Terraform as I do, and if you'd like to dive deeper into Terraform, and if you like to have a structured course that has quizzes, assignments, and a student guide, and also to dive deeper into a lot of important Terraform concepts like locals, which is a different type of variables, or to understand how you can apply loops, and dive deeper into the use of modules, and do projects using Terraform, capstone projects that you can highlight in your profile or in GitHub. And also, if you'd like to know a lot more about Terraform and more hands-on labs with a student guide, all of that is available in a ready course that is available to you to consume. And the details are in the description box with a sweet discount for anyone who would like to enroll. If you are satisfied with what you are learned, then thank you so much for watching. But if you would like to use Terraform like a pro, look at this course. Please, before you go, consider subscribing to the channel if you haven't done so. Activate the notifications to receive notifications about videos like this one that are so beneficial in technologies and tools that are hot skills that you can learn. And if you have benefited from the course, please do not forget to give us a like and share so the video can reach more people and benefit them as well. Thank you so much again for watching, and I'll see you in the next video. Ciao.